Oh, no. 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 All right, I'm going to play this YouTube video by a couple former NASA employees. One of them is an actual PhD scientist and foremost expert in electrostatics, and the other's a propulsion engineer. One of them is still at NASA, the other retired. The one still at NASA is about to retire. And they've been working on alternate forms of propulsion, which they colloquially call anti-gravity, but when you hear them and what they're describing, it's all electrical. So check this out.
All right, gentlemen, thank you for coming. You guys are some real deal scientists making it over here to the West Coast. Sorry?
He's a scientist. I'm an engineer.
Oh, scientist
Huge
and
difference.
engineer. Okay.
Huge.
Cool. You guys figured out a new kind of propulsion that doesn't use fuel. Is that correct?
That is correct.
That's correct.
And you guys are right over on the east coast of Florida, in Cocoa-Titusville area.
That's
yeah,
right.
we both came from the space program, the Kennedy Space Center. He was on the NASA side,
Okay.
the dark side, and I was
The
on
dark side.
I was on the contractor side.
Okay. Why don't we, for folks that are listening, break down, who you guys are and what your backgrounds are. You want to go first, Charles?
Yeah, sure. Dr. Charles Bueller, the lead scientist of the Electrostatics and Surface Physics Laboratory, NASA Kennedy Space Center. I've been at the Space Center since 2000, on and off. I did a 10-year stint as a consultant for ExxonMobil and then came back to NASA about 7-8 years ago. But I have a research lab, about 10 of us in the lab that I run there. In my time off from NASA, we discovered this phenomenon, this effect. So we've been working this effect together since 2016.
So you're actually employed by NASA.
I am a federal civil servant. Yes.
Are they okay with you doing all these public talks about?
Are absolutely allowed to if you let them know ahead of time. Yes.
Oh wow. Okay.
Yes.
And you were involved in all kinds of like famous NASA programs, right? Like including like the space shuttle and
I worked the space shuttle,
International Space Station,
ISS, a couple of Mars programs. All of the space programs.
Okay.
At least since 2000.
Okay, cool. Yeah, I definitely would want to learn more about that stuff. And Drew?
Andrew Orajima, 40-year veteran of the space program, contractor side. Been on Space Center since 1981. Then did some, did college, and then went back out there and was continuous up until I just retired out of the space program, out of the U.S. space program. 3 weeks ago to start my own company.
Oh, congratulations.
Exodus Propulsion Technologies. And the goal was to do what NASA wasn't doing. So about 20 plus years ago, 22 years ago, looked around and said, we're never getting out of low Earth orbit. It's just the chemical rocketry is not the answer to anything, least of all getting out of orbit. So started looking at all the crazy electric propulsions that were coming out, all this stuff. Said, I got to figure it out. It's because nobody else is doing it, so I'm going to do it. About 10 years ago, 10 years, 2 months and 3 days, actually. A friend of ours, I went to him and I said, I need an electrostatics guy. I don't even know what electrostatics is, but I think I need one of those guys. And my buddy hooked me up with Dr. Charles, who was also working on this in his background. And we struck magic since then. Now we have a fully functional electrostatic propulsion system that requires no fuel, no propellant, no oxidizers. It is literally latching onto space and pulling itself forwards.
It's latching onto space and pulling itself forward. Okay.
Something like that. I'm saying I say one thing, he says another, but
so
nobody understands what he talks about. So
is this kind of like what you hear when you hear people talking about electrogravitics or anti-gravity? I know that's kind of a fringe term, but are we in the same ballpark?
I pray we're not.
Yeah, I pray we're not too.
I don't want to be looped in with that.
Anti-gravity has picked up some really negative connotation. We call it poisoning of the well. So many
negative connotations.
Oh yeah, so many people have rushed out there and said, "Oh, I have anti-gravity. I have space drive. I have this. I have that." It's all been pretty much nothing. Most of it's atmospheric effects, but we literally have. And I don't know if we're allowed to say Star Trek. Are we allowed to say Star Trek? I love Star Trek. We have the Star Trek impulse engine. You put in energy, a tiny, tiny bit of energy in the form of electrostatic charge, and you are rewarded with your spaceship moving, lifting off the ground, flying through space, doing all the things that you expect a really cool Star Trek spaceship to do. At the moment, it's little, it's tiny. We brought some examples. We're looking for our first big customer who's willing to take a chance on our propulsion system by replacing all of their chemical propulsion with our electrostatic propulsion. But we have literally the Star Trek impulse engine.
Okay, so can you break this down for like a third grader? What is electrostatic propulsion and how does it work?
Oh boy. You want to get that into that right now? Okay.
Very, very, very like 90,000 foot view.
Sure. How I think it works and, have math to back it up, physics to back it up.
Mm-hmm.
It's basically a higher order expansion, if you will, term of the force of attraction that we get from Coulomb's law. So essentially Coulomb's law is attraction between two particles, right? They either attract or repel. And we have all the physics that describes that and how that's derived, how nature does that, why nature does that. This force, I believe, is manifested using an expansion of that set. So essentially, a higher order perturbation. Perturbation theory is what's used to describe all of the physics for essentially what we have in quantum electrodynamics. So what we do is we just go to a higher order perturbation and see what falls out. Now, it won't have the same strength or energy as its Coulomb counterparts, plus and minuses, attracting and repelling, but at a lower energy, but it'll have an ability to actually move as a whole together. And that kind of just falls out of the expansion of the perturbation theory. It's a very strange thing, but it was never needed. It was never necessary because no one's ever discovered this. We've known electrostatics for 150 years. We've never seen anything self-propel with just electrostatics. It's either an attracting or repelling. We've never seen both the attractor and the repeller move together in unison. So I just went back to the physics books and say, well, what is the interaction physics for that? Found out how it works in the second order, which is Coulomb's law, and then apply that to the third order. Go further. Just go further, deeper down. And when you do that, we'll use Andrew's term, you're rewarded with physics that tells you where the force comes from and how it enables and how it manifests and why it's there. It's pretty cool. And it fits our experiments too. And I did the math over my vacation last couple of weeks to kind of show that we could actually verify that with our experiments, which is really outstanding. Very excited and giddy about it. So you're the first to hear about this, but it's super cool. But that's what it is. So basically what happens is every particle interacts with another particle in the universe in quantum electrodynamics through an exchange of a virtual photon. Just consider it like I was telling him on the way over here, like a string.
Mm-hmm.
So if I had to explain it to a third grader, every particle is attached to another particle with a string.
Mm-hmm.
It can pull in tension or it can release in compression. Either way, whether it's attractive or repulsive.
Right.
We can't see these, but we know they exist in nature, and they come out and they fall out in the math, and it's very well known to science. And they have a lot of effects on their own. The strings do. These imaginary strings, these lines of force, we call them. We can't isolate them as real particles. We can't hold them in our hand and look at them under a microscope, but they're there mathematically.
Right.
They're attached to the charge, so we can't decouple them from the charge. You cannot have one or the other. You have the charge with the field, or you have the field with the charge. You can't decouple them.
Okay.
So that's basically why you can't see this virtual photon. Mathematically, it's a photon, which is a light particle. A light particle is a real particle you can hold and see and isolate.
Right.
But there are 3 virtual photons in math and one real one. One of the 3 virtual photons could be responsible for our force. So what happens in the higher order terms is these other virtual photons exist, and they give the momentum exchange with the particles without the recoil. That's what the math says. That's what falls out. So usually in second order, what happens is one particle is coming along, it releases this photon, so it recoils, and the second photon catches it, and it recoils. So like 2 ice skaters exchanging a bowling ball on an ice skating rink.
Right.
The overall system from a 1,000-foot view means momentum is conserved. Basically, what I started with is what I end with, because I've exchanged the bowling ball, I recoil, you caught the bowling ball, you recoil. So there's no net translation of those 2 charges in space. That's basically Coulomb's law. So that's why plus particles and minus particles attract, or they repel, but the whole system doesn't move as a whole. In the third order, someone gives a second bowling ball. They throw that first one to the other person, then they throw the second one somewhere else, and they don't catch the second one. So if they don't catch it and you're tethered together, you're going to move as a whole. Or if the second person has a second bowling ball, and they throw it, they're going to go somewhere else and take you with them. So that's the simple third grade analogy of momentum conservation from quantum electrodynamics, third order, time independent perturbation theory.
Whoa.
Scientist.
I don't know if that
Engineer.
made sense, but that's how I describe it.
I've heard it 50 times. I have the same look on my face as you do. Sure. What do you want me to build for you?
So, okay, how did you first come up with the idea to create this? Like, what problem did you want to solve? Did you just understand, like what you said earlier, we haven't been able to escape Earth's lower orbit, we have to figure out a new way? Because I've thought about this too. You know, it's amazing that we've come so far with technology since, you know, the Civil War shooting. We went from, you know, the 1800s during the Civil War shooting muskets to like 80 years later detonating nuclear bombs. And since then, it's like we haven't really gotten that much farther.
I agree. I have degrees in rocket propulsion in aerospace. I'm a student of Goddard, the guy who invented the liquid rocket engine. I'm a student of von Braun, the guy who perfected it. He did some bad things with it, but for the most part, no. I'm way too young for that.
I was going to say, but, you'd have been on his deathbed. You'd have been like a newborn.
I have talked to people who were his students. And by all accounts, he was a brilliant, brilliant man. Mm-hmm. I understand chemical rocketry, what you would call action-reaction rocketry, where you burn fuel and you create super hot gas and suck, squish, bang, blow, and out one end goes the hot gas and out the other end goes the rocket. This is wonderful. You can get to orbit with chemical rocketry. You can buy chemical fuels. You can do the economics of chemical rocketry are very well known. You can do all the things you want to do in orbit. You aren't getting to Mars on chemical rocketry. I know some people say they're going to do it. It's 40 or 50 launches to get enough fuel on board your ship to make the run to Mars every 22 months or some silly thing like that. But really, it's 7 years to Jupiter. It's 9 or 10 or 11 years to Saturn. These are not the realm of chemical rocketry. Is not the realm of a spacefaring civilization. I want to get out there.
Okay, hold on a second. You're the first person, like legit aerospace person I've ever heard say that.
Well, we all want. Every engineer that's ever worked on a chemical rocket wants to work on a better one.
Right. No. I understand that. But you're like the first legit aerospace person who's ever said we're not going to get to Mars with chemical rockets.
The math is ridiculous. I mean, yes, it can be done. Don't get me wrong. Anything can be done if you're bored enough and spend enough money. But you're talking 20, 30, 40, maybe 50 launches to put enough fuel, to put enough impulse into your first kick. Because once you run out of gas, your rocket's a paperweight. So if all you got is that first kick to get you out of Earth orbit or to get you away from the Earth and get you on your way, and then you got to have a braking orbit, all that requires energy. By the time you get to Mars 9 months later, because you coast for 9 months,
mm-hmm.
then you set down and your ship's empty. Okay, so you got to make more fuel, and that's just to get you back out of Mars orbit. So these are insanely complex and low yield. I mean, you might put a 1% of your initial mass on Mars, maybe less than 1%.
Yeah, is it true that like the Starship rockets from SpaceX are like 95% fuel and only like
it's probably higher than
5% payload?
It's probably higher than that.
Wow.
And that's not uncommon.
And it's very common. A typical geosync satellite, geosynchronous is about 22,000 miles up. They're the ones that kind of hang out over Denver, hang out over Florida. They rotate with the Earth. The rocket that it takes to put that up there, compared to the actual satellite that's in orbit, it's probably 95% rocket, fuel, whatever. Generally, they're thrown away. Sometimes they're reused. But the satellite is 5%.
Mm-hmm.
And when you get the satellite to where it's going, 50%, 60%, 80% of the satellite is fuel to keep it there. Because there's always little perturbations. You got to do station keeping burns. You got to do all kinds of silly things.
Yeah.
So you burn a lot of fuel and a lot of energy just to keep yourself where you should be. Well, when you're done burning your fuel, when your fuel is exhausted, and in most cases it's like monomethylhydrazine or something, when that fuel is exhausted, that's it. You get to go in what they call the graveyard orbit, which is move away from the important stuff because you're a danger at that point. You can't control yourself. And the same little perturbations are going to still happen to you. You might start drifting or sliding, whatever. We needed a better way. We need to get away from chemical rocketry into something better. And when I started, I didn't have the slightest clue. I hate electricity. It scares me to death.
Me too.
Okay?
I agree.
It terrifies me that I work on a high energy, high physics, electrostatic propulsion system that I haven't got the slightest clue how it works. That's what he's for. I don't have to know how it works. All I got to do is say, am I going to get hurt when I touch this? And then not believe him because he tends to lie.
Sometimes.
So I spent the first 10 years chasing my tail, thinking about all the different ways that people were, ion engines. And I fully understand ion engines. They're just chemical engines with a little electrostatic punch. So they get the ISP up around 3,000 or 4,000. Even that's not worthy of it. Then I found somebody who actually understood what is the only viable solution, and that is the fields that make up space. That's what we want to do, okay? I watched a lot of Star Trek. They were always doing warp and stuff. It's great. It's the greatest thing ever. So I had to find somebody that understood fields, and I did. Sadly, it was Charles, but, we make do with what we have. But now I love him like a brother. So
That'd be too, Drew.
Can we talk about the most underrated organ in your body? The liver. It's performing more than 500 functions every single day, supporting digestion, energy production, fat metabolism, vitamin storage, and processing basically everything you consume. That's why I've been using Dose for your liver. It's a clinically backed liver health supplement, but instead of another pill or powder, it's a daily 2-ounce liquid shot. It tastes just like fresh squeezed orange juice with 0 sugar, 0 junk, and 0 calories. Dose is designed to support daily liver function and aid your liver so it can process the unwanted elements so it can keep doing its job. And the science is solid. Dose has been studied in 2 double-blind, placebo-controlled studies showing a positive impact on liver enzyme levels. Ready to give your liver the support it deserves? Head on over to dosedaily.co/Danny or enter the code Danny to get 35% off your first subscription. The body does so much for you. It's time to do something for it. That's dosedaily.co/Danny for 35% off your first month subscription.
Yeah, I came at it from a different view. I think it was the early 90s, when I was going to high school and looking at rocketry and stuff. I said, rockets are cool, but I want something better. I want to see something better. I think that really got me excited was Back to the Future, seeing the hoverboards and the flying cars.
Mm-hmm.
Like, there's got to be a way to do this. I just don't know how to do it yet.
Yeah.
There's got to be a better way. And so I go through school and I go into undergrad, and then I go into grad school in physics. And I said, okay, I've understood all of physics, at least what's out there.
Mm-hmm.
What's the best path forward for that? So I guess it was around 2000, 2001. The most logical place to start for me would be the conservation of momentum from using a concept called field momentum. Now, field momentum is electric field cross product with a magnetic field, E cross B. It's kind of a strange term, electric field cross magnetic term, but that's called the Poynting vector. Essentially what that means is anytime you have an electric field and a magnetic field in the same spot, you have a momentum. See what? You have a momentum. They've known that since the 1800s, 1860s or so. And if you change that momentum, you get a force. So I said, well, why haven't people been doing this? And they have. Since the 1940s, 1950s, these E cross B thrusters. Mm-hmm. But it turns out they discovered a new momentum in the 1970s. All these momentums are being discovered, called hidden momentum. Hidden momentum is a relativistic effect. And what that is it counteracts any field momentum that you have in your system if the charges are allowed to flow. So, for example, if I tell you that any object that has an electric field and a magnetic field in it that have a non-zero cross product, basically means they're perpendicular at some point. If that exists anywhere, there's momentum. That's what science will tell you. Like, that thing's not moving. If I take a bar magnet, and I put 10,000 volts on it, you tell me that thing has momentum now? It does. Absolutely does. But it also has hidden momentum, which is a counteracting momentum due to relativistic charge moving inside the bar magnet. Oh, that's weird. So you got all these momentums. So I was like, okay, well, I got to get rid of this hidden momentum because it's killing my force that I want to make. E cross B. I want to just make an E cross B and kill it, get my force.
Yeah.
Now, you can do that in the angular case. Richard Feynman, the very famous Richard Feynman, if you've heard of him.
Oh, yeah.
He gave his students a disc. You have a Frisbee,
You get an experiment. You have a Frisbee, a disc, and you have little balls on the edges of the disc, like beads, and you charge them up. Just put some charge on them. And you put it through a solenoid. You turn on the solenoid. Nothing happens. You turn off the solenoid, the disc rotates. Where'd the momentum come from? He gave that to his graduate students as a homework problem. Sick man. But it turned out there was momentum stored in that field, that E cross B. It was non-zero. And when you shut it off, it gives a thrust. It gave a force. And that has been verified in the 70s. You can actually turn things that way using this effect. I said, well, I got to just do the linear analog to it. Not the angular, but the linear. That's where the hidden momentum came into effect. So
Interesting.
So the hidden momentum counteracts the actual effect that you would like to have in the angular case. That's not there.
Okay.
So Drew came to me in 2016 with an experiment that was working. You know, it was crude, and it was nice, but it was crude. And I thought, well, I didn't think, my wife thought, because she's the smart one.
Yes, she is.
She said, isn't that the same kind of thing you're working? Just a different flavor? I said, oh, well, that can't be. Let me go back to my lab and build something based on what she thought it was, and you know what we thought it was, and then we made that giant needle thing.
The giant needle thing
Of death.
That's the experiment that you
Giant
guys...
needle thing of
It was
death.
one of the first needle things. It moved about 3 or 4 feet in the air. It was 140,000 volts, but it was covered in tape, and it was awesome. It was like $10, $5 worth of stuff. And I looked at that and said, that sucker's moving. So from then on, I thought that the field momentum experiment was the correct one, because I have static charges now. And the Drew had a static charge experiment where there was no hidden momentum. Ooh, isn't that exciting? No hidden momentum, but it still had the field momentum, and I'm still able to change that field momentum to get my thrust.
Wow.
So I'm like, oh, we're on to it now. Woohoo. And then, you know, after 20 years working on that theory and 2 solid years, he and I working on that almost every day, it was wrong. It was just wrong.
Very wrong.
And that's how science is. You might believe something, but nature doesn't care what you believe.
Wow.
Nature has its own plans. But the reason why we went forward with it is because something was moving. So now we got to figure out what was moving. So when we took one of these forms of the Pac-Man thruster, we'll show you some of these ridiculous things, and shoved it into a vat of styrofoam, we had no more B field, which means we had no more current. So now things got very, very weird. So imagine not having any current, which means you don't have any power, because power is voltage times current.
Right.
So you're not expelling a lot of power, and you're getting thrust. So that made things very, very strange. But it made things a lot easier to build. So then I had to go back to the math. I said, well, I'll get rid of all this current. Got to get rid of all this B field out of here. And then let's see if this thing can conserve energy. So I have some math where I did some simple conservation of energy in the classical sense to see if we can at least get something out of it that we could build, something that we could just tell us what to do, based just on electric fields. And we were able to do that. And we'll show you some of those today.
Yeah. Do you want to go through we have a really quick little slideshow.
Yeah, let's see
it. Shows some of this stuff.
Fantastic.
Just go ahead and I don't know.
Which one? You want to start from the top here?
I'm no good with computers either.
Engineer that doesn't go with computers.
This is not
Imagine
order,
that.
Drew. Do you want this to be in any kind of order?
You should start with 0. Start with the first one.
Okay. Well, I'll have to rename them.
What does NASA think about you guys doing this stuff?
Start with 01. Isn't there 01?
That was it.
I don't know. I don't work for NASA.
I mean, I think they like it. We just
They think you guys are kooks, or they think you guys?
I don't know if there's any official word from NASA on this.
We have showed it to them several times.
What was their reaction?
Go away and don't bother us. Pretty
Depends
much
who you talk to.
Yeah, but pretty much it was go away because whatever you are, we don't care.
For me, NASA.
Listen, guys, we figured this out in the 50s. Leave us alone.
No, for me, NASA. We have what's called different swim lanes, if you will, at the different space centers. So each space center is allowed to work on a certain technology. And then when it gets to a certain maturity level, you have to hand it off to another space center. So that would be very disadvantageous for us to take this to our space center because we'd have to stop working on it. Yeah, and we're much more advanced.
Oh, okay.
And we'd have to hand it off to another space center.
I understand.
So we decided just to do it outside.
Right.
And just use it as an outside activity.
Exactwant. And you're having fun doing it too.
Well, yeah,
right?
I want to have fun doing it. So I don't want to be told not to do it.
Yeah.
So we just decided to keep doing.
Okay, so hold on there for a second.
Okay, you go.
Is it ready?
Yes.
Okay. I've been at this a while. That's me.
you?
That's me in '69 in front of what became Apollo 11.
Whoa.
Back then, they had a much more lenient program for Family Day. Which,
That's a cool
Where's your badge?
fucking
Where's your
photo,
badge?
man.
and I took another one 50 years later with me standing in the exact same
That's
spot
a really
with
cool
the Artemis
photo.
one. Go ahead. So I've been at this a while. That's me before Warp Drive. That's me. I used to build telescopes. I built everything you see in that picture, including the concrete that the hangar sits on.
What is that?
That is a 0.8 meter research grade telescope. I ground the lens, ground the mirrors, metallized them, built the entire structure, and worked with a team of geniuses on the guidance and control systems for it. So I was seriously into astronomy and telescopes before I jumped into Warp Drive.
Whoa.
So yeah, it's just me playing out. That's right out in front of my house. And of course, there's Dr. Charles, the smartest man in the room. And
That's a great shirt.
we love that whole ancient aliens thing and all the crazy theories. We love we live for this stuff. So that's one of our labs. Yeah. That's when we first got together. That might be in the old lab back in 2016.
Yeah, that's in Cape Canaveral. Yeah.
Yeah, that's when we first got together.
Mhm.
As always, we started with squiggle boards, what I call them, and I'd wait for him to fill up a little squiggle board with whatever he was squiggling on, and then I'd say the same words I tell him every time. What do you want me to build you? I can build anything, but I can't read his mind. So he would do some squiggles. We had our first intern. That's our first intern. Go ahead. And then that's our first test bench where we were building high voltage power supplies because, curiously enough, we couldn't buy the high voltage power supplies that we needed. So we had to end up building them. And we burned a lot of them up, and we learned a lot about building high voltage power supplies. That was probably our first live production thrust device. The entire little thing that looks like a fish tank is actually ITO coated PET plastic, which just means that it's there's a thin metal film on all of the plastic so that we can ground the entire box. It's like being in a metal box. So that's the Faraday shield around the test article.
So this is like a little Faraday cage.
That is a Faraday cage.
Okay.
You can see through it, but that is 100% Faraday cage shielded. All the grounds are tied together so that if there's any thrust created in the box, it isn't the box attracting to some other article in the room. So it's not Coulomb attraction. If there's any thrust created, it's because we are moving relative to space.
So when you say that, are you referring to the Casimir effect? Is that kind of like similar? No.
The Coulomb attraction is what I was talking about earlier. If you have a charge on anything, doesn't matter what it is, it'll attract to a ground.
Okay. Got it.
Because they'll just induce a field into the ground of the opposite polarity. And it doesn't have to be a good ground. It could be wood, floor, anything.
Okay.
So you have to make sure you shield it.
Got it.
We always measure the force on the box. That's that little force meter on the right there.
Mhm.
That's measuring the force on the entire box, not what's in it.
Okay.
Not just what's in it. So that's good.
And since both of us worked after hours, after our jobs, obviously I'm the one wearing the tie and he's the one wearing the khaki shorts.
You guys are a great team.
There we go.
Then the madness happened one day. I came in the shop and there was a blob of foam.
Oh,
and he's jumping up and down screaming, "It works! It works! It works!" I'm like,
well, I had to get.
What works?
Sometimes these air tests are terrible because you'll ionize the air and then the charges from the room will get to the outside of your test article and mess with your fields. So how do I keep the air away from my damn thruster because it nulls my fields?
Right.
So I use the brain blob here of spray foam to do that.
That thing right there produces thrust.
Well, what's in it does.
A giant piece of popcorn?
No,
that
there's
piece
a thruster
of foam
in there.
And that piece of wire produce thrust. It's in our patent. You should look it up.
The foam is not.
Have you ever opened your fridge, aimlessly stared into it for 5 minutes, and then convinced yourself there's nothing to eat? That's what happened to me before I started using ButcherBox. ButcherBox delivers 100% grass-fed beef, organic chicken, wild-caught seafood, and more, all sourced to standards they can actually tell you about. They've already done the research and made the sourcing decisions, so all you have to do is decide what's for dinner. It's honestly made eating healthy way easier for me because I always know I got high quality protein in the freezer that's ready to go. And when I'm hosting people or doing a cookout or just trying not to order takeout again, it saves me a trip to the store and lots of last minute scrambling. I keep a few of the staples stocked at all times, usually the beef, the chicken, and some fish. So when I need something quick, I've already got the real options ready waiting for me. For me, it just makes the healthy choice the easy choice. If you're looking for an easier way to get great meals on the table, give ButcherBox a try. Go to butcherbox.com/Danny to get $20 off your first box, plus your choice of free ground beef for life or free chicken thighs or top sirloins in every box for a year with free shipping always. That's butcherbox.com/Danny. It's spelled butcherbox.com/DANNY. And be sure to use the link below so they know we sent you. How much force have you guys been able to create to date?
To date, about 50 millinewtons.
And what is that in English?
50 millinewtons is about enough to lift two of these pieces of paper. Just 2 pieces of paper. About 50 millinewtons. On Earth's gravity. Well, yeah. The test is in a vacuum chamber.
The idea is if you guys are in space, that's a decent amount of
Well, the
thrust.
idea is that you put 1,000 of those together and you have a 5 Newton thruster. Then you put a 5 Newton thruster behind anything and you can be at Mars in 3.5 days.
What? Mm-hmm. With 1,000 of what you've been able to create?
Maybe 10,000. I don't know. I haven't gotten that big yet. But yes, we can produce 0.38 G continuous acceleration from Earth orbit to anywhere on the Mars surface in 3.5 days. We could build a spaceship. We can't because we can't afford
So your
spaceships,
biggest problem, your biggest hurdle is getting into space.
Yes.
Maybe you can use traditional rockets to get into space.
And that's our goal. Is
throw those away and then use what you've got done to.
We need to ride into space, and then once we're there, we can produce enough thrust to land on any other object in the solar system.
It's very, very weak thrust, but it's like driving a really old broken car from the 60s. It doesn't work very well. You floor it, it moves, but if you keep it floored and you never run out of gas, you're going to be the fastest car on the planet in a few hours.
Oh, yeah. And you never have to go to the gas station.
The numbers are staggering. Most people don't even believe them. And you think, how is a little blob of foam going to ever do any of the things that this guy is saying is going to happen?
Right.
But if we had a spacecraft, and let's say it weighed 45 tons, metric tons, and 30 of those metric tons were propulsion system, which leaves 15 tons for the spacecraft, the people, the ham sandwiches you want to take with you, whatever, and your flush toilet, by the way. And you're in Earth orbit. 3.5 days later, you're on the surface of Mars. 3.5 days, because during those 3.5 days, you continuously accelerated at 0.38 Gs, which means that you had the ability to pour your coffee in your mug the whole time. You can flush the toilet the whole time. And if you're wondering why I'm so obsessed with toilets, you go wear a diaper for 9 months and see how happy you're going to be when you get to Mars on chemical rocketry.
Oh, yeah, that would suck.
Ours has continuous acceleration. You continuously accelerate to the halfway point, you flip around 180 degrees, and you decelerate from there. At the midpoint, we're doing about 1 million miles an hour. We're only doing it for a few hours.
What?
Well, because you're accelerating the whole way there at 0.38 Gs. Then after that, you decelerate all the way at 0.38 Gs until you drop into you don't go into orbit because orbits are so 20th century. You literally just drop into Mars.
You just drop straight in.
And drop down. You're under thrust.
You don't have to ever turn
Mars
the
is only
thruster
pulling at
off.
you. Right. You never have to turn the engines off.
Oh, okay.
And Mars is only...
That's why we had to do orbit stuff for the moon stuff.
That's right, because the Earth is pulling on you and you only have so much impulse. But when you can never have to turn the engines off, and your engines can make, say, 0.39 Gs, and the Mars surface is only pulling at you at 0.38, that means you go down slowly. And then when you get right down near the surface, you crank up the engines to match Mars's gravity pull, and you don't need landing legs, you could just hover, but obviously you would land, get out, go do whatever it is you're going to do. And then from the moment you turned on the engines to the moment you are on Mars, you have the same gravity load on your body. So no more your bones starting to deteriorate. No more you're atrophying your muscles.
Radiation.
Well, you still have a lot of problems. We haven't solved any of the big problems. You still have cosmic rays.
But only 3 days of exposure, not
you get 3.5 days of exposure, not 9 months.
That's true.
Okay?
That's a big plus.
And if for some reason You think, well, that would require a nuclear reactor and they would have to have all this other stuff. The energy requirements to get to Mars are the same as the battery in your car could easily supply the energy to keep the engine running for the 3.5 days it takes to get to Mars. And you say, well, that's ridiculous. But remember, we're electrostatic. It doesn't take that much to generate charge. It takes a lot to generate current and B field, but we're neither of those two things. So once we have our static field formed, the unit, you can literally, we can turn the power off. Yeah, I know, it sounds crazy. These crazy guys are even crazier. But we could literally turn the power off and the engine stays on. And if you really want to hear the explanation of that, you know, get yourself some Excedrin and a stiff cup of coffee, and he can explain it to you. So anyhow, moving on.
Yes.
This is a typical day from anywhere in the last 10 years.
Okay.
Dr. Charles is up at the board giving out the very last theory ever.
There were old stuff here.
Many of these. They were all wonderful. They were all wrong. Now we have them right. This is a very typical. We're getting ready to. We just built the thing. We're getting ready to test something. You know, this is the team. This silly thing is what I have out on the web. If you go to our website and look at our webpage, I have a 45-minute dissertation on how to build that little piece of foam thing. I don't know where the camera is.
And what is this foam thing?
This is a thruster.
That is a thruster.
If you build this, if you spend the $1.50 it takes to build this, and the couple of hours, and by the way, the video is free. If you build this and you hang it from a string, you know, 8 or 10 feet of string from your ceiling, and you do it the way we say to do it, you will be rewarded with this pulling itself through space. This it's hanging on its string, obviously. You know, it can't fly. It can't lift itself off. Right. It only makes about 1/10 of a millinewton. But that's enough to see it move. And we have videos of stuff like that. So we thought we'd bring you one so you could see it.
That's incredible.
That is a warp drive thruster. I know he hates it when I call it warp drive, but I love the term. So any chance I get to call things warp drive, I do. So that's a cutaway of one of our thrusters. And notice it has black RTV all around the outside because air is the enemy. So you have to seal as much air out of the system as possible.
So why does it have to look like this? Why does it have to be this box with all these little grooves cut into the center of it?
Because the basic theory is that you have very small area on the tips of the grooves, and very large area on the foil on the back of that. And the large area has a greater electrostatic pressure pushing against it than the very small area of the tips of the fins. So it's a choice. Who's going to win? I push 1,000,000 pounds against 0 area, or I push 1 pound against 10 inches of area. Well, it doesn't matter how much you push on the little bitty guys. The area is virtually 0, so the force is almost nothing. So the force going backwards is almost nothing, whereas the force going forwards is more than nothing. The force wins. The large area versus the electrostatic pressure wins. There's a few more subtleties to it than that, but that's basically how it works. It's electrostatic pressure times area. Or electrostatic force times area, which is electrostatic pressure. So you can go ahead.
Yep, that's a pretty good explanation.
Unless you want to,
No, I mean, that's basically what it is.
So hypothetically, if you guys could scale this thing up, you know, times 10,000, what would the vehicles look like that we would travel to Mars in?
Anything you want them to look like. We don't need to be on the outsides of the spaceships. These can be sealed boxes in the middle of your ship. These could be on catamarans. These could be, let's say you build a ship that looks like, well, because I shamelessly love Star Trek. No one's going to believe this, but this is the first warp drive spaceship in the history of history. And you think, well, this is a little model from the 70s of Star Trek, okay? One of the guys on our team is a master model builder, by the way. But we put a tiny warp drive cell in here. Now, this whole thing only made 2.5 millinewtons of thrust, but it was inside of a ship. And when you have an engine in a ship, that's defining it as a ship under power. So this, although it didn't fly around the room or fly across space, was the first warp drive ship ever in the history of history. But putting that aside, because
Whoa.
I'm probably the only guy that thinks that's cool. This is a box. Inside of a box, you put your people, some area, you put area for people and sandwiches and stuff, and then you put your engine anywhere else you need to fill up the rest of the volume. Sadly, we are far more like a dirigible than we are like an airplane. Our engines are not very compact. They're large area devices. So we'll probably have very large surface areas, but we're flying through space, so who cares? It'll be like a solar sail almost. We had a large surface area because we're a surface area phenomenon, really. You can stack our stuff up, or you can go big surface areas. But if you have enough square meters of material at a high enough potential, then you have enough propulsion to go anywhere you want. Because you never have to turn the engines off. So you're constantly accelerating to go there. So your ship probably won't look as cool as this. It might look like a pressurized sphere with a great big propulsion system out in front of it that pulls it along. But
a great big panel or something?
Sure, like a solar sail. We don't need the sun. And we don't need this. We don't need the photons coming from the sun to do the job.
Right.
To do the job. But we are going to need something that you can put people inside of, something that you can put the hardware of the propulsion system in and attach the two with something. Cables, ropes, nacelles, something.
Yeah,
so it can be any shape, size, sex, or color you want it to be.
Wow.
I think that's one manifestation.
Yeah.
If we want to use area to maximize, or we could use volume. So you can imagine like a Borg cube.
Like a what?
A Borg cube, the Star Trek Borg cube.
Uh-huh.
You can use volume to put the thrust in too. It doesn't have to be area. It can be volume also. It's just user's choice.
So you could have a great big square in space or a great big sphere.
Like a big box or like a sphere or something.
It doesn't
like that.
matter.
And
As
you
long
would
as it
put
holds
inside
air.
of that a bunch of these
Inside that, you would put
layers of it.
Again, this is the stuff we're playing around with here.
There
This
you
is
go.
all
You found it. The Borg cube.
Yeah, this is all from 5 to 7 years ago, our stuff here. We have greatly simplified this. We now have propulsion cells that can lift their own weight. We are over unity. So if the propulsion cell, the material that the cell is made of weighs a pound, we can make 1.8 pounds. So we can make more thrust than the thing takes to lift its own body weight. So whatever's left over after one, that's what lifts the spaceship.
Right.
And we're over unity. We've been over unity for a while. We've been off chasing other.
That seems like a big deal.
It is a big deal.
Yeah.
But there are other big deals in order to have your own little space drive company. You have to achieve all the other things that we know nothing about, like becoming a company, becoming a brand, becoming something that someone believes. Okay, you almost believe us, but you'd be amazed how many people don't.
I believe you.
It doesn't matter how many times we've invited people in, showed them the magic, showed them the hardware, showed them the physics, put the hardware in their hands. They just walk away shaking their heads going, why did we waste our day here? Let's go get pizza. It every time.
That's incredible.
It's not every time. We have people that are interested. We have people that are investors. We have turned the corner now. Mm-hmm. But it took a while, longer than you think. But what's interesting about this field is that everyone has a different belief, and what that means is a different threshold for belief. Is it what you see? Is it what you touch? Is it a rotator? Is it a pendulum? Is it a spinner? Does it have to work in air? Does it have to work in vacuum? Does it have to work? Does it have to be stackable? Mm-hmm. Does it have to be, and every single person has a different requirement level. It's very odd. I mean, I don't know if you've ever asked that of the Wright brothers, does your plane fly? They would look and they would say, oh yeah, the plane flies. Imagine if they said, well, does it go underwater? Does it go into space?
Right.
Does it turn blue? It's very odd, the questions and the requirements set that we've been tasked to deal with. And every one of them is a fair question to ask. It just takes a long time to answer all of them. So we have to limit, our customer base, our investor base, to stay focused, because it's just the two of us. We got to stay focused.
Now, aren't there laws? Isn't there some sort of like U.S. government patent law where like if somebody comes up with some crazy patent or discovery or whatever, like it automatically defaults to the U.S. government or something like that? I remember Jesse Michaels telling me something like this.
Not exactly. The U.S. government reserves the right to ruin your life. And it goes back to the theory behind patents. Patents are not for the guys inventing stuff. They're for country building. They're for nation building.
Right.
So the nation that's going to give you the so-called protection, they reserve the right to take it from you.
Mm-hmm.
We believe,
For national security.
there's no way to know for sure, but our patent disappeared inside the patent office for 3.5 years, our original one. And we were told eventually by the patent office that it got hung up in DoD review. Maybe it did, maybe it didn't, but that's what they told us. Then it got hung up in NASA review. And the only reason we know any of this is because there just aren't that many people on this planet, so that they'd have somebody, external reviewers, review our patents. And they said, we can't because we work on the team that invented it. So after a while, the patent office gave up and they issued us our patent, which is wonderful. But we're running into the same problem now that we have our second patent out there. The patent office came back and they said, this is not possible. You are violating the laws of conservation of momentum. And we've spent a few years explaining patiently to the patent office the laws of conservation of momentum and all the stuff that Dr. Charles was talking about. And, hopefully they'll let our patent go the second time. We've already passed all the hurdles. We got hung up on a little technical glitch because they said, no, this is impossible. So we're not going to issue patent on it.
Right.
Okay, so we get affidavits and we showed them people that have reproduced our work, and we showed them videos of people that reproduced our work and a full description of the physics down to levels that they don't even understand.
Mm-hmm.
And we hope we've satisfied them. And now it's a waiting game.
Now,
so that's the reality of the U.S. patent system.
Now, what about the whole peer review process? Have you guys initiated anything like that?
We're going to.
I won't let him.
We're going to. Because, this is fundamental physics. So you can't really patent that anyway. But the fundamental physics will be peer reviewed. And really, we do need a nice description of the thrust itself, the experimental. So people can do it how Drew drew it up. Mm-hmm. But, have it written down on a nice paper so that scientists can verify it. And that's all.
But peer review is designed to shut down the flow of information. It's not designed to
it'll help the scientists.
So,
well, yeah, I'm familiar
but
with the
origins again,
of it.
It's like the example that Charles used of the Wright brothers. They flew. Nobody peer reviewed their work, and they had a lot of it. They actually invented the wind tunnel.
We're not letting our work.
Nobody peer reviewed their work.
Yeah, we're not holding up our work on a peer review.
Yeah,
we're not holding it up.
Right.
It's a parallel thing, just for science, and that's it. It's not in line with what we're doing because we're not waiting on it. I'm not waiting for the scientific community. It'll take them 20, 30 years to buy this, and I'm
20 to 30 years
at least.
And
I'm okay with that. I understand how the process works.
Yeah,
but I think what will happen, what I'm encouraged with, is as Drew made videos of how to build these things, and you can see they're not very complicated. There's a bunch of us working on them. What's exciting?
Hold there, because I want to explain.
Oh, you want to explain all this? But
yeah.
So you want to explain this guy too. But what's exciting is that if he makes videos how to make them, this will go the way of the lifters. If you're familiar with those, the lifters are something that came around in the 80s or 90s, where you take a aluminum foil, you form it in the shape of a triangle, vertical triangle with the lines on top.
I have seen those,
and people thought they were fake and all that stuff until hobbyists started to make them, and their teachers would make them, and students would make them, and then they would work. And they were cool. They're cool, lifting devices. They lift up a couple of feet off a table. Outstanding little Corona thruster devices, ion wind thrusters.
Mm-hmm. Ion wind.
So so basically, you're just taking the gas wind and you're accelerating it one way and moving the device the other way. It's a conservation of momentum of gas movement.
Right.
Not what we're doing, but certainly something people did not believe in until they actually started building them. So this will probably fall along the same path. People start building them in the garage. I've had people come up to us and tell us they've done that. And, just that would be the way that this makes it to the mainstream. Mm-hmm. The scientific peer review process will take a couple of decades.
You guys are doing everything you can. I mean, obviously you're explaining this soup to nuts on podcasts publicly, trying to make this more publicly available for people and let it get out there.
We want people to follow our patent, follow our videos, come talk to us. The only thing that's stopping anybody from learning more and learning really deep is our NDA, our non-disclosure agreement. Nobody comes in our shop that could walk away with the IP. And that's the only thing we ask. But once you pass the minimums of credibility, you come in and we'll talk. We'll show you everything we know how to do, because you might have the next great idea.
Right.
And I wanted to mention this, how Charles and I are the core of the team, but we have a big team. There's probably 8 or 10 people on our team, and some people float in and float out over the years. It's all about the team, because nobody can do everything, and I've tried. I can't do electronics. I'm terrible at it, and I don't do computers because I hate them. Charles is not the greatest with mechanical tooling, but nobody can do what he does. Nobody can go up to that whiteboard and fill it full of squiggles and actually make it make sense. Okay, very few people can do what I do, which is, for example, go to the next one. This is just us playing around in our shop one day. I built that thing. Everything you see there.
What is that thing?
That's a vacuum chamber. That's one of our small vacuum chambers.
Wow.
And there's nothing special about a vacuum chamber except that we can hit 10 to the minus 6 torr, which is hard vacuum. You put a lifter.
What does that mean, 10 to the minus 6 torr?
There are 760 millimeters of mercury in an atmosphere. That's what you would call a standard atmosphere. If you had a board on tube upside down, it would pull a vacuum at 760 millimeters high. That's the pressure of a standard atmosphere. If you pulled all the air out of that thing down to 1 millimeter, that means that you'd have only 1 millimeter of atmospheric pressure in that thing.
Got it.
The pressure on Mars is about 7 millimeters of mercury-ish, between 5 and 7. So if I was outside on Mars, the atmospheric pressure would be about 5 torr, 7 torr, something like that.
About 100 times less.
About 100 times less.
Okay.
If I was on Venus,
Be way more.
the atmospheric pressure would be 700 atmospheres. It's about 100 times the atmospheric pressure of the Earth.
Wow.
But when you get into vacuum, you get down around 1 torr, 1/10 of a torr. Now you're into the millitorr, 1,000th of a torr. Okay. The International Space Station, buzzing around up at whatever it is, 250 miles or so, it's at about 10 to the minus 8 torrs. The atmospheric pressure outside the station is about 10 to the minus 8 torrs.
Okay.
The atmospheric pressure on the surface of the moon is about 10 to the minus 9. Atmospheric pressure on the backside of the moon is about 10 to the minus 10. These numbers don't mean anything, and it doesn't matter. We can get down to space. We can pump down. We can put our test articles inside that box, inside that tube, pump down to about the pressure of space. We were talking about lifters. Lifters are fun things. Everybody says, oh, you're just making ion wind. Well, you put ion wind, you put a lifter in a vacuum, it stops making wind because there's no air to make the wind with. So lifters don't work in a vacuum. Our system loves vacuum because we don't have the air, which tends to short out the high voltage plates. Vacuum is very friendly to our system. The harder the vacuum, the higher the voltage we can run, the higher the field we can run.
Wow.
The more thrust we can make with the same hardware. So we grew up loving vacuum because everybody said, oh, they're just ion winds. It's just a lifter. Yeah. So we said, okay, what's it going to take to prove it to you? And the first hurdle was, I put it in a vacuum chamber and it'll fail. We put it in a vacuum chamber. It worked better. Then the next hurdle was, well, now what do you want to see? Oh, now we want to see it spin around. So we built spinners in the vacuum chamber. Then the next hurdle was, oh, we want to see it float. Okay, that's a tricky one. That's a real tricky one. So that's when we stopped listening to people saying I want, and we started focusing on what we needed.
Yeah.
So that's an example of a homegrown vacuum chamber. The next one. And of course, Dr. Charles is there to supervise.
Why is it so difficult to make it float?
Well, let's say we have
the 1.7 Earth unity. So we can make something that can lift its weight and a little bit more.
And a little bit more.
But that mass is based on the actual thruster itself. It doesn't count for the mass of the framing, the power supply, the tape, all the non-components that are doing nothing except holding it together and structure and all that.
Mm-hmm.
So it's like a car saying, I have enough horsepower to move my car or move the engine, but not the car.
Right. Not the
Can't move
tires.
the seats or the steering wheel or the.
You got to start somewhere.
So
where we started with was the fact that we're not zero. Okay, so that was the
Yes.
unicorn. We birthed the unicorn. Now people want the unicorn to get up on the table and dance, and then they want the unicorn to be wearing a certain color dress
Yeah.
and dance.
Mhm.
So it's everybody always wants the next cool thing because eventually everybody wants to see the Mattel hoverboard.
Is this a spinner?
That's a spinner.
Wow, look at that.
And that rotated around.
In a vacuum.
In a vacuum that's about 5 years ago, maybe. What year is that?
It's been a while.
2020.
How
6
fast
years
did it
ago.
spin?
Oh, it's
Very
tiny.
slowly.
It's not fast.
Oh, no,
Very,
helicopter.
very slowly. It took hours for it to rotate
One
around.
rotation was hours.
Because the string has torsion in it.
Right.
That thing's just held up with a string.
Right.
And the
right.
string has torsion. So you're working against the torsion in the string. Well, that whole thing only made about 2 millinewtons of thrust.
Mm-hmm.
2 millinewtons of thrust on an 18-inch arm ain't that big.
This sucker was heavy too back
And
then.
the whole thing weighed about 2 kilos, maybe 2.5 kilos.
Mm-hmm.
And it was, actually, that one's probably on a pin. Yeah, that one doesn't have a string. That one has the thing at the bottom is just a plate, and there's probably a pin coming up from the bottom. So that whole thing is on a pin and jewel pivot. But either way, that's why we got rid of the torsion string and went to the pin and jewel. That's the only reason that thing spun.
Mm.
So
That's
as
cool.
soon as we did this, they went to, now we need to see it float. And, we've been talking with people for years, and it always goes to the next level of, now I want to see it do that. Now I want to see it do that. Now I want to see it do that. Well, this is all self-funded back in the day. And, this is after we put in a full work week. We're doing this.
As I keep getting older, I'm starting to realize that life insurance is one of those things I should stop putting off. Nobody wants to think about worst case scenarios, but when your family relies on you, having this kind of coverage is the more responsible thing to do. And that's where Ethos makes the process stupid simple. Through Ethos, you can get a life insurance quote in seconds, apply in minutes, and get potentially same-day coverage all 100% online. There's no medical exam. You just answer a few simple health questions online, and you can get up to $3 million in coverage. And some policies are now as low as $30 a month. Ethos helps provide financial security by connecting you with coverage through its network of trusted carriers. It's one of those things that only takes minutes now, but can make a massive difference down the road. Take 10 minutes to get covered today with life insurance through Ethos. Get your free quote at ethos.com/Danny. That's spelled ethos.com/DANNY. Application times may vary and rates may vary. Is there one limiting factor that's holding you guys back that you could basically say, if say it was money, if you had a limited amount of money, would you guys be able to figure out how to make this thing float? Or is there what is the biggest common denominator that you think is impeding
it's the usual
progress?
thing. It's just money and time.
Money and time.
Really is. I mean, I'll be leaving my NASA job soon to work this full time, but it's always been a part-time thing. He just left his job full-time to do this full-time for the first time in 20 years. So time is going to be on our side.
Mm-hmm.
Then money, so we can get other people to help us. That's what this.
And what is the most like lowest hanging fruit as far as like a practical application for this thing?
I would say
This right here.
is what he's showing you there are these small sat thrusters.
This is an example of a CubeSat. Again, this is a cart. I can't see what's looking at, but this is an example.
You're looking at that camera.
Oh, okay. This is an example of a CubeSat. And for those who don't know what a CubeSat is a 4-inch by 4-inch by 4-inch cube, and you stack them up. U1, U2, U3. This is a U3. So people have launched these for 15 years now. They put these up in great big boxes, and they shoot them out one at a time. And sometimes they have little tiny propulsion systems in them, and sometimes they don't. And they're little tiny satellites. Again, this is a cartoon. This is not a real one.
Right.
Okay. Our dream is to build something like this, or get with a vendor who builds things like this. And
Is it roughly the same size?
it would be the exact same size. This is an exact copy of a U3 CubeSat. And then in this case, we propose to have this be the propulsion module. And the propulsion module would look something like this. Our propulsion mechanism would be inside of it.
Mm-hmm.
This is a cartoon again. There's
Right.
nothing real here.
I see.
And then this would mount directly to the other half of the spacecraft, so that the things like cameras and solar cells and gyros and all the things that make up little tiny spacecraft get a propulsion module. in this propulsion module would be enough propulsion to send this thing to Mars. And it would probably get there in a couple weeks.
Whoa.
I wouldn't say we'd have enough to get there in 3.5 days, which is
it's
in the future.
The propulsion module is about 50% of the entire
in this
size.
case, it would be.
In this case,
in this case, we actually set it up to be 50% because, again, this is a cartoon. You know, it may be that this propulsion module could handle something the size of this table, but now you're talking about much slower getting to Mars.
Mm-hmm.
You know, certainly we could climb out of the Earth's atmosphere. We could climb out of the Earth's orbital gravity. So we could, once we get into space, you know, somebody's going to have to give us a ride to space because these things don't lift their own body weight yet. So somebody's give us a ride. We're in orbit. We're in low Earth orbit, and we turn on our little thrusters. And normally, thrusters are turned on, and in a couple of months, little toy satellites make it up to whatever orbit they're supposed to be at. Then they run out of fuel.
Wow.
That's the best you get. Those are little ion engines. I mean, every one of the pretty much every satellite out there does that. They start out in a real low orbit, and then they slowly work their way up to a higher orbit, and then they run out of fuel.
This will never run out of fuel.
This will never run out of fuel, so you never have to turn off the thruster. So it constantly is accelerating. You're constantly gaining altitude, constantly. At some point, about 12 or 13 hours later, you've left the Earth's gravity and you can go to the moon if you want to. But then you better start decelerating pretty quick because you're going to hit the moon at, 200,000 miles an hour. So if you want to go to the moon, this little toy could take you to the moon. This little toy could take you to Mars, presuming all the other problems are solved. Okay, we don't have a deep sky network to communicate with our little toys. We don't know how to fly to Mars. We're just guys getting into this.
But right now, today, if you can get a ride into low Earth orbit, that thing would.
We would build a real one, and our propulsion system, which is very much advanced from what you see on the screen, would have more than enough capability to do all the crazy things we say it can do. We don't have to invent anything else. We have it. We just don't have the millions of dollars that it takes to get from cartoon to real life. Not that we're working on it. We work on it every day.
That sounds
12
incredible.
hours a day. But right now, we're trapped by the reality of that. I don't know about him, but I'm a poor boy. I don't have the money to just.
So he's got a pizza.
Yeah. We have a joke running. It's the only place on Earth with pizza and warp drive. I'm sorry. I just thought to put that in there because it was funny.
Now, have you guys talked to any high level space executives or rocket people, maybe for example Elon, maybe not at his level, but somebody about this and gotten any kind of feedback from them, positive or negative?
We have. We are in contact.
The well has been poisoned.
The well has been poisoned. So you're getting there's a lot of stigma attached to it, or just a lot of skepticism?
I think like I was saying, there's a lot of levels to climb. There's a lot of hurdles to climb, and there's a lot of minimum requirements. And there's different use cases that we have to show. So there's different thrusters that we have to show, different things that it needs to do. It's not a high hurdle, but at the end of that game, you're going to talk to the bigwig, and then they'll decide our fate after that. We're not waiting for that. We're just waiting. We're working with potential customers for this little guy. They may have thousands of these or hundreds of these. So that is it's a better ease in as you're starting a company to get a customer right away, which we already have. We think we're trying, and then go from there instead of, the big dogs, they'll hear about us later. Yeah, I'm sure. Sure. I'm not worried about it. But if we get a small customer that work with us to get us space rated, space grade, all of that, and pay for all of the heavy lifting, which is what some have offered to do, that's a much quicker route. And I think we're going to do that. And we're going to do that in short order. Yeah, once you get somebody big on there, everyone will try to jump on the bandwagon. But the early adopters are probably the hardest ones to get going. So what would be the... to get this guy into space, I'm sure just civilians can't launch shit into space, right? There's
you can buy a ride. You sure can.
Really?
You
Absolutely.
Could. This little bad boy
here.
So
the way I fly a DJI drone around, I could fly one of these in space.
Not quite.
Okay.
What you can do is,
I mean, regulatory wise.
you can buy a ride, and they take care of all the regulatory. You could build one of these, okay, excluding the propulsion system. The satellite alone will cost you about $300,000 for the pieces parts. And but the nice thing is, you can go out to whatever it is, littlesatellitecorp.com, and buy a chassis and a gyro and a star tracking. You can buy all the pieces of the puzzle, and you can even get people to assemble them for you. And then you would integrate in whatever your special thing is. Let's say you wanted to do a thing that took pictures, or some guy sent a cell phone up.
I saw that.
It takes a picture of
It takes a picture of a selfie or something. With
it takes, so you put your selfie on there and it takes a picture of you in space with the stars. It's wonderful.
My son loves that channel.
What was that called? Like
Mark Rober.
Mark Rober. That's what he was. Yeah,
and that's wonderful.
Yeah.
But the satellite, $300,000 roughly. If it's about this big, if it's bigger, it goes up fast.
You guys could build them, and then you guys could like rent them out.
Yes, yes, we could. To get this into space is anywhere from $300,000 to $1 million, depending on your ride and what you want to, how long you want to wait, and how far down the list you want to go. And there are ways to do that cheaper, and there are ways to do that more expensively, but it's somewhere around $300,000. So between the cost of the build and the cost of the ride and the cost of the mission, because you've got to have communications, you've got to have somebody actually receiving your telemetry. There are people who offer that service now. That stuff was not even available before. It's $1 million a pop. And generally, what you learn in the aerospace world and the space world is you need two of everything, because the first one's usually going to fail. So you got to build two of everything. So now you got $2 million sitting on the shelf. And that's great. That's what you're going to launch. But then you got to test everything. So you got to build two more of them. We call them engineering demonstration units. So you have to have your two engineering demonstration units, and they don't have to launch, but they have to get built. So there's another couple $100,000. And then you have to run your testing operation. These tests are pretty exotic. Shake, rattle, and roll, radio,
EMI. There's a gauntlet of tests.
There's an enormous gauntlet of tests that you have to pass before you are not a hazard to all the other people who've spent their hard-earned money to put their satellites into space. So you can launch your own satellites. You can. You got to buy a ride. You got to do all the minimums. You got to play by the game, because you can't buy your own rocket. I mean, if you can, that's even better. But nobody can buy their own rockets. So that's the world we're in. Is we're looking to team up with someone who wants to test out the first propulsion system that never has to be turned off on a satellite they're willing to risk it on.
It's kind of crazy to me that, there haven't been any big aerospace companies that have approached you guys and tried to contract you, like or even something like DARPA or something crazy.
There have been, and we're in talks with them. So I don't want to give out who all these people are, but that process is ongoing. It started. So we're excited about it. It's not just, we're not,
What do you guys think what do you guys think of when you see, and you hear of all these reports of like these crazy things flying around in the atmosphere, like the pilots talk about and all that stuff? Was that kind of like what inspired this stuff? Or like when you think of all the work and the time you put into creating this thing and you see stuff like that, what do you think?
Damn it.
Do you think it's all fake? Or do you think
I don't know. Maybe it uses this force, maybe it doesn't. I don't really know what it is.
Yeah.
I don't know what it is either.
Do you think that there are human beings on this earth who have figured out something like this on super steroids times 1,000,000 that you can put a human in and fucking zip around the sky?
I honestly don't know.
Is that possible, or is it impossible? Like I'm saying, like hypothetical, you got a gun to your head. Yes, they figured it out. No, they haven't figured it out.
I believe it's possible they have.
Yeah.
I just don't see any evidence of it.
Right.
I mean, it took us a long time, even as simple as this theoretically is, just to get there and to develop this and to continue to develop it. I mean, the amount of work and hours to get to this is ridiculous.
Propulsion's not the only thing you need to be able to do what we see on these I guess you're
And there's
referring to the
UAPs.
Tic Tac videos,
Yeah,
stuff
like
like
the
that.
Tic Tac videos, things like that.
And I promised him I wouldn't mention it, but I'm going to anyhow. I'm part of a group of, I call them crazy people because we are all crazy. It's the Alternate Propulsion Engineering Conference.
Oh
APEC.
yeah.
And
There's a lot of smart guys that are part of that conference.
Brilliant people in APEC. And there are crazy people in APEC. And
just like every group.
there's no and there's no reason you can't be brilliant and crazy, which is how they define me somehow. But there are guys in that group and gals too, because very brilliant. Some of the people in that group are female and they're very brilliant. Their dream is to pick one of the things that keeps you from being able to do the crazy things you see on the videos. One of them is, I want to go to the left at 500 Gs or 1,000 Gs, or whatever, it's sea level to 80,000 feet in a second.
Yeah.
Okay, that's 10,000 Gs. 10,000 Gs would do to your body? You would be a smear on the back bulkhead. Okay, 10,000 Gs, you could put anything, a piece of metal, and subject it to 10,000 Gs and it'll crush it. So obviously, if the videos are real and you're doing 10,000 Gs, somebody somewhere somehow has figured out a way to reduce your static inertia such that for those moments that you're doing the high G forces, you're not subject to the inertial loads.
Right.
One of the guys on the team has a machine that makes my vacuum system look silly. And he's reporting that he has lowered the inertial. So he has, he can move his test article and it isn't subjected to inertia. So he has reduced its inertial component by a small fraction with whatever magic he's working on. I truly don't understand it, but he's working on it. And someday he might get to where he can take 100% of the inertia out along one plane or two planes or three planes. So then he could accelerate his test article at 100 Gs and the test article wouldn't feel the inertia. But that doesn't mean he has any way. Let's say he does it. He doesn't have any way to make his test article move. He would want somebody that has a propulsion system like I have.
Right.
I don't have any way to keep my people from being smeared on the back bulkhead.
This is the crazy thing about science too, is because most science in the academic sense is very stovepiped, meaning like it's not very interdisciplinary. People work in single lanes and they don't only talk to people in their own lane. They don't communicate outside.
That's why we're part of I like to call them crazy people, but they're brilliant.
Yeah.
And we get together once or twice a month and it's open forum. Anybody can talk, anybody can present, anybody can ask questions. And if you have some answers, anybody's welcome to give answers. And we kick all kinds of ideas around and stuff. But it's basically focused on propulsion. That's what this conference is focused on, which is good for me because that's all I care about.
Yeah. So when you say 10,000 Gs, like for example, that the way that like Dave Fravor describes that, the way that Tic Tac move, you're saying for it to make these hard turns and to go from sea level to whatever it was, 80,000 feet in a second, that would be that roughly that kind of Gs. So a human being wouldn't survive that if it was in traditional space time. But would the materials that we know of even survive that? Like we don't have any materials on Earth.
I don't believe we have anything that could survive those kind of Gs.
No types of metal alloys terrestrially that would survive those kinds of Gs.
It puts far too much of a stress on the hull.
I look at those observables, the 4 observables they have. Obviously, propulsion's one of them. Inertia's another. Going through objects, flying through objects. Going through mountains and these things.
Through mountains
underwater, without even seeing the water, without even experiencing any of that.
What does that mean?
You have to be in a place or a time that the water isn't.
Yeah. So
I don't have them doing it, but you would have to be where the water isn't.
Quantum mechanical can possibly allow that. Everything has all the atoms in our body and molecules and all that have a certain quantum state. And if you change that quantum state, if you can do it, you can add another perhaps quantum number. If you add another quantum number, you're no longer in the other quantum state that the rest of the universe is in. You might just be able to pass right through it. So there are Pauli exclusionary principles in quantum mechanics, very, very ad hoc, very, weird theories out there that people can do experiments on to show that if, we know how the Pauli exclusionary principle works. If you were able to change the quantum state of something, you could go through these mountains and water, oceans, whatever. I don't think humans, you asked earlier, do we have this and where someone's got it in a mountain somewhere and they're doing all this? This is thousands of years ahead of us.
Who is?
This technology that we're talking about.
That we're seeing.
Yeah. And this is far ahead of us. Like not even, the textbooks will kind of go over this. Like even our force is so awesome. It's going to be 1,000 years before you get strong enough to do these crazy things. What your buddy's doing with the inertia, he's a long way from that.
Oh yeah,
I can't imagine there's one set of guys that have all of this figured out in some mountain somewhere. That's just kind of like hard to believe because
have you met anybody ever who is more adept or proficient in this field of electrostatics than you are?
I have a lot of colleagues that are in this field.
Mm-hmm.
There's not a lot of us that work at propulsion, but there's a lot of electrostatics colleagues of mine.
Right. I just think that, coming from someone like you, who is like one of the top people in this, doing this work at like a place like NASA, and you saying that that stuff is thousands of years ahead is crazy. Because I've heard stories of people who have done research on places like DARPA and talk about the technology that they've been working on. They say that usually they're like 20 years ahead of anything that you see in the public sphere. Or like in the commercial sphere, right? Sure. So like 1,000. That's insane.
That's how I personally feel. You're talking about quantum mechanics that we had since the 1920s. There's been no advancement in that Pauli exclusion principle to go phase through a matter and go through a table without touching it. Physics, it's maybe possible, but you're talking centuries ahead of us from now. Mm-hmm. And this inertia, these right angle terms, and you can tell that the ship is not even stressed by any of these things. It's actually colder in some of these videos. So there's a lot more going on in those things than I just don't have the faintest.
My first introduction to all of this stuff was the Bob Lazar story. And I know you talked to Bob Lazar with Jesse Michaels.
Yeah.
And he described it in a way that I completely understood it. And I don't know like mathematically how it works, but I understand like generally how it works. He was saying that there was this basketball sized reactor that basically when you turned it on, it was like you couldn't touch it. Yeah. And the way he described that the alleged crafts that he worked on moved was they sort of like the way I would drop something like that, it would move horizontally to the earth or perpendicular to the earth as if it was falling. And he even said that they would fly belly first. So like if it somehow bent gravity or space-time around it, it could theoretically like fall in whatever direction it goes, meaning that there's this sort of like bubble around you that's protecting you from inertia or whatever. I don't know what word I'm looking for here, but whatever.
Maybe
that's bending of space-time.
I'd love to see
We don't have a quantum theory for that
either.
The bending of space-time. How would you do it? How would you build that in the lab?
Right. Element 115.
Sure.
I just don't know how you would do it.
I have my hands full, 100 hours a week.
Has anyone ever asked him to break it down? Does he even understand how that works? Or is that just too perplexing for him to?
In the 80s, he talked about the gravity waves stuff.
Yeah.
Right. The gravitational waves being created from the element 115 and they would go down those tubes and go into the gravity wave amplifiers on the ship. And at the time, I didn't really believe a lot of that.
Yeah.
I just couldn't make sense of it. I was a kid, young, and just that was kind of at the time, that was like the hottest topic, gravity waves. Hot topic. Richard Feynman, got onto the science community about gravity waves. Can they do work? He wanted to know. There wasn't anyone working on that field. So So I think, he picked up on the gravity. Maybe that's what it was, gravity waves. But more recently, I think he's more open to the possibility of maybe not being gravity waves, but something else.
Oh, really?
Something else entirely. So
like more in line with what you guys are doing.
It's possible. It's just another force. It can't do all the fancy things you're talking about, bending space-time or anything else, but it could be a force.
Mm-hmm.
We haven't explored a lot of facets of our force. we're brand new at this. We're like a kid in a candy store. We have a new shiny car. We got to test it. We got to take it out for a test drive to check it out. But it's possible because the element 115 theoretically is a very high melting point material, higher than anything we have theoretically. We've gotten very close to that. So theoretically, it has a very high melting point. And that's a very advantage. Has a very huge advantage.
Mm-hmm.
And I talked about this at APEC a few years back, but my thought was like, oh, that's interesting. And I showed the design that Bob Lazar put on his napkin.
Yeah, the sports model or whatever.
Of the sports model, the internals, which he didn't show before. I'd never seen it. And I looked at that and I said, that looks like a transmitter. I showed my wife, who's at NASA, she in the EMI group, and she's like, yeah, it does look like a transmitter. I said, maybe that's an electromagnetic transmitter. So, Bob drew the waveguides, which are basically ways to trap electromagnetic light, whatever frequency that would be, probably gigahertz or terahertz or something like that.
Right.
And like, this is an electromagnetic source, possibly. And then he'd go into the gravity wave amplifiers. Now, that doesn't mean anything 20 years ago, but in today's light, well, the gravity wave amplifier, the spaceship would always move in the direction of the amplifier. Just like our propulsion always moves in the direction of the of the thrust, like our forces are in the direction of the thrust. It's like it was pushing, they're pulling on it, if you will.
Not in the opposite direction.
Not in the opposite direction. So usually you have a rocket, you have exhaust going one way and the rocket goes the other way. This goes the same. So it's weird. And his gravity wave amplifiers would turn a certain direction. The ship would go in that direction. So we go with it.
Yeah.
So I'm like, okay, it could be an electromagnetic thing. And if it is, that's pretty exciting because that's basically in line with what Drew and I are starting to scratch the surface on.
Right.
Basically, we're probably years away from something that exotic, but that could be something like that. At least it falls within something that humans can probably test and understand long before gravity waves. And
I hope you guys have good security around your lab.
Someone will come in and steal our styrofoam.
There's too many missing scientists popping up.
We have the best security possible. Nobody believes us. Our next door neighbors don't believe us. They just shake their head and say, "What a waste! So much potential," and then they move on and go do whatever they're going to do.
Yeah, well, you have just so many stories of like those scientists that go missing, and then you even had that lady, that Ning Li lady, who discovered that the conductor, the superconductor or whatever that spun. It did something crazy, right? And then she actually, it got peer reviewed. And she got a contract with the DOD, I think, and then she just like vanished. And people think that like the Chinese basically rendered her back to China to do some work for them or something, maybe.
That's probably the most likely.
Yeah,
possible. There are some people at the APEC group who have been in that world for 25 plus years, and they have a lot of historical knowledge, and they know some of these people. So we're hearing that statistically, it's not a thing. Some of these people were perhaps not fully stable. Some of these people were being lumped together in groups that don't belong together.
That's the consensus.
Because we talk about this
from that community, which I would think they'd be
we
the
talk
experts.
About this regularly, and
about this lady in particular,
about the whole
phenomenon
of the
like
scientists
there's
missing.
10 or 20 of these people.
Oh yeah. A lot of them. Yeah, but there's a few of them that are like the general, the McCaslin guy. Yeah. That one was very odd.
So we're not taking any extraordinary precautions.
Yeah.
We're a small business, and we have the precautions that a small business requires. And basically, nobody believes us. Really, nobody. Not even our wives barely believe us. Okay,
my wife.
And his wife can explain the physics better than he can, and she barely believes us.
That's funny.
So,
if some men in black showed up at your laboratory and they said, "Hey guys, you're going to come work for us now. You're going to work underground. You're going to kiss your public life goodbye, but we're going to show you what's really going on," what would you do?
Yeah, pack my bags. I'm gone.
Wow.
No,
I don't care where. I don't care if that thing's under the ocean.
Yeah, I used to think the same thing. Like, but on the other hand, the more I think about it, I'm like, I really don't want to know the truth, about what all this stuff really is, because I don't know what kind of baggage that comes with. because there's so many different people, there's so many different stories around this stuff. And, it's really hard to like keep one coherent sort of view on this kind of stuff because it's so intertwined with all the UFO stuff, and there's so many UFO stories, and it's hard to pick the wheat from the chaff. It's just like the zone has been flooded with so much crazy stuff. And within that big cauldron of craziness, there's a lot of real stuff. There has to be a lot of real stuff. So
we're really
and a lot of that stuff comes with like, remote controlling stuff with your consciousness, and I know a lot of really smart people, including Jesse Michaels, who's been studying this stuff forever, who's talked to all the most brilliant people on earth when it comes to this stuff, including you. I don't know if you've talked to him, but like he thinks that is a potential thing. And he's talked to people that have worked in like, aerospace companies or have been, there's one guy he talked to who is he works for I think NASA or SpaceX, and he is the guy who like oversees all the launches or whatever. And this guy works in the Huntsville, Alabama location,
Marshall,
and apparently like really high level, and as far as rocketry. And he's been, he also, I think he had a friend on the Challenger shuttle mission. And, this guy is of the belief that it's the same thing. So I don't know. It's too confusing for me to navigate.
I got to tell you, we're so far down the food chain. That's the beauty of nobody believes us, is we just do our thing. We publish our results to our friends and to our potential customers, and we just keep moving forwards. That's our goal.
Yeah,
our goal is to listen to the madness and enjoy the stories if that's what they are. Read the headlines. I look forward to the launches. I've seen most of them for the last 50 years. I live within 30 miles of where I grew up. So it's everything we can do to move our little piece of the story forward.
Yeah. I had a friend who was out fishing the other day and he saw that shuttle explode, that Blue Origin one, or the rocket.
Yeah, that was unfortunate.
Shook my house.
Yes, I have.
What was that one doing? That one was sending satellites.
Static fire.
It was just static firing the engine.
Static fire.
Yeah, they're getting ready to.
Job's so important.
They're getting ready to.
Not electrostatic fire.
Oh,
static means it's static, not moving. So they hold the rocket down.
They bolt the rocket down,
and then they shoot the engines.
They fire the engines.
I see what you mean.
Yeah. Static fire.
Electrostatic fire would have been Apollo 1, right?
No. The Apollo 1 was just a fire.
Just a regular fire. Okay.
Apollo 1 happened because certain people did not understand the theory behind absolute pressure or gauge pressure. They thought they were the same thing. So Apollo 1 it wasn't an error. It was an act of stupid. It was an act of stupid. So, most of the time when you end up killing your crew is an act of stupid, because the hardware they've beaten the hardware to where it can handle the loads, but then you do something stupid and the hardware can't handle it no more.
Right.
So it's very sad.
Yeah, it was tragic. And the guy Gus Grissom like famously hung a lemon over the shuttle or whatever, just because he thought that the equipment was. I mean, obviously he had a good reason to believe that the equipment was not up to par.
It's very difficult. I believe it was Mr. Musk that said that rockets are hard. Rocketry is hard, and he's not kidding.
Right.
And he's spent enough money to find out how difficult it is, and through sheer perseverance and the incredible engineering effort of his team, they just move forward. They move forward faster than we do. Okay, we move forward fast. I mean, we test once or twice a week, 3 times a week, sometimes 4, and we have iterations twice a week. Sometimes those guys are moving light years faster than we are.
They also have unlimited budgets.
They also have a far larger team. They have a much narrower scope of what they're trying to do.
Right. And
people have built rockets before. And I don't think anyone's built what we're building before. And if they have, I'd really like to talk to them.
Yeah, I mean, we don't want to be mixed in with with the alien crowd and all that. This is just another discovery in physics, I think.
Mhm.
And
Well, how could you be into this stuff and not love the aliens?
well, yeah, you do love it. I
You
mean,
do. You just like to hear the stories and watch the movies. And,
and I told Jesse,
it's great fun. And
I've experienced some of these clairvoyance things myself because you can do it.
Clairvoyance?
Yeah. Oh yeah, absolutely. It's I like anything in the world. You have to believe it. To believe it, you have to test it yourself. Don't just take someone's word for it. Just try it out. Like telepathy, very real. You have to you have to practice it. Clairvoyance, there's books that tell you how to do it. I was a kid, I was all into that stuff. Just draw something on paper, have someone else draw something, and you figure out what it is without looking at it. And just draw what you think it is.
Mm-hmm.
If they concentrate on it real hard enough and you read their mind and all that, you'll see what they see. It's not too complicated. It's not too hard. You just have to do it. Telepathy is the same way. Do that experiment with my kids a lot. Think of something I'm saying, and they just think of something. I do it with my wife, just all the time. Like, what number are you thinking of? And just practice it. You practice it, you get good at it. I have no idea how it works. But
it's also interesting that, Edgar Mitchell got really into that stuff.
Yeah. It's a different phenomenon. There's a lot of things and I tell the students this, and, I gave a talk at the Electrostatic Society of America, which I'm now the president of. And I told the young folks in there, there's a lot left to be discovered. Everyone thinks everything's done. Everything's discovered. And that's not true. It's the 21st century, but there's still discoveries to be made. I discovered 3 or 4 different phenomena in electrostatics.
Right.
This propulsion is just one of them.
Right.
But we're still a very young species. There's a lot more to learn. And don't think science is done. It's not.
Right.
And it's an exciting world we live in. I think it's a very exciting world. Personally, I think it's really exciting. I think it's going to get more exciting as we get further along.
And I think there's
here.
a lot more to it than just like the nuts and bolts physical like the physical elements of stuff, right? I think there's, just studying the history of NASA, like those dudes, L. Ron Hubbard was best friends with freaking Jack Parsons, doing all kinds of crazy seances and witchcraft, and these guys were into all kinds of wacky stuff. Like how and a Nazi. So you have like the 3 craziest types of people you could imagine coming together and forming NASA. Like it seems like there was way more to this rocketry stuff than just.
But when all was said and done, they were crazy on their own time. They were working with Robert Goddard's liquid fuel engine during their daytime. So they were doing real engineering, real rocket science during the daytime. They may have been crazy, let's go get a beer and do a seance or whatever. I don't know. But during the daytime, they were learning how to build a nozzle that expanded the gas that they were generating in the power head. They were learning how to pump fuel where they were going to go. They I don't know that they were doing those squiggles, but they were doing rocket engineering based on what was known at the time. And they actually didn't know it, but so was a young von Braun over in Germany doing basically the same studies that they were doing. And he had a different funding source. So yeah, you can put as much of the seance stuff in there as you want, but if you're not based in the physics and in the engineering of your day, you're just you're guessing. We build hardware. We build hardware that works. We build hardware that can be tested, reproduced, and gets the job done. And the job for us is we want to put the chemical rocketry people out of jobs. We want to replace chemical rocketry.
That's the other thing I wanted to ask you is, do you think there's sort of like a built-in conflict of interest with people who would potentially invest in this stuff? Because those people could also be invested in other huge rocket companies, energy companies, oil companies, that kind of thing. And there could be, do you think it's possible there could be, a huge effort to shove this stuff underground or keep it buried so that, people can continue making trillions of dollars? And the whole world economy is based on oil. And if this stuff becomes,
Do you want me to take
if this gets advanced enough and people can power their jet skis with it, that could disrupt the entire world.
The reality of it is it takes 20 to 30 years for any technology to be accepted by the civilization. That's just the reality. The phone, electricity, running water, indoor bathrooms. These things didn't. Somebody showed the cell phone. It was 25 years before anybody had real cell phones. That's how long it takes. It takes a while for the civilization to accept it. Right now, the civilization around us is very happy with what they have. Okay, they have chemical rocketry to get you off the ground. They have ion rocketry, which is an electrically enhanced chemical rocketry to get you into orbit and keep you there. They're all very happy, by the way. There's nobody that hates the situation of space right now. Nobody goes, I'm not going to put up this fleet of satellites because I have to deal with chemical rocketry. I have to deal with ion rockets or ion engines, and it's just such a bother. I'm not going to do it. Nobody's saying that. They're saying, okay, it costs X amount of dollars to do this. It costs X amount of dollars to do that. We're going to make X amount of dollars. We're going to charge people more for their cell phone service or whatever. Mm-hmm. We're coming into it with, hey, we can offer you a better product at the same cost, but this product has so much more potential that you're going to find new ways to make money. But it's still going to take 10, 15, 20 years before anybody, if we were accepted tomorrow, it'd be 20 years before we have integrated into the current ethos of making money in space.
Right.
Before we're a serious player. So that's the reality of where we are in the big picture.
And I think this would be hard to keep under a lid. It's out now. Mm-hmm. This force, it's out there. People can look at it. People can build it. People can test it. It'd be tough to put a lid on it. Can it solve the energy crisis? Who knows? Can it do all these magical things that we promise? Lifting cars and replacing rockets. Mm-hmm. We hope so.
This might be a really dumb question, but what about like propelling stuff in the ocean?
It's even tougher.
Tougher.
Yeah, you got a big force of drag there.
600 times the density.
If you could find something that was a little floaty, maybe, or like neutral buoyancy.
Sure.
Maybe it'd be.
You have X amount of pounds of force. A propeller, or I guess that's a thruster underwater, whether it's electric or mechanical. All it does is produce force. You're pushing the water behind you to push the boat forward.
Exactly.
So let's say you make 100 pounds of force with your propeller for whatever reason, whatever shape or size you are, underwater or on the surface, on a hydrofoil above it. You got 100 pounds of force from your propulsion system. Mm-hmm. Your propeller is interacting with the water and giving you 100 pounds of net force. Well, that's like putting a box with 100 pounds of net force in the middle of your boat and saying, what could you do with it? Well, you can do whatever you can do with 100 pounds of our force. You could do with 100 pounds from a propeller. You just don't have to stick anything in the water.
Right.
So can it move a boat? Sure. If you got enough force. Can it move an airplane? Sure. If you got enough force. Can it lift an airplane up? Sure. If you've got enough propulsion to offset the weight of the airplane.
And it's a new force. You do what you want with it.
Right.
Use it to spin a turbine, a windmill for energy. You can do anything you want with this new force.
Right. And you guys have done over 2,000 different experiments of this?
Yeah, we showed you a couple.
About 2,500 probably.
Well, it was
2,500.
Easily.
Do you want to talk to this guy?
Oh, yeah. Some of this stuff was amazing. Like we would go to lunch every once in a while, and we would beg Janessa to come with us because she's way smarter than Charles.
My wife.
And she would kick out ideas and we would write them down because that's, and we got really excited when Charles figured out that it was the asymmetry of the system that made it work. I mean, we got super excited because nobody had ever had this thought. And we're like, awesome, look at this. And then, this took hundreds of experiments to get to the point where he had enough data to where he could process in his mind what the data meant. So it took hundreds of these, we call them Pac-Mans because they were little curved things that They were cute little Pac-Man looking things.
Right.
But we burn them up. We'd light them on fire. We just a lot of very bad things. Get very electrocuted, very shocked. But the net result was he turned that idea, all that synthesized data, into a revelation. And once we had that direction, once we had it in our heads that it was the asymmetry, we just optimized the asymmetry. You know, how many ways are there to optimize asymmetry? Okay, well, you could build one side bigger than the other. You could build one side different than the other. You could crank up the voltage on one side and reduce it on the other. So there's a few knobs, if you will, a few tricks of the trade. And then once we had that, we were off to the races. So that's the sort of you know, our stuff isn't linear. We don't go in and say test. Okay, and then we move 1% in the right direction. We'll go days or weeks down the wrong rabbit hole. And it's interesting, and like Edison, we know 10,000 ways how not to build a light bulb.
Right.
Well, we have about 3,500 ways how not to build a thruster.
How many different people are you guys like bringing in to like look at what you're doing and throw out ideas just to get like new perspectives on things?
Well, we've had, you know, chemical engineers help us with some of that route, the chemistry route. Neither one of us are chemists. We have material scientists, physicists, modeling. We did some of that, optimization. Some of that's in the patent too. So different ideas, we can get them from optimization from the programs, the computer, or you know, people do have all kinds of ideas. Try this, try that, try this. You know,
right.
And we can try things as we go, if we wish. You know, that's the right direction. But you know, we've gotten to the point where we know what works and kind of know what doesn't work. And so we might be past some of the traditional try this, try that, try this for these DC version of thrusters. But there's other classes of thrusters that we are going into that are going to be more complicated in the future. That we'll have to go back to the well and say, okay, how do we get the most out of this? This is something we're not familiar with. You know, whether it's a voltage waveform or a material type or some kind of permittivity or something that's new that we're going to keep adding to it. We'll go find those experts for those skill sets to make the thrusters. And we know a bunch of folks in a variety of different fields. So it depends on what it is.
Right.
So that's the beauty of this. I mean, it seems to be working. So why not try something more elaborate, more expensive, and with a better benefit in the end? Now that we know that the base cases are working. So we will find those folks, and if we don't already have them. But
can we see? Do you guys bring like a video showing it creating the thrust, or do you have a video that we can show?
What was that one that was earlier?
It's on you have it like on a scale, right? And it shows you like the weight changing.
Oh, you want to? He's talking about he's not talking about the spinning
or whatever, something like that. I don't know.
We can show you. We can show you of it spinning. I don't know. This is a joke, and of course it's based on an old advertising thing. You know, $350,000 for a lab.
Yeah.
You know, $8,000 in lost time for a bunch of engineers. $32 for the wings and the soda. You know, look on the new guy's face. There's no sane people in the room. Priceless. Okay, you have no idea how many really smart guys have floated in and out over the years and just gone, you people are mad. And then went back to their lives and had great lives. Okay, while we have had our lives. So, and this is a couple of those guys are serious team members, and everybody wants the dream. They all want to help make the dream go forwards, but they're all specialized in their little tiny fields. Like one guy there, a couple people there at NASA. One guy's an electrical engineer, another guy's a prototyping engineer, another guy's a business interface engineer, or he used to be a mechanical engineer, and another guy came from a background of prototyping and building human rated bicycles the bicycles that can go like 100 miles an hour, little bicycle stuff. So our team has had the benefit of genius over the years. And, it's gotten us to where we are now. As far as new people coming in, it's gotten a lot more specialized now that we have a target.
Right.
So, for example, this is a
target, meaning this thing, right?
Yeah.
Well, yeah, we have potential customers, and customers want what they want.
Right.
So we are targeting for the customer interface. For example, this is the thruster basically it's on a stick, and it's just balanced by the weight of the battery and stuff. And
where's the thruster?
It's underneath that
It's
white
in the plastic
plastic
bag.
Originally, it was just on the end of the stick. Then the guy, actually Charles's mentor, said, Put some plastic around it because it could be ion wind. We did. Then we put it in a plastic bag. Then we put a plastic bag over the plastic bag. By the time we got done, we had like 6 plastic bags on the end of this stupid thing, and it still made thrust. And
he was like, "I don't know how this is working."
Yeah, and
colleague I've known for 25 years, a
Really?
Master electrostatics.
Yeah.
Professor. I said,
so
Sid, I told
that's
you.
the kind of people we have on our team, is people that come in and say, this isn't real. And then, okay, well, what can we do to make it real for you? And then they give us what they want. Well, I want to see it put it in a bag. I want to see you put it in vacuum. And we do all of these things, and it passes their test. And then they shake their head and they go, wow, this thing could be real. And then they go off and, go back to their normal lives. And we take what we've learned from them and move forwards.
Right.
So this is a carousel, a vertical hanging carousel, I guess you would call it.
Okay.
So it's balanced. You can't see the other half of it, but basically on the bottom half you have a pack of thrusters. On the top half you have a pack of thrusters, which you can't see. And then the middle is a power supply or Bluetooth. We talk to it through the vacuum chambers. So this is a high vacuum test of a thruster pack, and it's surrounded in a plastic Faraday cage, which is on the left. You can see the ITO, the indium tin oxide plastic.
Yep.
And then we turn it on, and you can see it, rotate. And
So it's showing motion in vacuum,
in high
which
vacuum.
Right.
is very difficult to do. And you can figure out how much it weighs. Yeah, here it is. This is it without
is a
any
sped up
plastic
one.
Well,
bag
that's
on
moving
it.
pretty fast.
No. This
It
video
is
sped up.
sped up. Okay.
Oh, okay.
These are very slow things. Okay. But again, that whole thing is just another one of these white foam
Yeah,
things.
that's styrofoam.
Okay. The whole thing only makes about 125 micronewtons.
Now it's going the other way.
It's because of the torsion in the string.
Okay.
You go as far as you can go, and you cut the power, and it has
And
to
then it
unwind
goes
the
back.
it has to
It unwinds,
unwind
yeah.
the string,
Right.
and then it'll go and it'll come to a stopping point. And you turn it on again, and it winds the string back out.
That's wild.
That somebody said, well, it's not real unless it can do that.
How sped up is this? 2x? 3x?
It's
This was a long video, so we constricted it. That's why we sped it up.
10x,
10x. Wow.
probably 10x.
I don't know.
Yeah, it's sped up.
This took maybe 3 minutes, 4 minutes.
Yeah,
to
it
do
takes
this.
it took about 4 or 5 minutes to go around in a circle. But
Okay. And the video is how long, roughly? So that'll give us an idea of how fast it's sped
I
up.
don't know. It's not clicking on me.
Oh, okay.
I don't know.
No worries.
I'm guessing it's somewhere between 5 and 10x.
There we go. So this section of it's been a minute,
Okay.
but we have lots of videos like this, and this one's real time. This one's
and
not
this
sped
is
up.
this is the
So-
same.
So this is
This
kind
is
of
a thruster with plastic bags on it.
it
to
moves
prove that
almost the
it's
same
not
speed. This is
ion
a
wind.
couple years later, so this is a bit newer than the last one.
And then we said, okay, well, we've done about all we can do in open air.
Yeah.
So now let's
What
go.
I like about this
What's
is
the next thing?
he walks right by it, so you would think all the wind from him walking right by would just stop this thing in its tracks and move it the other way. It didn't even phase it.
That's pretty
Right?
insane.
Did you see that?
and
Did you
this
see
is,
that little
we've
subtlety?
tried different power supplies.
So
And
here it is. It's coming this way. So it's going counterclockwise. Drew walks right past it. Almost
Now,
rubs up
what
against
could
it.
like the world's most vicious skeptic say about this? Like,
Now-
what holes?
that's
could they,
easy.
What holes could they poke in that?
Normally, any kind of thruster that you would do, electric only, the first thing they'd say, well, you're interacting with the Earth's magnetic field.
Mm-hmm.
So, and that can happen, but not for an electrostatic thruster, not for one that doesn't have current. So if you could do the current, calculate whatever current you need to, to charge the plates, and it's tiny, and the magnetic field that you get from that is infinitesimal. So you can't interact with the Earth's magnetic field with our magnetic field because it's so small. And plus it goes around a full circle, so it doesn't matter anyway.
And then we put a super magnet, one of these little,
So that's one of the
of
things.
these super little magnets
Yeah.
underneath it, and it just goes right over the top.
So
Really?
that's
Because
one of
there's
them.
no ferromagnetic
There's a
material.
list of skeptical things.
Wow.
So the Earth's magnetic field is one of them. The ion wind, which we talked about.
We've addressed both of those.
Well, there's half a dozen of them.
There's many of them.
So you have an ion wind, which is basically you're charging the air, and the air is accelerating. So we put everything in styrofoam or plastic or RTV or epoxy, and then cover that in bags if we need to for the demonstration purposes. Our test articles, we don't always go to that rigor unless it's a demonstration. Our test articles, we're fine enough with the ITO Faraday shields, so we make sure all of that's intact. But so you want a Faraday shield that you want to encapsulate it, you want to keep it away from something. You do not want any coulomb attraction near anything, so you don't have any cabinets or tables or chairs feet away. So there's no force of attraction. And then you can see it go around the room. So if there is a cabinet that's attracted to, which is probability less than a fraction of a percent, it still moves past it and keeps going. So
Right.
probability is now 0. So there's so many facets to this that we've addressed every issue multiple times over in multiple configurations, as many as we can come up with. So the very last thing we should do, and we have to do, is just put it in space. That's it. That's the last hurdle. Put it in space and see what it does.
Couldn't you do this? Doesn't NASA have like space chambers you can use?
He's got one here. This is what they would have at NASA. These are high vacuum chambers.
I mean, like a huge one, like the size of this room.
Yes. So that could be another thing. Some of the aerospace companies that we're going to test this for us don't go down high enough vacuum for the large ones.
Yeah, also,
it's basically a belief system.
They do?
Also, I have a chamber that you could put this desk inside of
Oh, do you really?
at our facility. Yeah.
So that is another thing
Wow.
we could do. Get that sucker up online. That's a very expensive chamber. So that is another
and then
thing.
how do you set it up once it's in the chamber?
You probably have to do something like this where you put a framework around it and you
Well,
cover it in a
I'm a
box.
professional aerospace engineer. I built ground support equipment for 40 years. I'm really good at that.
Right.
Whatever test he needs run, I dream it up, all the hardware, then build it, then run the test, and then have him come and take shots, pot shots at what could be wrong. Why could that have done that? Why could it run this? Flip it backwards, flip it to 180, return it 90 degrees. So
do it in other chambers.
we can
Done
do
that
too.
we can build anything.
Flip it the other
That
way.
would
See if
be
it goes the
required.
correct direction.
Yeah.
Put dummy plates in there that look just like your plates, but don't have the magic of the asymmetry that you incorporated. See if they work. They don't work.
Flip the plates.
There's a
Flip the
lot of
structure.
controls you can do.
Flip the polarity.
There's a lot of controls you could do. We've done them all multiple times. Because nothing I hate more, and I'm sure Drew hates it too, is wasting our time.
False data.
We cannot stand that. False positives are
False
a nightmare.
positives.
So we always have to go through the rigor of flipping it backwards, putting in dummy plates, putting in a bigger chamber. If we get something that's really nuts, crazy.
Electrostatic. You put 5,000 volts on a wire. You think, okay, I've just put 5,000 volts on a wire. If the wire is thin, it can actually physically change shape because the electrostatics inside want to get away from each other. The little electrons on the wire want to get away from each other, and they exert so much force on the insulation, they can actually make wires change shape.
Wow.
So if you have wires running to your test article, when you power it up, a source of false information could just be the fact that you powered it up. So in order to stop that, because Dr. Charles said, hey, we need to, that's the next order of operations. I said, okay, took the entire high voltage power supply and mounted it inside the test rig, inside the Faraday cup, inside the Faraday chamber. And the whole thing is now on a pendulum.
So you can see it here. I mean,
So it
you
doesn't
can
matter
strip
if
this down to nothing.
I
There's
shrunk
a little
all that down and stuck it inside of the Faraday chamber, inside the Faraday box.
So if your power supply is inside your box,
Eliminating
that's
one
moving,
more possible source of false
Yeah.
then
information.
that's really, really hard.
And
to
then
fake
ran
that.
1,000 tests in that new configuration.
So
It's been at least 1,000
So
that we've had.
there are
it,
smart people that have
fully
very,
inside.
very good ideas of how to be fooled, and
Yeah.
we've just had to address all of them over the last 10 years. That's what we had to do, and that's okay. That's what we
That's
want.
what the only person we're competing with is ourselves. We are going to innovate so fast that no one's going to be able to catch us.
So that's pretty cool. That's where we're at. I mean, that's not where we're at, but that's to answer your question. Yes, there's at least a half a dozen or a dozen
And
different.
those things that are, you can't see them, but those things are these. This is the actual. That's from like 5 years ago, 6 years ago. But those stacked, you stack enough of those little bad boys up, and you can make a 5 millinewton thruster.
Wow.
Then you put
What is this thing in the middle made of?
that's a sheet of brass.
That's just brass?
Mm-hmm. The yellow stuff is polymer tape called Kapton.
Now, what about like any kind of crazy exotic materials? Are there any like other materials that you guys could think up that would make this stuff work?
I mean, there are.
Yeah.
I mean, I would say there's plenty of options, but you have to know why you're doing them, what you're doing them for. Are you trying to shrink it down? Are you trying to make it lighter? Are you trying to increase the field? Are you trying to prevent breakdown of the plates of the field? Are you trying to increase the permittivity? Are you trying to decrease the permittivity? You know, there are a lot of material questions, and there are a lot of materials that can accommodate those design changes. So the answer is, of the 2,000 tests, many of them are literally material based.
Right.
So, and then, you know, so there's a wide space there, and there's no wrong answers. When people come up with things, there are so many facets in which this thing works. Not all of them are better, as Drew would say. Some of them are just worse. But I think we found like 90% of the time the darn force is there because it is so universal. It's just a universal force. It just is.
Right.
It's hard to explain. And once you know the rules, you'll know before you even build it if it's going to work or not.
The biggest problem, this is going to sound ridiculous, but our biggest problem was sometimes we don't have an off switch. We turn these things on, and in the physics of charging up high voltage materials, whether they be conductive like metal or dielectric, which just means they're non-conductive. Sometimes you transfer charge into or from one material into the other, so that when you turn the power off, the charge is still in there. It's like taking a balloon and rubbing it on a kitty. We don't hurt the kitty. We just rub the balloon on the kitty, and then the balloon sticks to the wall.
Yeah.
Or you rub your hand and you can shock somebody.
Right.
You've imparted charge to yourself or the balloon, and that charge doesn't just instantaneously dissipate. Well, in our case, we're working with electrostatic fields that are so high that we can drive charge into materials that you just don't expect them to take on a charge. Drive the charge down into them.
Wow.
Okay. And once you have the charge driven into the material, when you cut the power, that's the free charge. That goes away and goes back to sleep. But the charge that you've driven down into the materials,
right,
that charge has its own field because it's charge. Charge has field. Well, this is a field-driven phenomenon. It doesn't care where the field comes from. If it comes from live energy or if it comes from frozen charge, it doesn't care.
Right.
As long as what I like to say, as long as the geometry is fixed, the magic, however we set this thing up appropriately, and the charge is present, it'll continue to make thrust. So we'll run this, we'll put together a really state-of-the-art thruster, and I'll charge it for, 30,000 seconds. That's a normal test. And turn it off. Well, it's in high vacuum, and it's got nowhere to go because it's isolated electrically. I'll come back the next day and it'll still be there. The thrust will still be there, which means that it's been making thrust. Maybe it's making 2, 3, 4 millinewtons of thrust. When you come back the next day, it's still making 3 millinewtons of thrust. Now, at some point, as Dr. Charles will tell you, there are no perfect materials. There are no perfect conductors. There are no perfect insulators. So at some point, that charge will bleed off to somewhere. It will continue to migrate through the material. It'll migrate backwards. It'll do something because there are no perfect materials. Well, once the charge bleeds off, the thrust bleeds off. So when we really want to make a stinger of a thruster, we'll charge that thing up for 100,000 seconds, 200,000 seconds. That's a long time. That's a week. And then we'll just leave it be for a while, and it'll just stay on.
Really?
Well, some customers want it to stay
There we go.
on.
There's our after our meeting.
Oh yeah.
What is this?
This
It's,
is
remember the high voltage needle I told you about?
yeah, that was the
There's a brass
that was
needle
the
there.
idea of that was a really
It's a
bad
plastic
idea.
tube over it. And
And again, it's just
What is that thing on the bottom?
it's a plastic tube.
I used the
And
white
it's a piece of
styrofoam.
wire and a plastic tube
Okay.
and a
What-
piece of tape on the end of it.
What the thing? What thing on the ground though?
That's just a block of styrofoam.
Oh,
I have a ruler
tape
there
measure.
to try to measure how far it moved.
But
I had to make sure
when you
it
do
was
the
plastic.
math and you do the weight, that thing was making about 6 millinewtons of thrust.
It was 140,000 volts. So
It was 140,000 volts, but it was making like 6 millinewtons of thrust. Well, that's insane. That's insane.
it's a lot of voltage, right?
Yeah, it's insane voltages.
So Drew's task to me back in 2016 in April, after I went home and did this, after I saw his lab,
Okay.
his task was to me was you got to package that in this thing.
Right.
You got to put that in that little test toy.
Yeah, because
At
the power,
140,000 volts with no ground around it. You know, that's what that had no ground around it.
the power supply for that thing was the size of this room.
So just to
It
get
was ridiculous.
the grounds around it took a heck of a lot of development and understanding,
Right.
because you put 160,000 volts inside of a metal can, it's just going to spark to the can and break, just spark to it. So we had a lot of work to go from that to other designs,
Mm-hmm.
but that's kind of where we started.
So the idea is to do the same thing with lower and lower voltage.
Lower voltage, smaller,
Lower
higher
voltage,
force ratio.
but-
There's a lot of parameters to optimize.
Drop the voltage and increase the force.
Yeah, so we're
Increase the
down to
field,
like
right. If you increase the field, because voltage is just there to make the field.
Yeah,
So
so
you increase the field. So if you drop the voltage, you got to do something like bring the stuff closer together.
The universe
That's-
as a
so
whole
you could keep the same
existed
field.
because of
Exactly.
like,
So
bomb.
we
Okay,
play at
I
the
don't
edge of the
believe in
envelope
that too.
for materials. We play at 10 to the 8th volts per meter.
Mm-hmm.
That's 2 orders of magnitude greater than it takes to break down air.
that's the far view of it.
Yeah.
Oh wow.
So you don't want
I
to
was
be near that
interrupting
thing, but
something. Forgive me. I
Yeah,
just
it was
couldn't remember
lethal.
easy.
It was lethal at every
Really?
Yeah, it was lethal at every possible instance.
so we had to make
So-
something that was
That's why we
non-lethal.
only had our intern run around and change stuff.
Now, how is this stuff different from the Byfield Brown effect?
There are some overlap there for sure.
There's overlap, and he was
I
working
think
with
so.
lots of voltage.
He was
right?
he was a million volts, so hundreds of thousands of volts. Yeah,
Mhm.
in air. There was a lot of ion wind, I'm sure, and some
There
of
was
his,
a lot of ion wind
in
in
some of
Byfield Brown.
his. But I don't think all of it was. I think some of it might have been this effect, because these two effects counter each other based on the geometry. Our effect is much weaker than ion wind, so we want to make sure we cancel the ion wind so we don't see it, because it'll null our force.
Mhm.
So, but I wouldn't be surprised if there was some overlap there.
And
with some of his
isn't
thrusters.
it true? Like sort of what he discovered was utilized for like the skin of some of the stealth bombers. There's some sort of like weird thing going on with the skin of those planes.
That's the lore.
That's not proven.
I don't know if it was proven or not.
I know they
never worked
use
on
that.
those programs.
Right.
I mean, I think when you put a Corona out in front of an airplane or in front of a spacecraft, you're getting a wind, but this wind is like 1 or 2 miles an hour. It's a tiny, slow, very weak wind.
Mm.
It's not strong, but maybe the thought was for them was to try to lower the turbulence of the gas. If it was a highly ionized gas, maybe someone thought that would work.
Mm-hmm.
I don't see how it would affect it in a good way, in a meaningful way, but
Yeah.
it doesn't mean they didn't test it.
Yeah.
High voltage Corona wind is another specialty of a field subset of
Mhm.
electrostatics.
Yeah.
Not something aerospace engineers spend a lot of time understanding and learning. So I wouldn't be surprised if they thought, oh, this is a wind. We'll just add a wind to our spacecraft without any propellers and increase the wind that we're making, decrease the thrust that we need to get the same
Mhm.
speed. We lower the fuel or whatever, lower the friction.
It could have been something as
It could have been something like that, but I
try
don't.
out like they have they wanted to make torpedoes go faster. Okay, well you're passing through water,
Yeah.
so they would. There's information out there that says that they put a small rocket motor facing forward on a torpedo, and then the bigger torpedo propulsion, of course, is in the back. You think, how is
Well, could
that
you do
going to
that?
help anything?
Right.
Well, the rocket motor literally blast gas in front of the torpedo. Well, gas displaces water. So now you're passing through a lower density fluid, which is a combination of gas and water.
Like what creates a cavity right in front of the torpedo?
And apparently that was enough to lower the viscosity of the water, or lower the, not water, but the viscosity of the combination gas and water. So now you're pushing your torpedo through a little bubble.
Right.
Instead of solid water. So maybe you could go faster. That's the sort of thing that I could understand from aerodynamics. Maybe they thought, well, let's do that. Let's push this Corona gas out in front of the wing, maybe somehow magically, and maybe as it gets swept back, it'll reduce the turbulence, or it'll recharge the laminar boundary layer, because that's usually where the drag comes from, is when the laminar boundary layer gets tripped and you go into turbulent flow. Maybe it'll push that back another 10 or 20%, and we'll gain some more laminar flow. Who knows? They could have tried it out. It may have done something. Yeah. It could have just been a good story.
Right.
I don't know. Never worked on the program.
Yeah, it's just so crazy to me how far advanced certain technologies have become, where other ones have not. For like, we can FaceTime people in New Zealand in literally a split second, and self-driving cars can deliver you a Caesar salad. But we haven't figured out a better way than this primitive combustion engine stuff, where we're blasting out chemicals out of the back of a rocket and fire to launch shit into space. And that's seems to be so much money wasted on doing that, when we could figure out a better way. It's just one of those mysteries.
We need to give him a team shirt.
This is a better way.
He wants to join the team.
This tells you that
it's crazy though that you guys are the first people I've talked to that are actually working on something like this. That's what's crazy to me.
And it's not so much an engineering issue. It's more of a physics issue.
Is this your pretzel?
The physics of this didn't exist. This is a pretzel can.
He loves this stupid thing.
This is a pretzel can. If you
it's literally a can that had pretzels in it.
and I put a brass rod down the center, down the axis.
Peanut butter filled pretzels or just regular pretzels?
I don't know. He ate them all.
Okay.
There's no pretzels in there now. Pretzels would not help. And then on the what I did is put a ground sheet in halfway inside the pretzel can. That's only half the cylinder.
Yeah.
So that's the ground. So here's your asymmetry from your high voltage rod to your halfway coated pretzel can. It's a very expensive test, as you can imagine. That's a joke. But no, the expensive part is all the power supplies and all that. But the pretzel can doesn't make a lot of thrust, but it still makes thrust. So that's what was needed, I think, for the last 100 years, like you're saying. The frustration is we don't have a nice new foundation of physics to start from. It always has to start from the foundation of physics and then move up and let the engineers work it from there. Now we have that, so now the engineers can work it from here, because it's a discovery. It's what it is.
Right.
So now what can we do with it? How strong can we make it? What are the end limits of this force? We've done all we could with the known forces at the time. This is something new now. We have a new toy now in this field of propulsion.
Right. Yeah, and then also the most money that I would imagine that the most money that gets spent on things like this are for the purposes of war, which is why they get hidden in these big these defense programs, these defense contractors that are incentivized to keep stuff quiet and not to talk about it, just for national security type things and
maybe
whatever. At least historically, that's a fact.
Nobody's thrown any money at us, so
well, it's not getting buried by ITAR.
Yeah,
if they want to steal my pretzel can,
that's what I'm
welcome
saying.
to it.
My point was maybe that's why we don't see more of it in the public, because it is hidden, because it's being worked on for national defense type stuff and the purposes of making weapons or whatever, which is that would be the only plausible explanation I can come up with to why it would be
to some of these engineers
secret.
If they're working on something and they want, I would love to have a conversation with them.
Yeah.
Because I would love to know how they pulled off some of the stuff I'm struggling with right now.
Yeah.
There's nobody I can.
The
I can't
is
go
those
out
NDAs
there.
are pretty vicious, I've heard.
I don't care. I would sign them.
No, I mean that Dave signed.
Yeah.
They can't talk to you.
Yeah.
There's just nobody out there I mean, is there anybody out there you can talk to? I mean, is there anybody out there doing third order perturbation theory QED?
No, I don't.
And I know there's nobody out there building thrusters that's past me, because I talked to the next. I know the next 5 or 10 guys that are in the realm of theory and building stuff, and the guys that have reproduced my work. There's nobody. There's nobody. I'd love to,
But I mean,
I want to hire them.
On the reverse side, if it is a military thing, it's hidden somewhere in a mountain and it's used for weapons for hurting folks or whatever.
Yeah.
Is there any evidence of that? That some weird craft comes in way better than stealth technology.
I mean, look at the where we're losing a war to Iran. We're not using any crazy exotic weapons with that. I mean, we still have these aircraft carriers, and we're trying to fight against $20,000 drones.
Yeah. So I would think if we had something exotic, we might want to be using it.
Yeah, you would think that
we would be.
You would think if we had that, we might be using it now more than ever.
You have a curious definition of losing if you think we're losing to Iran.
Really?
I believe so.
Well, you think the United States is winning that war?
A very curious definition.
Yeah. Well, everything that I've read, at least, doesn't seem like it's that we're doing too well. But it is definitely one of the hottest wars that we've seen as far as the United States being involved in. As far as like equipment being used, right? It's
been very expensive.
We have lots of
very expensive, and it's
Navy
very
equipment,
conventional.
Very conventional.
It's almost as if they're depleting the conventional so they can fill up the armory with maybe the next gen. I don't know. Maybe they're going to fill it back up with gravity bombs again. Maybe they're going to fill it up with next gen. I don't know. I'm not connected in any way, shape, or form with the military, but.
Yeah, well, I would imagine that we would see something.
There's a video of the chamber.
Man, this is super old.
But I'll just pause it.
Yeah, like, for example.
Oh, jeez, if I can pause it on the right spot.
You can freeze it in the middle. I think you have to go to it.
I got it.
And again, we have a great big viewport on the side of the vacuum chamber. And you're just looking into the vacuum chamber. And this is back when we were just hanging things in the chamber. We didn't have a test stand around them or anything. But there is an ITO box. In other words, there's a
Faraday cage.
A Faraday cage around the test article. That's kind of what the yellow thing is.
Right.
A lot of tape on it. And then it goes, it's just free hanging, and then it goes backwards to a load cell. So nothing's going to move in this test. The whole test is conducted because load cells give you information about the forces they experience, but they only move 1/10 of a millimeter. So there's no motion in the test, but they're tugging on something. It's like every scale you've ever stepped on has load cells in it. That's how it converts your weight into something that it can show you on a screen. So all our forces are against a load cell. The load cell is connected to a data acquisition system, and that's converted into information that can be displayed on a screen. Back when we were showing the other movies, they had a little chyron running along the bottom. We would take all our data that we collect, everything, and put it on the screen and then just video it. It's the fastest way to record all 20 channels. So this is where we've evolved to, is full vacuum, full shielding, and running against a piece of equipment that's digital. So there's no human in the loop here. We run these tests automated. Right. And the way I normally do them is I usually pull back on the string a little bit, put about a 10, 15 millinewton force on the meter, and then see if it changes from that. Okay. That way there's no slack in the string, and you're not changing things. Right. But it takes 12 hours. You put a test article in there, it'll take 12 hours
very impressive
for the stretch in the string to level out.
It's a really nice test setup.
Water vapor on the surfaces. There's molecular water on every surface. It takes 12 hours for the molecular water to evaporate off the surfaces. I can put a brand new thruster in there that I know is perfect. Put it in there, pump it down, run the test, see no thrust at all. Wait 12 hours, and there's thrust. Wow. Well, what was wrong? What was wrong was there was molecular water on the surfaces that was acting as a metal and shorting out the thruster. That's not because it was a bad design. It's because there's water on everything in air. And you
Right.
start by, you got to be able to breathe. Otherwise, it's really tough to work on stuff. So, so we learned a lot about what it takes to do good testing.
Mm-hmm.
And reproducing and good testing is the core.
Mm-hmm.
We come up with a design and we'll test and test and test and test and test.
Mm-hmm.
And this is just that's a couple of years ago. But those are fun days. That was like days when they were a whole lot simpler.
So you said earlier in the beginning of the podcast that you know a lot about the Saturn V rocket.
I believe I do.
How come we haven't been able to create a rocket as good as that?
We have
since the 60s.
Plenty of rockets better than the Saturn V.
Then how come we haven't? Well, we haven't had a rocket like the Saturn V that has been able to work on the first try without refueling.
Saturn V's didn't work on the first try. It was the whole pogo problem. Did you ever hear about it?
No, I didn't. What is it?
Saturn V's the sloshing. You had an instability in the fuel tanks.
Okay.
Okay, and that ended up with sloshing around, so they had to put baffles in the fuel tanks, and that still didn't get rid of the pogo problem. So they ended up that they had
pogo?
to put it's pogo. Yeah, pogo Saturn V.
What is the acronym? What's the acronym?
Oh, I don't know. It's just because of pogo stick. The thing would go boom, 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 boom.
From the fuel?
No, it turned out to be instability in the combustion chamber in the oxygen mix when they were pumping in the liquid oxygen and the liquid hydrogen.
Right.
They're pumping in the liquid oxygen and RP1, which is basically refined kerosene, and they ended up having to put simple circular baffles in the first stage combustor section of the interchange, and that's all it took. And they eliminated pogo on like the third try.
Mm-hmm.
But they didn't see pogo until they were flying. They didn't see it in the F1 test because you don't take your whole the F1 was a monster of a test rig. When they put the F1 engines in the test rig and they fired them all up, you don't take your whole test rig and shake it up and down a couple of times a second like you do your rocket. So they didn't know there was a problem. It was a systemic problem. It was a problem created by the system of rocketry. Well, once they launched and they had pogo and they almost lost the Saturn V to it, they immediately went back to the drawing boards and figured out what the problem was, and they fixed it in 2 or 3 runs. So by the time you got to putting people on board, the pogo problem was solved.
But is it true isn't it true that we never like actually had a Saturn V explode or anything like that? Like the first actual launch with humans was successful. I do not believe they
had a rapid disassembly. I know. I think they succeeded in the Saturn V getting off the deck very well. But they blew up lots of F1 engines.
Right.
At Huntsville. That was where they tested all the F1s at.
Right.
They blew up lots of engines. The shuttle blew up lots and lots of shuttle engines.
Mm-hmm.
They almost gave up on that engine before they got it working.
Right.
Lots of rockets blow up. Lots of rocket engines blow up. They had lots of fuel tank failures. They had lots of there's lots of components in a rocket, and they're all tested independently. And you don't see the failures because they solve them. Mm-hmm. The only time you see the assembly is when everything is actually coming together.
So why don't you think that we've been able to go back to the moon since the Apollo?
We haven't wanted to. Yeah. Bad enough.
We had 10% of the federal budget back then. Now we have 1/10 of 1%.
Right.
It's a different game now.
Plus, it's a mission. The Saturn V was...
but we've been talking about going back to the moon for so long.
Yeah, but the people want to go back to the moon. That doesn't mean the governments want to go back to the moon.
Well, the presidents have been saying it since who? Since
again, there hasn't been enough will to go back
Reagan?
To the moon. There just hasn't.
But the Artemis program has a lot of momentum now. We went around the moon a few months ago. Mm-hmm. So that's the first step. It's a huge step.
They didn't land.
I had 10 years in the Artemis.
But the next, but they're ambitious. So an Isaacman is going to be on point with this. They're going to go into low Earth orbit. They're going to do some demating procedures in low Earth orbit, just kind of what we did for the Galileo program.
The next one, they're going to go into low, or
they're going to go up and they're going to check out transfer and stuff and fuel. I don't know. They're doing fueling next time. Yeah, they're going to do fueling thing because the new generation of rockets they have a different mission. Their mission isn't go camp on the moon at all costs, and we hope we get the astronauts back. That's the old mission. Okay, and that's why I said those were the bravest guys in the world.
Right.
Total respect. The new mission is we expect to get the guys back and the gals. I don't want to limit it. We expect to get everybody back, and we're not going to kill any of the ground crew either. And we want to do this cost effectively. So we want to get some of the rocket back, if not all of the rocket back. And we want to be able to do this on a continuous basis. These are very different launch parameters, very different goals. Okay, this is a very different economy, as Dr. Charles mentioned. There's about a 100th as many people working on these programs as there was. Okay, it's one thing. It's like, you want to build a pyramid. Okay, go get the entire country interested in building a pyramid, and you can build one.
Not just a couple of YouTubers.
Now let's wait. Let's wait 1,000 years, and let's build another pyramid. Oh, but we want to do this with one construction company working with 1/10 of 1% of the resources that we had the first time.
Right.
The technology has accelerated. There's no comparing a shuttle RS-45 engine to the third stage, the S3 engine. There's just no comparing it. Mm-hmm. The S3 engine was a go-getter. It maybe had an ISP of somewhere around 300. The RS-45 engine, which was in the shuttle, which is probably 10 years later, had an ISP of around 450. That's an enormous amount better efficiency. Okay, the new engines that burn what are they? Methane oxygen. Mm-hmm. These engines are ISPing within like 1% of their maximum capability. Mm-hmm. These are incredibly efficient engines. This is amazing. Yeah. They have optimized it now for a different goal.
I think the difference now is not just the government going is part of the Artemis program. They've brought in industry. They brought in Elon Musk to help, Jeff Bezos to help. All these other aerospace companies are helping, and other countries are helping.
Elon recently pulled back on his ambitions to go to Mars and said,
just to help the Artemis program.
To the moon first.
Just to help the Artemis program.
I believe that was so that they could accelerate the lunar program.
Right.
And
because he said he doesn't know if we're going to make Mars in his lifetime.
If you look at it, though, the step from Earth to Mars is big. The step from Earth to Moon is smaller, significantly smaller, right. And you can learn almost everything you need to learn if you stay with chemical rocketry. If you jump to a new technology base, put the moon back on, put Mars back on the table, put Jupiter on the table, put Saturn's moons on the table, because you don't need to learn how to refuel in space. You don't need to have 40 launches to pack enough fuel.
With this technology.
With our technology.
Right, of course.
It's a whole new learning game.
And also, if you're what about if you're using the moon as a launch point to go to Mars instead of the Earth? Now you're not having to contend with Earth's gravity anymore.
Exactly. It's true. We are advertising right now about 0.5 Earth unity. In other words, we can generate about half of the thrust that's needed to pick a rocket ship up off the Earth. But when you look at lunar gravity, that's about 2.5 times lunar unity. So we have
1/8 gravity, right?
It's 1/6.
1/6, sorry.
1/6 gravity. But we have a much, much greater margin for success coming off the moon.
Right.
And then we go into Mars. If we can do 0.5 Earth gravity and Mars is only 0.38, we can take off of Mars too. Mm-hmm. We can leave Mars and come back. Okay, and again, I'm not wearing diapers, so
you're not volunteering.
I'm not volunteering.
He wants to go, but he has to use your technology.
Yeah, I want 3.5 days. I damn near hold my breath for 3.5 days.
Wow.
So it's like, do you have an ECLIS system that's good for 9 months?
Yeah,
that ain't no joke.
Yeah,
that's an environmental control life support system that can run 9 months closed loop. What do you do with the carbon dioxide? What are you going to pack 1,000 tons of carbon dioxide absorber on? You're gonna what? Literally, I spent a lot of years in the ECLIS game, and it's terrible. It's terrible. 3.5 days. Again, you can damn near hold your breath. Mm-hmm. But
yeah, no, it's just astonishing though that out of how many launches that were supposed to go to the moon, what was it, 7? was it 7 launches for the Apollo programs, and then six out of 7 actually landed. Is that right?
Yeah, there
or was it 7 out of
whatever.
8 or something like that? Like the success rate was amazing.
I think we landed 6 and we sent 7.
We landed 6.
It was incredible.
Yeah.
But again, it was the same design that they got working. They didn't change anything.
Right.
They didn't make the rocket twice as good. They slowly began to remove from in between the stages. There were giant rings about 6 feet high, and on those rings were mounted telemetry and test equipment and recording and cameras and all kinds of nonsense.
Yeah.
They, after the first launch and after the first landing, they said, okay, maybe we don't need to have all of this. So they take some weight off, and that could put some more throw weight to the moon. By the time they got to the last landing on the moon, they had removed something like 4 tons of materials from the first and second stages, so that they could, send a car to the moon and bring back 1,000 pounds of moon rock or something silly like that. Those are tiny iterative changes toward a goal. They didn't turn around and say, hey, we want to get back the first stage of the Saturn V. Okay. Do you want to get it back from the bottom of the ocean, or you want it to come land back on the launch pad? They didn't say that. They said, let's take a little more weight out so we have a little more throw weight to the moon. Same basic mission. Let's give the guys 3 days on the moon instead of 4 hours or something. Okay, these are tiny incremental improvements in a system. Those you can do. It's not amazing that we got 6 out of 7 tries. It's a testament to they tested them 10,000 times before they sent the guys up there.
Right.
And
it's just amazing that
enough.
it happened at that point in history, that long ago. And we haven't been able to come close since, with all the advancements of technology in every other field, right? Except for that one. That's the one that seemed to go backwards.
I spent 25 years working on the shuttle program. That was a pretty amazing flying machine.
Didn't we use the same shuttle engines for this Artemis launch?
It is the same liquid engines.
The same engines,
RS-45. They're actually shuttle engines because they were the finest liquid oxygen engines ever made. They had the highest ISP, which is the efficiency factor of a rocket engine.
Yeah.
They were a great design. They were stupid expensive, like, I don't know, 10, 20 million bucks a piece or something like that. And they took forever to manufacture. And I believe they're starting the line back up for more Artemises. I believe
they're coming out. Going to be 2 missions next year.
Yeah, I believe they're starting the line back up. But there's nothing.
I was so shocked when the one that happened recently happened, because that one had been getting pushed for so long.
Yeah, I put 10 years into the predecessor
There's a better
of the
cadence
Artemis
now.
program.
Yeah.
We've been missing the cadence for a very long time.
Are these rockets they're using reusable or no?
No.
For the Artemis, they're not.
Everything goes in the ocean.
Everything goes.
The only thing they get back are the people and the little Orion
capsule,
and it's not reusable. I think theoretically it is.
Yeah.
I worked on the building where they resurface it, and I don't think I know the heat shield's not.
Yeah.
And I don't believe the capsule is, but
yeah, my best argument for that, what I just explained, why we haven't been back, is that it's not practical to send people to the moon or to Mars when we can send robots and drones there to do the job just as good as any human being could do. It's just too dangerous.
Again, and that's a great
I feel
idea.
Like the Apollo missions were just a flex, that we were just trying to beat the Russians to the moon. That's all we were trying to do. We're trying to be the number one to put people on the moon. It was just it was a publicity stunt.
You were completely right, and it was a brilliant tactical motion. It showed that we had not only caught up to the Russians, because they were way ahead of us before that. They did the first orbit, they did the first dog, the first Sputnik thing. They were way ahead of us. We caught up, then we went past them. They put the first lunar rover on the moon. It was a little nuclear powered tank. But we caught up to them and we passed them, and then planetary, we surpassed them. We did the Mars programs. I don't think we've done anything on Venus, so they were ahead of us on the Venus landings.
Right.
But Yeah, it was another extension of the Cold War, I believe.
Right.
And it's been my opinion that NASA has been a ping pong ball of the political scheme forever. They were born a ping pong ball. There was nothing wrong with NACA. It was making airplane wings and doing great. And then they said, well, we need to have something that does space because, the godless, commies are going to take space from us.
Right.
So they created NASA, and it was a ping pong ball of politics ever since. They cut the budgets, they expand the budget. They give them a mission, they cancel the mission. They tell them to produce hardware that is technologically the bleeding edge. Then they slice the teams up, and they come in and they rearrange the what they want them to do. It's terrible. It's not how you build a rocket. But
how much technology, if any, do you think NASA has that it's keeping secret? Think it's possible? I mean, I know it's kind of you're technically employed by them, but if you could speculate.
Well, I mean, we're public. We serve the public, right? So every time we have a new technology, we have to report it.
Right.
So we have
legally
new technology reporting.
Right.
And we put it out there. We want to report it because then we could maybe get it patented and get it licensed, and then we can benefit from it. The employees benefit. It's not like a company where the companies benefit.
Have you heard of the story of Gary McKinnon, the hacker guy who hacked NASA?
Yeah, I heard of him. He's living in England or whatever.
Yeah, the U.S. tried to extradite him back to the U.S. to put him in prison for 80 years because he when he was a kid he did some hacking stuff, and he tried hacking the Pentagon and ended up getting into NASA, and he found some image of this Tic Tac object floating in outer Earth orbit, and it was like a document that was referring to non-terrestrial officers or something crazy like this. And as soon as he saw the thing with obviously he can't prove it, but this is what he said, and we know for a fact the U.S. threw everything but the kitchen sink at this guy to try to get him to come here so they could put him in prison. And it's crazy that he described this cigar-shaped white metallic object and on a NASA database.
Dude, nobody believes we're real, and we don't follow the UFO crazy stuff. Do you want us to speculate on it?
I heard all these stories. I can't verify any of these things. NASA has people that go in and erase images before they give them to the public. I don't know if that's real. I just don't. We just had a mission to the moon, right? We landed our payload on the moon, the electrodynamic dust shield. It removes dust from surfaces as part of the Firefly payload last year.
He invented that, by the way.
And then, we had companies take images. They take high definition movies of the moon, and they give them out. So we don't, NASA doesn't control a lot of that. Maybe they did a long time ago, but I don't think they control it now. So I think companies can easily take super high definition, videos of the moon and everything and share them. It would be a massive conspiracy if there was giant buildings on the moon and all these structures and all that stuff.
Yeah, that's another crazy one too.
That's another crazy one.
There's stories about that.
But the imagery that comes out, not just in America, but the companies in America, China, don't see anything like that.
Oh man, there's this dude who allegedly was in charge of mapping the moon for the Apollo missions, and he worked for NASA, and his name was Hal Povenmire. Have you heard of this name before?
No.
Never heard of Hal Povenmire? So I heard that this guy worked for NASA, and he allegedly mapped the moon, and he told somebody that there was crazy structures, ancient looking structures on the moon.
I've heard of that too.
Yeah. And there's other people that have talked about that too. There's other people that, stories that are unverifiable about that, but it's just interesting,
It's interesting where these stories come from.
Yeah.
All the
giant
more reason.
Cannons on the moon.
All
cannons?
Cannons.
I haven't heard of that.
Yeah.
I did see something a couple of years ago of the head of NASA talking in front of Congress, being asked about exploring the dark side of the moon, and the congressman was grilling the head of NASA, one of the previous heads of NASA, and he was like, the Chinese said that they're actively trying to figure out what's on the dark side, do studies on the dark side of the moon. And he's like, why aren't you doing that? He's like, oh, let them do it. We have no interest in that.
Okay, you do know there is no dark side of the moon, right?
Well,
there's the
what
side
I'm saying
away
is that,
from us.
that's what I mean.
Okay,
the side that's not
just
facing the moon.
because there's so many people out there that think the world's flat and whatever, all the crazy nonsense.
Yeah, the same side of the moon that's constantly facing away from Earth.
Right.
That's what I meant by that.
We have plenty of satellites that map all that.
Mhm.
Yeah.
I mean, so that's not
The Lunar Explorer
the LRO.
was able to take pictures all the way down to the pole that was laying on the ground that the flag used to be on.
Right.
So, and they've
Wow.
mapped the entire moon 20
Right.
times over.
Yeah, so
Yeah.
it
They've
would be
literally
a-
mapped the moon 20 times over.
Yeah.
And they can see things. They can see a 4-foot high pole or whatever laying down on its side, and all the little footprints around it.
Mm.
So if you're hiding a city or cannons or something on the moon, you're doing really good. You're
there's some-
really, really good at that.
There's definitely a lot of high definition video of the moon.
Right. Have we seen high definition footage of the opposite side of the moon?
Yeah.
Mhm.
Oh, we have.
Absolutely.
Oh,
The
that's
Lunar
it's
available.
very well
Explorer,
mapped.
Oh, wow.
It's very-
Publicly?
of course.
Oh, wow. I've
all
never
of
seen that.
NASA's imagery is public.
Sure.
Oh, okay.
There's a Lunar Planetary Institute. Lunar Planetary Science
By that,
Institute.
it's like saying all of the Hubble raw data is publicly available. There's, I don't know, 50,000 gigabytes of Hubble data that
Mhm.
you can go download it any piece you want. But there's 50,000 gigabytes of it.
Yeah, that's the hard thing is
You
trying
know
to
what's
go
crazy
through that
is
data.
I learned from an astrophysicist recently. He was saying that all of the highest powered telescopes that we have at the observatories, whenever they have to, I guess they have to process the images that the telescopes produce, they have to pass through the Pentagon before they can be released publicly.
I've never heard that. but-
ChatGPT it, Steve.
Okay.
Find
Okay.
the source.
It would be a,
I've never done.
This was a
I've
like
never
a New
done
York
prof-
Times article, I think it was.
I've never done professional astrophotography, but
Yeah.
I did 30 years of amateur deep sky astrophotography.
Mhm.
10 of it with that monster of that telescope. Go to the next one.
Mhm.
10 of it with that monster. I have thousands of deep sky astrophotographs. Of those thousands, I have one that, and I'm like, okay, I don't know what that is, but it sure looks like a meteor.
Yeah.
One out of thousands. Okay, and I did deep sky astrophotography for real
Yeah.
for 20 plus years.
Never saw anything that just like made you more curious or anything
No.
like that.
I mean,
And I
think
had
the
big boy
UAP
toys.
And you're not interested in it whatsoever.
In what?
Like the things flying around that could not be explained or anomalous.
I never
stuff?
saw one.
Just never saw one.
I saw plenty of stuff that belongs up there,
Yeah.
and took some fairly decent pictures of it.
hmm
By today's standards, they're jokes, but
hmm
technology
Most people that
has
see
gotten
things,
so amazing.
I feel like most people that report seeing weird things in the sky, they always seem to be near like military bases or Air Force bases, things like that. Like there's lots of stories.
Maybe.
Yeah, I mean, I've seen weird things, but I don't know about taking images and giving them to someone first before you release them, kind of thing.
Yeah. Well, I'd imagine. I mean, you
I don't
guys
have
are
any
right
experience of
there
that.
in Titusville. There's a
Oh,
lot
yeah.
of crazy stuff, military going on there, and space stuff going on there.
It's mostly civilian. I mean, they haven't thrown anything military.
There's a huge Air Force base over there, right near Melbourne. I used to
Yeah,
surf behind all the
Patrick.
time. Patrick's Air Force Base. Yeah.
Patrick Space Force Base.
It's Space Force Base.
Of course
Yep.
it is.
I thought it was Air Force Base.
It
was.
was.
Oh, that's when I used to know it, when it was Air Force Base. And I think they're doing a lot of work with Northrop Grumman there too. Like there's a lot of
There's a large
overlap.
contingent.
I've heard. I know somebody who used to work.
There's a very large contingent of Northrop Grumman down in Melbourne and,
Yeah.
and down in Palm Bay. And most of the big aerospace companies are moving out of wherever they are and setting up shop within 20 miles of the Kennedy Space Center.
Whoa.
We've got Lockheed Martin bringing the Fleet Ballistic Missile force to Titusville.
I read about that.
And that's great. I mean, that moves more space amazement and space technology into an area that is becoming the hub of space research and space launch capabilities. That's why we're there.
Mm,
The world's first warp drive company.
that's amazing.
Shameless plug.
Yeah, no, I imagine that there's got to be all kinds of crazy stuff going on the West Coast or on the East Coast of Florida. You know, stuff that could not be explained that people would be seeing in the sky.
So the short and long of it is there's lots of stuff up in the sky.
Yeah.
Some of it you can readily figure out what it is. Some of it turns out to be reflections. Some of it, who knows, might be unidentifiable, cool stuff.
Yeah.
Let's get up there and find out.
Me and Steve saw something actually right off the coast over on Indian Rocks Beach on the West Coast over here about 2 years ago. We had a gentleman came on the podcast, and he brought us out to the beach, and we sat there and we stared at the sky for like 2 hours. And first of all, that's the first disclaimer, is I've never stared at the sky for 2 hours at night.
Okay.
So we sat out there, and Steve brought his camera, and we were staring at the sky, waiting for some orbs to pop up or some anomalous lights to pop up. And we could see we got used to the airplane traffic, right? We saw all the airplane traffic. We saw the planes that were landing in Clearwater. We knew the planes that were landing in Tampa. They all had the lights. It was easy to distinguish the planes. We could see the boats on the water with the lights. And at one point, off the horizon, this orb of light pops up off the horizon, and starts moving. It goes like, imagine this table is the horizon. It goes like this, and then starts going like this.
One went straight
orb.
up, and then it fizzled
and then it
out.
got really, really bright, and another orb pops up and starts going the opposite way.
Oh, wow.
And then fizzles out. And I had never seen anything. It was not an airplane. There's no way that was an airplane.
I have the video on my desktop.
Yeah, check this out.
So to set up for people watching, or you guys too. So this right here is the horizon.
You can kind of see the horizon right there. You see that?
And then, of course, you'll see planes. This right up here is a plane, and I don't remember what this is, but you'll see it pop up right around here.
So that was a plane flashing.
Okay.
There it is.
Right off the horizon. See that?
It's not red? Was it red?
Yeah.
Watch.
It goes up. It fizzles out.
Now it starts moving to the right. You can see it moving past.
One appears on the top and moves to the left.
Oh, yeah.
Now watch. It'll just disappear.
And then it gets brighter. And then it disappears.
Yeah, that one gets super bright.
We saw that a few times.
Look how bright that thing gets.
Brighter than the plane. And it's off the horizon. That plane is, I don't know how far the plane is.
And then it goes
like
away,
closer.
right?
It just disappears. Yeah.
Wasn't a boat. Wasn't a plane. I don't know how to explain it. It's the first time I've ever seen anything like that.
That's
Yeah,
interesting.
I told Jesse about my experience with those things.
Is that
something similar to
what your
that?
things look like?
Oh, hell yeah.
I wish I'd have known this
That
before
far
you
offshore?
were hooked up with me.
It was about, I would say, 3 miles offshore. I don't know if you watched that podcast that I did with him. I talked about it. I don't know if he aired it or not, but it was
I
weird.
saw it, and I saw it on thing.
Yeah. Yeah, my wife went out there to the beach like we always do at night, just hanging out.
What beach?
This would have been Cocoa Beach.
Cocoa Beach. Okay.
So just South Cocoa Beach,
Right.
just north of Patrick.
Right.
And we go out there all the time, and we went out there, and I'm going to say it's like 9:30, 10 o'clock at night, something. There's not a lot of people on the beach, if any.
Mm-hmm.
And we see a light 3 miles away, and it's pretty still, kind of like that. It just comes up and it gets real bright. It gets real dim. It gets real bright. It gets real dim. It's not doing anything. It's just getting bright and getting dim. It's undulating. It's kind of just getting bright and dim. Like, that's weird. It's just a weird boat doing something.
Right.
I don't know what it's doing.
No noise or nothing?
No, but then it gets real bright. Like, oh my God, nuclear bomb went off bright.
What?
It got so bright, it lit up the whole beach. As far as the eye could see, it made shadows of us against the buildings behind us. As far as we looked left and right, we couldn't see anyone else on the beach. And this giant explosion out there. I said, oh my God, we got to call somebody. And Janessa is like, well, it's the Air Force Base. They'll come out soon, or they'll come out to check it out. And sure enough, within 5 minutes or so, a couple of helicopters went out. Maybe 1 or 2 helicopters went out, hovered right over the damn thing.
Really? While it was still lit up?
It got dimmer,
Okay.
but it was still there, doing a little undulating thing. Got real dim. I'm like, it must have, maybe it's a shut off a flare. I don't know what it was, but it was so bright, much brighter than a flare would be. Lit up the whole beach. And we were like 3 miles away. A flare would not light up our whole beach.
No, not like that.
Not like that.
Shadows.
It looked like a giant nuclear weapon. It wasn't a mushroom cloud with it, but it was just the brightness of it. And we were like, this is weird. So the helicopter hung over for a few minutes and then just went back, and the light was still there. I'm like, are they going to rescue these people? Are they going to send boats? Are they going to do something? Just anything. I don't know what. So we sat there and kept watching it. It's about 10, 15 minutes in later, the light started getting bigger, started getting closer. So we're like, oh, that's weird. Janice and I were still looking, and no, it's a light. It's undulating. It's going bright, getting dim, getting bright, getting dim. It's getting closer. Now it's 2 miles offshore. Then it was a mile offshore. And then it gets freaky. Now,
like directly, if you're facing the Atlantic Ocean directly off the beach from you,
it came right towards us. It did a beeline for us. And, it didn't go super fast, but it was moving fast enough that we can tell that it was coming towards us. Or it certainly looked like it did initially. And then we knew it was definitely coming towards us when it got half a mile offshore. And then it got about a third of a mile offshore. And then it split into 5 or 6 lights. And then it got closer. This is the crazy thing.
Closer than a quarter mile?
Oh, man, this is super close. These things were like the size of like a basketball. I don't know. They weren't very big.
Right.
But they were very close. They were just where the waves started breaking. Like, oh, my God. Like 200 feet out, maybe?
Right.
Something like that.
Right.
And they went and rotated these 5 or 6 lights, went like bicycle spokes into the water, halfway out of the water, halfway into the water. And they just kept doing this. And it was like the freakiest thing. I don't know what the hell it was. So we were walking away. Like, this is too close. So we've already started hightailing.
I would have been
north.
sprinting.
So we were like, we're going to walk. And it followed us. Kept getting closer.
While it was doing the spinning?
While I was doing the spinning, the spokes in the water coming back out. And I'm like, there's no one on the beach. No one can see this. And so it got to the point where we started getting scared because we couldn't outrun this thing. This thing just came from 3 miles over here. And this is 45 minutes in. This is about way more than half an hour. 35 minutes of this experience. I'm like, this thing's not going away. So I knew my little alien tricks because I studied them for a long time. I was a kid. Always followed this phenomenon just for fun. Like, just close your eyes and just tell it to go away. And that's what I did. So I just said, Janessa, I'm just going to tell it to go away. Because when you get scared, it knows. And it went away after about 45 minutes. So
really?
It didn't get any closer once the waves started breaking, but it did not go away. It wouldn't have gone away if I didn't tell it to. I don't think it would have gone away unless I told it to.
And
it was kind of just
completely gone after that.
It was completely gone after that. It did the wave thing into the water, boop, 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 and didn't come back out.
How long ago was this?
2013, 2014, 2013. Wasn't that long.
Whoa, dude.
And it was a good half an hour, 45-minute thing. And I just, to this day, we were like, okay, this is going to be on the news. There was a boat that exploded. I'm sure we weren't the only one to see this. There's hundreds of buildings and apartments and condos. Someone had to have seen this.
Mm-hmm.
So we looked at the newspapers
Right,
the next day, asked people that lived there. No, I didn't see nothing. It's like 10 o'clock at night. It's not like 3 a.m. It was like 10, 11 o'clock at night. It wasn't even that late.
Your wife described it the same way you did.
Oh,
she
yeah.
definitely saw it too. It wasn't just you.
No, it was 2 of us. And we didn't go back to the beach right away after that.
Wow. Oh, dude.
It was scary, but it was like not super scary. But once it got a little bit too scary, told to go away and it went away. But I don't know what it was. I don't really know. But I don't think it's super uncommon. Like Stephen Greer takes his folks, and you know who Stephen Greer is.
Yeah, I know who he is.
Whether you believe him or not, I know he does take a whole group of people down Vero Beach, about an hour south.
Vero, yep.
And they get the chairs and they sit up on the beach and they summon these lights when they go. Every 2-3 months, he takes a contingent of people
meditate
and they
they
just sit on the beach and they say, think happy thoughts, and then his lights will come and you'll see 4, 5, 6 lights. They'll be on the horizon just dancing.
Mm-hmm.
Last 10, 15 minutes and go away. He does that all the time. Don't know what it is. There's a lot of cruise ships sightings, probably more popular.
That's a huge cruise ship port right there.
There's
right?
a huge, Cape Canaveral is a huge port. And there's a lot of sightings off of cruise ships of these same red, what you saw, what I saw, things following the cruise ships like dolphins do.
Yeah.
Following the cruise ships.
Right.
People have that on video. No one knows what the heck it is. I don't think anyone knows what it is. I have no
I
idea.
wonder if those dudes in the helicopter knew what it was.
They knew. They might know that it's there. I haven't. I'm just
They're
speculating
probably
what the
just-
military does. They're just like,
They have to be aware of it, obviously.
yeah,
If
they're like, okay, they know what it's not. It's not the
Right.
Russians. It's not the Chinese.
right.
So, okay, it's not them. We'll be fine. Let's go back. That's my guess. They know what it's not.
Wow.
That's all I know. But it was a heck of an experience.
I can't imagine. I wouldn't have been able to stop thinking about
one
that.
I can't forget. But I believe you've seen this because I've
Yeah.
seen these. Over
Yeah,
the
and
water.
it's it's on video too, so it's like that didn't just like haphazardly happen to me. I went out searching it.
Yeah.
Like this just happened to you without asking for it to happen. Like we were begging. We were on the beach for 2 hours. This guy was saying he could do it.
And I told my buddy about it, and I said, "Well, you could try going and looking for yourself." So he went out with his family. Make it 2 years later, 3 years later.
Mhm.
He's Charlie. I saw the lights.
Really?
He's like, "Yep." He's like, "Yeah, I saw them." I was like, Did you try to summon them? He said, "Oh yeah." Did they follow you? Oh no, I ran.
That's crazy, man.
But him and his family.
I wonder
saw
if it
them.
has something to do with that area in the east coast of Florida.
I don't know. I have no idea. I can't even speculate what the heck that is.
Yeah,
I mean,
that's
even as
bizarre.
close as they got, I mean, I could see how close they were.
No feelings associated. No other sensory.
You know, it was almost like it was not communicating, but it was basically like, "Hi, hello.
Just friendly.
Do you want to talk? Do you want to maybe get a little closer?" You know, if I had to give it a voice, okay, you're scared. I'm going to go away. You know, and that was it.
Wow.
And that was everything. There was, I don't know what it was. I don't know. I couldn't even speculate. There was no solid object. It wasn't a ball of light. It was
Mhm.
really just weird. It wasn't like
Yeah.
an orb. I don't know what it was.
Yeah. It's very strange. It's very strange.
I
It's
don't. I couldn't even
mysteries.
comment on it.
Yeah.
Don't ask me. I can't ask Drew to build that. I don't know,
Right.
I don't know where to begin. What that is.
Right.
Yeah.
Yeah. No, it's interesting too that how you said like you close your eyes and it went away because it just seems like there's a consciousness aspect to all this stuff.
Oh,
That's
yeah.
it's hard to put your finger on. It's hard to weigh it and measure it and experiment with it. It's just
I mean, like I told you, I believed in telepathy because of the experiments I've done as a kid and continue to do. And I just tried it with this things and it seemed to work.
yeah.
That makes the most sense to me just
Definitely.
to try because we don't know the physics of telepathy, but there's something going on there.
There's something there. I mean, if the government spent that millions of dollars on those programs during the Cold War to experiment with that stuff, there couldn't be nothing to it, right? There had to have been something.
There's something. We don't understand it, but it's there. Just
Mhm.
because
Right.
we don't understand doesn't mean it's not there.
Exactly.
Same thing with clairvoyance.
Mm-hmm.
Telekinesis, I don't think there's any proof of that. But telepathy and clairvoyance, I think there's something to it.
Mm-hmm. It's funny enough. I had I ever heard of a guy named Dean Radin.
Which one's that guy?
He's a CIA contractor scientist who's very much into studying this kind of stuff. And anyways, he is like an expert on this stuff, on this telepathy, clairvoyance stuff, like the Stargate program stuff and all this. Uri Geller and all these people. And like he was explaining how all of like the brightest minds in science that he knew of, this was in the early 2000s, maybe late 90s, in his field of what he was studying, they were getting contacted by Jeffrey Epstein to study this stuff. And he even got a request to talk to Jeffrey Epstein and ended up doing a 20-minute Skype call with him. And I was like, what happened? And he was like, he just asked me to tell him stories about spoon bending for 20 minutes.
Weird.
Very weird.
Yeah, he was flying like top scientists in all kinds of fields.
We were talking
And to
about that
see
on the
him.
way here. The fascination Jeffrey Epstein had with scientists.
Yeah. Yeah. He had lots of weird that's just something that I don't know what it is, but there's something weird that happens with people that just have like an insane amount of money that they just, maybe they get bored and they just start getting interested in stuff that, is unconventional. But he was definitely obsessed with, gravity and this kind of telekinesis stuff and telepathy, and they had a submarine. He was allegedly looking for like Atlantis and stuff, like wild stuff. But, you know, talking to real scientists and trying to do real research on it, you know, even working with the NSA, trying to figure out how to extend his lifespan using like code hacking and stuff like that. It's wild. Twilight Zone stuff. But
maybe one day we'll be rich trillionaires.
Well, when you have one of the guy, when you have a guy, the lesson
weird
here,
stuff like that.
The lesson here is when you have a guy like that reach out to you to fund you, make sure you do an extensive background check on him. Make sure he hasn't been arrested for, any kind of crazy charges.
The only background check I'm going to run is, does his check clear?
Well,
Dude,
unfortunately, that's what all the other ones have said too.
I want to build spaceships, man. I don't care what they want to do with them.
Well, you just got to make sure they haven't been caught up in any like international human trafficking rings. Then you're good.
I don't want any part of that. That's
well,
not
guys, thank you so much for doing this. This has been a mind-blowing conversation, and I'm really grateful for you guys spending the time to come over here and explain this stuff to me and to the audience. So
thank you very much for having us. I think we both
it was a
enjoyed this very
blast.
much.
Yeah.
Cool.
So may I ask a personal question?
Of course.
Do you think we're crazy, or do you believe us?
No, I totally believe you guys.
Okay,
I think
that's
you
it.
guys
We
are
don't
on
have him on the team.
Give me a shirt, baby. Sign me up.
Yeah, he brought shirts.
We have him somewhere. We brought him.
Oh, I got him. He gave him to me earlier.
Yeah, man. No, I think this is fascinating stuff. And you guys obviously know your shit. You guys have, very credentialed, legitimate people that are doing this kind of work, and also at the same time willing to talk about it publicly, which I feel like that's very, very rare. So you guys are super important, and I'm happy to help boost your signal as much as possible.
That's awesome.
Well,
yeah,
thank you.
we love when people want to come and put their hands on the hardware.
Yeah.
Actually hands on. We'll run a test, we'll crack the chamber, pull the thing out, disassemble it, put it in their hands, and they're like, this is what was just tested? And I'm like, yeah, you just saw it tested.
Yeah.
And because there's nothing to hide. If the thing works, it's going to work all the time. If it's phony, then it's a parlor trick.
Right.
And someone's going to be able to see through it.
Mm-hmm. I totally agree, man. Tell people where they can learn more about your stuff. Do you guys have a website, social media links, or anything like that?
We do.
Did he change the website name?
I don't know. It used to be.
Sorry, you can send it to me.
Yeah,
you can send it to
we're
me
gonna
after
have to
this,
send it to
and
you.
we'll
We're
link
going
it.
through an IT upgrade because we need it desperately.
Okay. Well, either way,
None of us are IT literate.
I'll put all the links to the websites and stuff.
Yeah.
in the show notes so people can find them.
Yeah.
I found what you were talking about, Danny.
What did you find, Steve? Let's see.
It was reported in the Atlantic, and the article
Atlantic. That's what it was.
When a telescope.
When a telescope is a national security risk, it concerns the Vera-C Rubin Observatory, a federally funded telescope in Chile, designed to repeatedly photograph enormous areas of the sky. Okay, and then what does it say about going through the Pentagon?
Every 30 seconds, it was had to be sent to a secure facility in California for some reason.
Huh. So small image cutouts that might show classified American satellites or spacecraft are withheld from the real-time worldwide alert system. The rest of the data is released in approximately 1 minute. Okay. The complete unredacted image is released 80 hours later once the information is considered too old to reliably reveal the classified spacecraft's current location. That's their explanation for why they do that. Still interesting.
Yeah.
Wow, that's a lot of data.
Yeah, quite a bit.
That's the largest. That's the largest camera on Earth.
The one in Chile?
On that telescope that they just came online. That's the largest camera. It's like 130 terabytes per image.
Holy shit.
It's ridiculous.
Smokes.
It's insane because they have like 2,500 cameras on their imaging system, and it scans. They found millions of asteroids.
That's it. Look at that.
They found hundreds of thousands.
That's where they found those
asteroids.
interstellar objects that Avi Loeb talks about.
Oh,
With
really?
that thing, I believe.
I mean, that's a super project. They're going to map the whole sky every 8 months or something. and find like near Earth. And I want to talk about just one last thing, and then we'll go away.
No, we got plenty. We got all the time you need.
Let's say you see something in the sky, scary, and you have 3 to 6 months to do something about it. It's
Like
coming
an
at you
asteroid?
like an asteroid. Okay, not a planet killer, maybe not even a continent killer, a city killer. Okay, something. What are you gonna do? Really? You call Ghostbusters?
Armageddon.
You got to shoot a nuke at it.
No, that's not the answer to anything. The answer is have a plan and have some way to send a bunch of little thrusters that never have to turn off, so that you can get out there in a couple of days, put the thrusters on the object, turn them on to full blast, and push the thing out of the way. We're asteroid defense.
You think this could push an asteroid off its trajectory?
Easily.
Wow.
Because it's got it. How big's the asteroid? I don't know. Put 1,000 of them on there.
Mm-hmm.
The thing is, today in chemical rocketry, it could take you a year to get to the thing, 2 years to get to it. Well, by then it's a little bit late. Let's say the thing is going to hit the Earth in 6 months. With us, anything in the inside the orbit of Mars is a couple of days to get to. Either side of the sun, we don't really care.
Right.
So we offer
Because your engine doesn't stop running.
Right? Because we offer a realistic way to get to where you're going. Look at the problem, analyze what the solution is, and then execute the fix.
Right.
You don't need to blow the thing up. You just need to move it a little bit.
Right. What is the conventional way that they plan to do that? Like, isn't there like a conventional plan on how to deflect asteroids?
Well, sometimes they put
there is no
thrusters
real
on there.
plan. They did some testing. They went to this little asteroid and they slammed a puck of copper into it or something.
Oh, really?
And they changed the little asteroid, the little tiny asteroid. I mean, the thing's like the size of this room.
Mm-hmm.
They changed its orbit, and that was great. They studied the results of it, and it was amazing. It was great. But it took them like 2 years to get there.
Yeah. Oh, wow. Really?
And it was a stable. They knew exactly where the thing was, and they planned a whole mission around it. What I'm saying is, they're out there looking. That observatory, that amazing observatory, found like 20,000 new asteroids in its first run,
Right.
the first couple of hour run or something like that.
That's crazy.
Okay. Well, they're going to run that thing. They're going to find 20,000 asteroids a day forever. New ones.
Yeah.
What if they find one they don't like? We're saying somebody come believe us and let us show you how we can build something that might be really useful someday soon.
Totally.
Because chemical rocketry ain't the answer to
You
nothing.
could send it out to one of those interstellar objects too, just to look at that.
I did the math.
Wait for a
we
nice
could catch it.
billionaire.
Really?
We up for about another 2 months. We could catch it.
That's amazing. That this telescope,
You got
these huge telescopes, since they've been brought online, they've already detected 3.
Yeah, that's us. Yeah.
Oh, there's a website. What
Our
is the
website goes up and down.
ExodusPropulsion.space.
Yeah, that sounds like it.
Fantastic.
Yeah, we're not real good with that. That website's terrible.
We'll link it
But
below.
it's the best we got. We're working on it. We're
looks good to me,
working on
man.
a lot of things. And the website, we got a genius now on the team.
I love it.
And he's going to, like I said, you can go out to any one of those videos and one of them will show you how to build a thruster. I think the first one, a terrible picture of me, but will show you how to build a thruster. They'll show you how to build this thruster right here. You can build this thruster. I think I use this in the example. And when you get done, it will reward you with working.
That's amazing, man. Well, we will link all this stuff below for folks. Thank you guys again. I very much appreciate it.
It's been a lot of fun.
It has been fun.
Good night, folks.
When was that interview taken?
All right, fellas. Sweet. Riveting conversation, lads. Auf der Heide blüht ein kleines Blumen und das
Hello? What are you doing right now? Hello? Hello?
Hello?
Why are you guys so silent? Have you run out of topics today?
Hello. That's
Hmm. Yeah.
what's up? Good.
Yeah,
Hello.
fine.
What brings you to the Flat Earth Discord?
you have these guys that are 20 miles apart, and I'm not necessarily, I don't know exactly what they're looking for, but I know what they should be looking for. And they should be looking for a bulge in the water that protrudes to cut their laser off, right?
Yeah, like
Right.
if the Earth is a globe, gravity is pulling all the water down on the Earth, so therefore
Right.
water
And
should
the
be
sides would be
curving.
further down. Right. And so I was proving this to this guy earlier that like you can do this with surface tension in a swimming pool, a very large swimming pool, a cup, anything. And if you put too much water into the pool, it'll bubble around over the pool. It'll be higher in the middle. But as soon as you add any kind of turbulence in the water, that bubble will, in essence, if you had a beach on the side of the pool, the water would go up on the beach and then move back and forth. And then if you were to shoot a laser over that, you would get a flat surface. And then as soon as you stop the turbulence, assuming that the beach was slanted, it would go back to its original state as a bubble. And in this case, if you're expecting a bubble and the water is not still, it's not. If the water's moving, you're never gonna get that bubble. I mean, I don't know how large you could scale up your test. I don't know. We don't have the money to build a 20-mile swimming pool, but
How much
if you had
curvature do you think is over 20 miles?
over 20 miles, I'd probably say it would have to be several meters, probably 10 meters.
Probably more than that.
Yeah. But nevertheless, no matter how much curvature you have in any kind of,
Do you know the height of the laser in that video?
5 feet.
5 feet. So check this out. I'm gonna go to Earth curve. I'm gonna Google Earth curve calculator. They actually have these out there.
Right, I get what you're saying, but you're never going to get a water that basically, as soon as you have any kind of turbulence in the water is not going to follow gravity's laws because it's not being pulled on in the center as far as that's concerned. The water is being moved by other forces out and away from what gravity is wanting it to do. That's why we have
All right, brother. Let's do metric. 60 meters.
yeah,
That's how much curve there is over 20 miles with a
60 meters, yeah.
So if you got a laser 5 feet high and you shoot it over 20 miles of water, at the other end, the laser should be 60 meters above your head, 198 feet.
Yeah, and what I'm saying is, no matter how high that would be, as soon as you add any kind of turbulence in the water, it will pull that down and away from where it needs to be at. I'm telling you, any kind of swimming pool that you can go to and create a scenario where there's no wind, there's no fishes in the water, you can make a curve in that swimming pool, no matter how big it is.
Yeah, but you can't make 198 feet of.
So, Deck, are you talking about like the surface tension, like the image I posted?
I'm saying any pool that you make that does not have any turbulence in the water, no matter how big it is, you can make a curve in it. It is possible to make a curve.
Look at the image that Matthew Learns put in the side chat. It bulges up, but it's still flat on top.
Yeah, the cause of the bulge is not what you think it is, right? It's not gravity.
It is gravity.
Yeah, so it's surface tension in that case, or if it's a meniscus, it can go the other way. But those effects are only a couple millimeters. Like even in a swimming pool, it would be like 2 millimeters higher.
Right.
Yeah, surface
Exactly.
tension forms due to intermolecular forces, not gravity.
Right, I understand that, but the reason
I mean, I get your reasoning behind it, but there's not enough surface tension out there to create 198 feet um, matter of fact, let me lower this down to 0. You have to do the entire 266 feet of surface tension. There's no way that it would ever bulge that much over 20 miles.
Yeah, I don't see that actually bulging either like that. There
I'm
might
not
be some
saying
incremental amount, but for all we know, it could be concave bulging, right?
I'm not saying that it will be surface tension. I'm saying in an example like surface tension where it is bulging out.
And I get your reasoning behind it, but
any kind of turmoil that you put into that cup, it's going to break that roundedness of it.
Your reasoning is based on, as a child, you were taught the Earth is too big to see the curve. It looks flat, but it's curving, and then you never questioned it ever again. So now you're trying to reason
No,
without
I'm saying it's
actual
not curving.
evidence.
I'm saying it's not curving. Not
Oh,
that
it's not
not
curving?
that lake. Not that lake.
It has to curve.
If it is curving, it's so minuscule you could not see it. But if the water was not moving, there was no wind, there was no fishes, it would be curving a lot more than it is in that video.
It has to curve, brother.
It doesn't.
It does.
Look, what I'm saying is if you take a surface tension and create a bubble similar to what a bulge would be on Earth, that should be in a pond. It should be. And you create any kind of turbulence in that surface tension, it will break and make the bubble flat.
Let me ask you this: if you have a pond and then you add more water to it, what's going to happen?
It'll create a bubble.
It'll just push outward more because water will seek the lowest part and then it'll spread out within its container.
Right, I understand that. But you will still create a larger surface tension bubble than what's in a cup.
No, it'll just continue to get higher and spread out. It's not like there's not a vertical wall on a lake like in a swimming pool.
Yeah, right.
Just like a beach. Like the water is just going to continue to go further and further up the shoreline.
Right. But you're still gonna have a certain amount of surface tension in a lake or anything that was not moving. It's just gonna be less than
No,
it'll be less than
flat.
a straight wall.
It's just like as you add more water, the water's going to rise and it's going to spread out further across the shoreline.
No, you will have
go
surface
further up the
tension
shoreline.
any size of amount of water. You will have surface tension. You could do it with a cooler. You could do it with a swimming pool.
If you have a vertical wall with nothing behind it.
Yes. Well, even if you made a slanted cup, you can make a slanted cup. You would still get surface tension.
Okay, so if I flooded the whole Earth, if I flooded the whole Earth, then the Earth would be a ball then?
Yes.
Retarded. Water should be curving already right now, and it's not.
Right, because you have turbulence in the water.
There's no turbulence. It rained, and the fucking ground is still.
One thing is, in that cup, if you barely move the water in that cup, it'll break that bubble.
Yeah. Nobody's moving the lake bed. Nobody's moving Salt Lake.
The water is moving.
No, it's not.
Yes, it is. It is. All those fish in there, any kind of movement in there. Of course, it would need more for a lake than.
Okay, so then water's flat and Earth is flat. All the oceans are flat too.
No, the ocean is a different scenario.
No, the turbulence is breaking the water, bro. It can't bubble.
Well, the ocean is a different scenario.
No. I'm going by exactly what you said. Turbulence
no.
is breaking
What
the water.
it has similar
All those
properties.
sharks and whales, and I mean,
It has
hell,
similar.
whales communicate with each other from 400 miles away. That's impossible for the Baltic.
What I would suggest is, if it would be possible, I would do this in the ocean and not in a lake, because it's a different scenario. That's what I'm trying to say. If this test could be done in the ocean, I would 100% agree with it. But
Done it in the ocean. Would you like to see an example of that? Someone show him the black swan or maybe the turbines. Let's see if I can find those. Just DJ when we meet.
Yeah, I got it.
what you also have to remember, though, in the ocean is you cannot get close enough to the water to measure it correctly. That's another issue.
What are you talking about?
Like any variable in a swimming pool that you, the largest swimming pool on Earth, if there is curvature, you would be, it would be
Here's a
possible.
PhD in optics. He's looking at a wind farm off the coast of England. Makes a 14-mile observation. Flat as can be. You want to talk about turbulence?
What better expert could you hope for?
I know, right? A PhD. Here's a guy that was looking at over a lake. It was frozen, and he measured out his markers over a lake using his odometer. All documented. Let's see. Did y'all show him the FE core laser test?
I haven't.
Because he wants ocean measurements. So I think the one you posted first is perfect. That's in the ocean, the wind farm.
Yeah, that Rampion wind farm observation just blows the globe out of the water. It's better than the black swan at the oil rigs, in my opinion.
Anyway,
yeah,
what I'm trying
take some
to say
time
is,
and have a look
what
at
I'm trying,
that
what I'm trying to
John
say
D
is,
video.
if you were to take a swimming pool and make a bulge, like a surface tension bulge in it, make a turbulence in the swimming pool, the water would wash up onto the sides of a swimming pool, make like a wave like you would have in, like on a beach. Just imagine the side of the pool is like a beach. And then in the center of the swimming pool, the water would point up like a point in the center of it, and then go back and forth, just like the ocean does, just like a lake does. Any type of water, the water concentrates its forces in the center of it, not the sides of it, the center.
It's not true. That's not hydrostatic equilibrium, and pressure is perpendicular to the surface outward against the container.
Right, but we're talking about a circular, like, the problem is
a beach is the
lake,
container, bro.
everything, the ocean. Yeah.
Right, so the container forces back in with the same pressure that it's forcing outward.
Yeah, okay, it's like this, you have, if you throw water up a hill, it's not going to go down for a little bit. It's going to keep moving up the hill. What I'm saying is like the turbulence that you have in the ocean is constantly pushing it up that hill. So gravity is never getting a chance to move it down the other way where it needs to be. You see what I'm saying?
No.
Like, an assumption of what we should see in the ocean in a spherical Earth would be that the ocean is hundreds of miles up in the air, right? In the center of it. There's a massive bulge in the ocean. Maybe not hundreds of miles, but very high up in the air.
What?
The bulge of the ocean you should be able to notice it, right? Like, or in a pond or in a lake, you should be able to notice a bulge in the center of it.
I don't think, no, like there are salt flats you can go to, okay, and when they get rained upon, these salt flats, some of them are like hundreds of square kilometers. They form a perfect flat mirrored surface. Tourists go there all the time and take video and pictures.
You can't look at land. That's why people look at water.
No, it's a salt flat. It's full of water. That's the thing. It's maybe like a centimeter high of water, perfectly smooth like a glass surface of salt, and it's flat for hundreds of square kilometers.
Yeah, but the issue with that is, you don't know how far it is away from Earth's center. That's why flat earthers don't use Earth as an example.
What do
They
you
use
mean we
water.
don't know how far away? Listen, Earth curves at an average rate of 8 inches per mile squared. Okay,
Yes,
and the
but
average
land does not
deviation
follow
along
that.
the semi-major and semi-minor axes is like, what is it, 1/3 of 1% of a perfect ellipsoid?
Yeah, but what I'm saying is this salt flat, if someone would have gone out
Spheroid,
there
rather.
with a bulldozer and dumped dirt out and made it 8 inches, then you would be like, oh, well, it's 8 inches. You can't follow land. That's why people use water.
That's what I'm talking about. Water covering a salt flat is flat. It's not curving.
Yeah, but you can cover any piece of land in water.
So gravity's claimed to provide an equipotential where at every point along the surface of a globe, gravity is pulling downward. So there's a radial, or pushing downward, radially inward to a common center of mass. So if you're on a globe, you take a bubble level, you can walk around and hold it level, and you could walk around the ball and it's always going to stay level if you're on a globe. What needs to be measured is that deviation, the deviation from a tangent to the ball, and a rotation, the tangent rotation from point A to point B.
Right.
Around the ball. Now, nobody's able to measure that. We tried with lasers.
What I'm
It's flat.
saying is there's no way for it to create a bubble if there's turbulence in the water. There's no way for it to rise like it should.
What do you mean? Why should any body of water rise in the middle?
That's what you're trying to prove, that it can't do that. That's what the
No,
video's
we're
about.
trying to measure drop over distance.
No, not drop over. You're trying to see the bulge in the water that comes up from a lake.
No. What should be happening is at the destination of that laser, the laser should be 198 feet above your head. It's not about seeing the bulge. The
No, because
laser
the
shouldn't be
lake
hitting the
is
target.
flat. The lake is flat, though.
Yes.
That's the whole point.
Well, if you're pointing a laser over something flat, then how are you going to get change?
Where's the globe
Water
then
should
if
be
it's flat?
curving.
No, the
How many?
ocean.
Yeah, how
It's
many
not
flat?
curving. That's what I'm saying. You
How
either
many
need to see
flat
the curve
swaths
in the
are
water,
there on the surface of a ball deck?
brother. You're trying to see the curve in the ocean. You're not trying to see the change in height on land.
I'm
Right?
still talking about. At what point did I talk about land?
Well, he was saying that it's supposed to be so many meters over your head, and that's impossible because you're shooting a laser straight over a flat piece of water.
Yeah,
And
because
I'm
Earth is
saying
not
to you,
curving.
the reason the water is not curving is because it has turbulence. If it was curving it should be on a round Earth.
No, FE Core
you
shot
would
a
see,
laser over a frozen lake, dude. 40 kilometers.
yeah, it'll be flat, perfectly. A lake will be
Exactly.
perfectly
It
flat.
was.
Yes.
Professor Dr. John D. took his high-end optics and was able to zoom into the base of windmills 12 kilometers away from his position out in the ocean.
Yeah. Well, you could see a lot more than you can at least see a lot further than that.
We've taken measurements over the Salton Sea using mirror flashes. We've taken measurements over at Lake Tahoe. We've taken measurements at Lake IJssel in the Netherlands.
They're all going to be flat.
It's all bodies of water. We've done measurements up and down coastlines over the water. It's flat there too.
Yeah, they're all going to be flat, other than the ocean.
Exactly. So for somebody to say that the Earth is curving, where's the curvature? That's what we want to find out. Where is it? Because
You're never
it's
gonna
nowhere to be
find it in
found.
the lake because you have turbulence
No,
in
we
the
did
water.
oceans, dude. Frozen lakes, no turbulence.
Well, frozen lakes is the same thing as a lake.
Yeah, with a hard sheet
Really?
of
So it's
ice.
frozen. It's frozen.
Right.
There's no turbulence, right?
You
Can't
have
be
a flat
turbulent 'cause
lake.
it's
If you have
frozen.
a flat lake and you freeze it, it's still going to be flat. Like, same thing.
Exactly.
When does
Yeah.
water curve?
It's not
How
going
far
to. If it
away?
has, the only time you're going to get a water to curve if it does not have turbulence, other than the ocean.
Okay, so how far away on the ocean?
Very far.
How far? From a
I would have to
5 foot
research that
observer height, how
for
far?
you, but
We know what the claim is if Earth's a globe.
well, I don't know. Right? I
Yeah,
don't.
but
You know, like
you
so
don't
many
have to take our
acres
word
per
for it.
mile or something.
I'm
or,
just saying I can't give you that. I don't know. You know.
Right, and we use water specifically because of the claim that gravity forms an equipotential around the surface of a ball. So mean sea level should be curved around a globe and should be at an average height.
The ocean
Change the definition to that too.
So, right, so you
Back
should
in
be able to
2019.
especially if it's frozen, be able to measure that deviation that is
Well,
consistent with a curving surface.
the interesting thing is, I think you kind of have to look away from lasers, and I would look more into radio waves because
We've
radio
done that
waves
too.
cannot go through land.
Right, so we
I
have
agree.
people who are professional microwave installers
Mhm.
who've done the same thing.
Right, but why would you not be
Yeah.
able to send that to?
They establish what's called a Fresnel zone between point A and B over the surface of the Earth, whether it's land or water.
So if the ocean is flat,
The
and for
Fresnel
whatever
zone
reason,
doesn't bend.
right? So if the ocean is flat and
How about a
it's not
10,000
possible
mile? How about a 10,000 mile radio communication before there were any satellites
from land, like
from land?
from like
From
the
UK to
ocean height,
Australia, dude.
right? From like ocean height.
Yeah, from UK to Australia.
Flat.
Or maybe during World War II when the Germans were crisscrossing beams to find hidden British targets.
Yeah.
Yeah, I
Or
would have
maybe
to look
when
at. That's what I'm saying. I don't think
maybe when the Titanic sank, the SOS signal was picked up 3,000 miles away.
Oh, that's a good one. We've also got high altitude infrared observations. Right. I mean, we've got observations of mountain ranges that should be 180,000 feet below the curvature horizon of a globe. But you can see it in infrared. Right. So the whole purpose of using infrared is to cut through the haze so you could see the curvature of the Earth pop out. Problem is, it looks even flatter. Where's the curve?
I see what's happening here with the radio waves.
What, they were bouncing it up the ionosphere?
Yeah, they didn't
Right.
know
So,
about skywave propagation back then, and the time of
well,
day that they were doing it is not conducive to bouncing off the E and F layers.
so
And not
there's an
only
easy.
that, but the frequency that they or the wavelength that they used was 5 higher than what bounces off of the ionosphere.
I don't think so, dude. Not according to current claim. They used a
What's current
very,
claim now?
very low frequency. High
It
frequencies are
was
set to go through.
not high frequency. It was like, so bouncing off the ionosphere is between this frequency and this frequency, and he was like 5 kilohertz above that
I don't
when
think
he
so,
made
dude.
his radio. I'll look into it. I'll pull it up.
Like we don't actually know exactly what frequency range he used. We have an idea. I think it was like 2 to 3 megahertz. I think might have been like
See, this would be something very difficult to prove with radio waves, just because they travel so fast. It would cost a lot of money to do it. But basically, what you would have to assume is that you would somehow have to. It would be hard to do it as a flat Earth, or you would have. Man,
no. What
anyway,
you do is you build what's called a high gain antenna. Examples are Yagi or log periodic antennas. And you
yeah, but
also have
that's
a
not
high gain receiver.
that's not the issue. That's not the issue.
Yeah, it
The
is. I
issue
mean,
is
this way you can narrow the beam and you can make it super thin, highly directional.
no. That's not what I'm saying. What I'm saying is if the radio wave was traveling straight in a straight line on a flat Earth from, let's just say, the United States to China, there would be, if you could calculate how long it would take to make that distance. So, and then you could do the same thing for it supposedly bouncing off the ionosphere and coming back to China. You could calculate that distance somehow, right?
Why
And you
calculate
would
that
have
when you can send like a song, right? Like you could play a song,
because
and then that song could be picked up from the receiver, and someone could say, "Yep, I heard that song."
well, that's not that's not what you're trying to figure out. You're trying to figure out whether it's on a flat Earth. It's not gonna you're not gonna hear it from the ionosphere and bounce down. You're gonna hear it in a straight line. It'll travel faster going straight to China. You see what I'm saying? Over the ocean. You would receive it faster than you would receive it if it was bouncing off the ionosphere and then back down, because it's a longer path. So you would have to calculate how long it would take to travel in a straight line on a flat Earth if it was traveling from the United States to China, and if it took longer than that, then that means it would be bouncing off the ionosphere and then back down and not traveling straight across. You see what I'm saying?
Well, you'd have to assume the distance from the United States
Right.
to China,
And that's the issue is
and
we don't have a flat Earth distance.
well, there's a lot of issues with getting distances over water, right?
I think there is.
There's
No,
there's
there's
no
not.
landmark.
No,
Well, the other issue
you're not
is
referencing a landmark.
the main issue is that the radio waves, from what I could see online, Google search, right? They travel at 180,000 miles per hour. So having some type of receiver that could decipher between milliseconds would be hard to find as well.
What you're describing is GPS.
No, because
they send the time.
It's traveling so fast you would almost hear it if your ears were hearing it, you would hear it at the same time. If you were playing a song and you were sending a radio wave straight to China across the ocean, and it was also receiving it from the ionosphere, right? Then, well, actually, hold on a second. Is there some way to make a cone of radio waves that did not go upwards? I don't know.
I was just describing to you earlier, Deck, and you kept shooting me down. You need a
Yeah, but
high
the
gain
issue is
antenna and high gain receiver from point to point.
the issue is like if you're pointing it straight across in a on a circular Earth, it's still going to hit the ionosphere. You know what I'm saying? It's still eventually going to.
Yeah, let me interject here real quick. The problem is, even in your local town, your FM radio station is, you tune it into your car, there's an effect called picket fencing to where you'll essentially receive the same signal a fraction of a second later because it's, in theory, bounced off a couple things. So the problem with any of this is that you really can't control the radio wave, if you want to call it a radio wave. You really can't control that signal between the transmitter and the receiver. That's the problem with any of this. Nobody knows exactly where it goes and where it was. All they know is that you receive it. So you can send it 3 times in a row and it could go a completely different path each time.
Yeah,
Right.
it's why
What
RF
I've
engineers spend a lot of time studying and surveying areas to find the optimal path. And a lot of times they'll say, F it, I'm just going to put up a big tower 300 feet high and put a microwave emitter on top.
Yeah, and the whole issue is like if you could send it straight across the ocean on a flat Earth to China, you would receive it faster than it going up, bouncing off the ionosphere, and then coming back down in some random direction.
Maybe
But you'd have
so,
to.
but that doesn't prove anything.
What I'm saying is, if you could calculate, I don't know if it's possible, how fast it would take the difference between those two.
Yeah, what you're describing are called echoes. I mean, they happen all the time. And I think that's what Barrington was also describing.
Yeah, but echoes also are plausible in a spherical, because if you're sending it straight up and it bounces down, it bounces across, versus going straight across the ocean. On a spherical Earth, if you shoot it straight across the ocean, it'll still go up to the ionosphere eventually.
Yes, but it would have to hit a
You would
specific
still have echo.
location in the ionosphere to bounce back down and hit a specific location on Earth. Do you agree?
Right.
It'd have to be frequency dependent and time of day dependent and
That's
meteorologically
a
dependent.
lot of variables, honestly. But
Yeah, some of us understand this kind of thing, and
we understand the implications.
Right. The problem is we have wireless transmissions taking place before they even knew that there was such a thing that they call an ionosphere today, and that they were conducting these transmission tests during the time of day where it's not optimal for the signal to be bouncing in the manner that we would describe it having to do today with this knowledge, if you want to call it that. So how is it doing it? Right, when the sun goes away, that's typically when these layers come out and you can bounce your beam off of them, skip the beam off of them, they say, right? But what if it's morning where it's supposed to be skipping? And the transmission still has a path to its destination. Well, then that's kind of interesting.
By the way, Deck, I put a link in the side chat for you and tagged you a list of other long distance observations that include eyesight observations, laser observations, and radio wave observations.
all right, bet. Thank you.
Now, it is listed on Web Archive. The guy that was maintaining it, he just got tired of paying for the what you call it, the website, not the website, but the server. So he just backed it up on Web Archive.
When you said before you traveling over distance and knowing how far you've traveled or where you've gone is hard or like impossible to do. It's not. We have all sorts of modern instruments to do that like very easily.
Oh yeah, like what?
Well, thing that planes use all the time, inertial navigation system.
Yeah, how do they know how far they've traveled?
Because that's how the instrument works. It's measuring
How?
it with what, as in how the inertial navigation instrument works.
Yeah, how? Yeah, why don't you tell us?
Yeah. So it's got a central gyroscope on the three axes of like sets of gimbals, and it's also kind of it's integrated with accelerometers and position sensors, so that it's maintaining kind of a level over the Earth, because What
That doesn't
would
address how
happen?
far they've gone, dude. How do you know how far they've gone?
that's how the accelerometers, position sensors, and the actual the gyro work in tandem. Like they're
What if the
telling you
plane's
your
not
distance.
accelerating?
Yeah, that's where the position sensors come in, and like the
Position
attitude
sensors?
sensors. Sorry.
How do position sensors tell you how fast the plane is going?
No, so you've got attitude sensors.
Yeah, we're talking about
Which
distance travel, dude. Try to focus.
yeah, you said what if the plane's not accelerating? So why are you jumping between questions?
Yeah, no, I'm not, because you keep diverting away from the distance problem. You're trying to talk about attitude.
You said what if the plane's not accelerating? I
Right,
know
because
what
you
you're
said the
asking.
accelerometers could tell you like how far the plane is
Yeah.
going.
Yeah.
Well, why don't you go give an example of that?
Because if the plane is in motion, right, the accelerometers are giving a reading as to the force the plane is experiencing.
What if the plane's flying at a constant rate of speed? Is it accelerating?
Yeah, or what about headwinds and tailwinds?
They're all part of the adjustment.
The adjustment, yeah. Can you be any more, bland with your descriptions?
Well, okay, tell me, what are you asking?
For like the 10th time, I'm asking you how the plane knows how far it's traveled. You said we have all these systems to determine the distance that these planes travel over water. And I'm like, great. Why don't you give us a method? And, and what I'm hearing is anything but.
Like in a car, we have rotational speed of the wheel, right?
Yeah.
How do you measure speed in a plane?
Yeah, you're using inertial instruments.
Okay, so you're moving at a constant rate of speed, and it's as if you're not moving at all. Now what?
Yeah, and the accelerometer is reading that the plane is moving at a consistent velocity. Like, so what?
So 0.
No, because the accelerometer read that the plane was experiencing a force. Therefore, it's taking it from the last reference point that it's moving at a constant speed. Because to go back to 0, it would have to decelerate.
That's not an accelerometer.
Unfortunately, headwinds and tailwinds will fuck with you right here.
No, they don't, because it's all inertia. It's all inertia. It is all going to affect the readings from the accelerometer.
If you're supposedly flying at 500 miles an hour and you get a headwind of 200 miles an hour, how fast are you?
Yeah, you just take an X, Y, and Z direction and say, right, this is in what resultant direction I am heading as a result of this tailwind, as a result of my inclination or declination. Am I dropping altitude? Am I increasing in altitude? How fast am I going?
I have no idea what I asked.
Well, then you're asking random gibberish.
Well, you don't even know what I asked. Just a simple math problem, bro.
And I just told you have got 3 axes of movement, haven't you?
Okay, so you're not going up in altitude, you're not going down in altitude, and you're not turning, you're moving in a linear path, and you're supposed to be going 500 miles an hour because you're at full throttle, but you have a 200 mile an hour headwind. How fast are you going?
You can work it out. I'm not solving a math problem here for you. Like, yeah, you just use some trigonometry to determine a resultant speed. Like this isn't 200. Sorry? Well, so we just say 300 then, whatever.
There you go.
Right, is this productive? Like, what's your point?
Is it what?
What is your point?
If you don't have any land markers and you're out over the water and you can't tell how fast you're going, how do you know how fast you're going?
It's measuring it. That's how it works. Are you questioning the fact of whether it's measuring it?
You claim that there are all kinds of ways that airplanes can measure their distance between point A and B, and you brought up accelerometers. That's where we are right now, right? And then I'm
Yeah,
like, well, what if you're flying in a steady like 100-mile-an-hour headwind? Your accelerometer reads 0, which is exactly the same as if you're flying in calm air. So how do you determine how much distance you've actually gained during that time that the accelerometer is reading 0?
No,
you know, and you're in a 100-mile-an-hour headwind.
Okay, if it really feels
okay,
like I need to
yeah.
What?
Okay.
It really feels like an. Oh, what the hell? We're just 5 years old. Are you gonna like let me just respond?
Is this the day that you come in and you pretend like you have no past history with any of us?
So you're saying that you're specifically going to be ignorant because you've been butt hurt in past sessions?
I'm gonna be ignorant, but you don't deserve any respect. Not only that, but
right,
you're speaking gibberish.
You're still seething.
You're speaking gibberish.
Yeah, right.
You haven't said anything.
That planes do every single day all over the earth.
You don't understand how they're doing it, right? So because an
Yeah.
accelerometer is going to read 0
I'm sorry to interrupt.
in steady flight.
Yeah, I'm sorry to interrupt, Yoder. I want you to continue with what you were saying, but I came on to see did Deck have anything more to ask or say? But of course, Deck has left because Cosmic Nun, whatever he is today, has interrupted and derailed the conversation with the new person. Good job, gold medal for slitheriness. Go ahead, Yoder.
No, Deck left a while back, and Danny Lion, we'll review it with you here in a little bit.
Yeah, you don't have to review it. He was here when Dude started blabbering. I came on and checked, and he left because he was bored, obviously. Because yeah, go ahead, Yoder.
Yeah, I mean, final part here, and this is not refutable. So these accelerometers have a blind spot. As they read 0 in steady flight, they have no way of knowing if they're moving like 500 knots in calm air or 500 knots against a 100-knot headwind. The forces are going to be balanced in both cases, and you're not going to be able to determine how far the plane has actually flown. Okay.
Okay.
So,
right. I think we need to simplify it. So it's like, right. I have an accelerometer. Say in my car. I think most cars have.
No, you can't use your car. Your car uses wheel rotation.
No, cars use a bunch of different instruments. I mean,
use an analogy with going from point A to B over water like you were initially supposed to defend.
I wrote my thesis on one of the types of sensors a car has that has nothing to do with wheel rotation. Well, it has something to do with wheel rotation.
This is all about getting a distance between like two cities across the ocean, which you said, airplanes have all these ways to consistently measure this. And then you brought up accelerometers, and then I shot you down. So that's where we are in this part of the conversation. If you want to move on to cars or something else, take the L, and we can move on to cars.
Because I feel like we need to simplify it. So it's like just
I made it super simple. I think the audience understands. If you don't, I can cut you loose right now.
Okay. If I'm walking, right, and I have an accelerometer attached to my body, right, the accelerometer from rest reads 0. right? I start walking. Okay, the accelerometer starts to read something. You know, it reads an acceleration, like a few meters per second acceleration or something like that. It then goes back down to zero again, right? It reads zero.
Sure. Then we measure stride.
But from the accelerometer's point of view, what is the logical conclusion of what I am doing while it's still reading zero? Oh, it's an open question. What would the conclusion be inferred as a result of the accelerometer still reading
I'm sorry, I
zero?
fail to see the relevance.
Because we're building up to a plane, because I need to simplify this.
No, you don't need to simplify it for me, dude. I know
I
more
do,
about this topic than you
because
do.
you're not understanding this, so I need to
No,
simplify.
I am understanding this, okay? I know how air data inertial reference units work in airplanes.
Right. So this should be easy to understand, because I can bring it back to a
and
plane,
it's
but it's like
irrelevant.
you get very confused.
It's irrelevant. It's completely irrelevant.
Okay, take a plane. Take a plane, right? Since you got upset when I talked about walking or using cars, right? You're in a plane. You take off, right? And let's just keep it fairly simple, right? And say that there is one accelerometer reading your acceleration parallel to the axis of the fuselage. So just call it your x direction. Right? If the initially at rest state we know it's zero. It takes off. Suddenly it starts reading acceleration going. Right. It then, when the plane reaches a constant speed, it returns to zero. Obviously, it's going at a constant speed, no acceleration. Right. What what would the logical conclusion from point of view of the accelerometer be that the plane is doing? So you guys just don't know.
Brother, do you think that we just sit in here all day and that we don't have jobs?
You don't seem to know.
Huh? I wasn't even listening to you because I'm still trying to figure out what other instrument are you
Trying to
using
figure
if
out
the
what the
accelerometer
answer to the
reads
question
zero.
is. You're still trying to figure out what the answer to the question is. That's why I'm saying
You're
I
talking
simplified
irrelevant.
it.
Go ahead. What's your question?
The question was, as I said, right? What would the logical conclusion be to draw from the data from the accelerometer as to what the plane is doing?
If it reads zero and you're in mid-flight, you're not moving at all.
No. The accelerometer doesn't know you're in mid-flight. But what is the conclusion from the pilot reading the data?
You're not moving. That you're not moving.
No. Okay. No, sorry. I don't want to be condescending on that. It's the conclusion is that you're going at a constant speed because the accelerometer hasn't read any deceleration.
You don't need it to read deceleration.
How would it think that, or how would you think looking at that data, planes come to a stop? You're not reading any deceleration.
You're a fucking moron.
That's your counter argument.
Show me a linear accelerometer. Post one in the chat right now. A linear accelerometer right now. Post in the chat.
What?
A linear accelerometer. Post one in the chat.
What do you mean? You can have
Yeah, you don't even know your own argument. You don't even understand your own argument.
An accelerometer in one axis.
Yeah. So how do you know whether you're accelerating or slowing down? That's linear, right? You're going in a direction.
We agreed.
There's curvilinear, so you got a ring laser gyro, which measures the rotational acceleration. I want you to show me the linear accelerometer.
Why? What is it?
Because that's your argument. Because that's your argument. That the plane, the data, right, is that it's measuring that if it's going at a constant speed, it would not measure any output. because
Actually,
there's
I
no
don't even know.
acceleration.
How long have you been
Hold on,
listening, Indio?
sheepdog. Don't not wait, sheepdog. I want to know what device they're
Sheepdog.
measuring linear acceleration with in the first place. So you made up everything you fucking said. Everything.
No idea.
Then show the device that they're measuring a linear acceleration with.
No, that's not necessary for the argument.
It is, because that's what you said. You said there's a device that's
No.
measuring an acceleration.
Okay.
And if it's going at a constant speed, it's not measuring an acceleration. What device is that?
Yeah, I don't
What
care
device is
what
that?
the exact device is called. I don't care
Because
what
that
it's
device
called.
doesn't exist, dude.
I mean, this is
There's
the
no
thing
such
where you
thing
say
as
it
a
doesn't.
linear
No.
accelerometer. They don't exist.
Oh.
So
Do
you've
you
been
want- am I
bluffing and bullshitting and saying, I'm not going to be condescending. You're talking out your asshole the whole time.
No, this is the thing I find.
Yeah, no, I don't care what you find. I don't care about your social commentary. Produce the device that measures, that says the data. You said data. What device is sending out data that matches what you're saying?
It's worse than that, Indio. His whole argument
exactly.
is saying...
Shut the fuck up, Cosmic. Don't ever talk in here again.
He literally used the argument that accelerometers measure distance travel over water. That's where it started. It was worse than that.
There's something called an inertial navigation system, but that's not simply an accelerometer. In fact, it's not an accelerometer at all in the sense of measuring acceleration.
Anyway, that's all I wanted to say, Indio. I wasn't trying to interrupt you.
Yeah. I know. I just didn't want to let this dude off the hook. I'm already irritated because I just happened to click on, because I got the live stream in the background. I click on mute, and I hear freaking Dandelion spurging about this clown running interference.
I'm glad you liked spurging. It wasn't for nothing then. Got you in
it
here.
wasn't. And then I okay, maybe he actually has a point. And then it's just made up bullshit.
Well, he came in here, right, with this little sad puppy dog voice, I'm trying to be good, guys. And then it's like, no, don't act like you don't have a fucking...
And he's like, you guys can't answer my question. Of course we can't answer your question. Your made-up fucking device that belongs on the state to Slay. So, in an airplane, they measure acceleration with something called a pitot tube. Okay? That's what they measure the speed with. Yeah, okay, just post... Yeah, Cosmic, just post the device in the chat. And then we can talk about the data that you says exists. My question is, I just want to see how you guys can explain. What would the pilot think about the data? What fucking data? With what device? Talking out your ass. So just...
And then he tried to say that, since you don't understand accelerometers in airplanes, we'll talk about the accelerometer in a car. It's like, it's measuring you're measuring wheel rotation, dude. This is
the problem, Sheepdog, is this person interacts with reality through a phone. So the little phone is like the window to his freaking made up reality. It's like, phone, man, it's got an accelerometer. If I drop my phone, man, it'll tell me its orientation. That must be what the plane's doing. Yoder tried to explain it to him. I heard him, but he's too dumb.
We've got Giga. Oh yeah, we've talked to Giga before. Welcome back, Giga. If you're the same Giga, I don't know. There could be more than one.
I think I'm the same Giga. I've been in here before.
Yeah. What did we talk about last time?
I think we talked about lasers and like a lake or something to prove the Earth is flat.
Yeah, that's what we were talking about with Deck earlier. Also, yeah, it's a good thing to talk about. Yep, those lasers demonstrate there's no curvature. That's what they demonstrate. They, you could say they disprove the globe.
Thought the other day, though, I just kind of wanted to mention this. Is it possible that gravity bends the light as well, though?
Well, first you'd have to prove that your gravity is capable of having any effect on anything anywhere in some kind of objective scientific way. Are you able to do that?
Well, yeah, gravity absolutely affects light. That's why black holes are black, you know?
Oh, so you've got some proof of black holes for us. Yeah, post the
Proof is
the
you can't see
verify
it.
post the verifiable, testable, repeatable scientific evidence with the experiment, with the testable hypothesis, the independent and dependent variable that can be manipulated. So how are you manipulating the independent variable in the case of black holes and light, as you claim?
How am I manipulating an independent variable?
Yeah, that's the question. Yep. What's the independent variable in your black hole proposition?
Is Earth a black hole now?
Light. Light would be the variable.
Well, let me tell you, Giga, even if the general theory of relativity was true and gravity bent light, the mass of Earth would only bend light 1/16 millionth of 1 degree. So now that ain't going to do it. You're going to need more bendy.
I forgot flat Earth. A lot of flat earthers don't believe in gravity as well.
It doesn't even matter. It doesn't do what you need it to do.
It is odd though, Indio, that like the evidence for a globe is that everything looks flat.
Dandelion was on track with the black hole because we'd have to be living on black hole Earth.
It would kind of mean, too, if light was bent by gravity, that the stars in the sky aren't even where we're looking, you know?
They already say that anyway.
Since people have shot lasers across the Earth horizontally and got the same elevation at both ends of the laser light, that means that the light is curving at the exact rate that the Earth is curving. Are you saying that the Earth appears to be flat because the light is being bent into a flat view?
No, so the issue is, with a laser beam, you're able to view a laser beam much further away than supposedly if the Earth is flat, right? Or sorry, if the Earth is curved, I had it backwards. Perhaps all I'm theorizing is that gravity bends the light coming from the laser, allowing it to go further.
That would mean you'd be able to see the laser at its location of start.
You wouldn't be able to see the starting point from the laser, but you'd be able to see the light bend around the Earth.
Okay,
Maybe that's
so
what people
you're
are seeing.
viewing the laser light. The laser light looks straight, right? Now, the Earth is curving, right? Now, the laser light that looks flat is going across the curved Earth, and it's curving at the exact same rate as the Earth. So now you're viewing a straight light you're viewing a curved light as straight. So are you viewing the curved Earth and it looks flat because of it? Because regular light is not as intense as laser light, and the laser light looks straight as it curves at the exact same rate as the Earth does. Because the elevation on both sides of the beam across the large body of water or a large area of land, it's at the same altitude. Because if the laser light was straight and it was not being bent by Earth curve, but the Earth was curving, then the altitude of the laser light at the opposite end of the laser should be at a higher altitude because the ground is curving away from it, right? But you're saying that it's the exact same curve rate as the Earth. So then you're viewing a flat world. Gravity is causing the world to look flat.
Yeah, that kind of is what I'm saying.
Okay.
Kind of,
So
yeah.
you have to believe the opposite of your senses and you have to bend over backwards to make your senses make sense.
I don't think it's really bending over backwards. It's just understanding that, light is made of photons and those can be affected by gravity.
Well, what you just agreed to is that the world looks flat, but it's not actually flat. To the extent that laser light is now bending at the same curvature rate as the surface of the Earth because of gravity. You're accepting that you will never see, ever, the curve of the Earth. But it's there.
Yeah, I'd really like to do some of these laser tests myself.
Do it. Scrutinize it as to your heart's content. Do you know the rate of curvature or the distance to the horizon? Or how to calculate the distance to the horizon with the radius value that they've given you?
No, I remember it's like so many inches per mile or something. I don't remember exactly. Like what?
The distance to the horizon with a radius value of 3,959 miles is 1.2 times the square root of the observation height in feet. So if you're 1 foot above the water and you look out in front of you with the radius value they've given you, the horizon where things disappear should be at 1.2 miles. If you're at 6 feet, should be about 3 miles. If you're at 30,000 feet, because you want to be in a plane, that's about 218 miles. If you're at 44,000 feet, that's 250 something miles.
Well, you kind of got to do the laser tests at sea level for them to be valid,
Yeah, because I mean, the sea level is the basis for all horizontal, altitude reference, right? Sea level being 0 on that baseline, and any altitude above that being,
Have you ever been on the ocean in the ship?
Yes, I've been on a boat.
It sure looks flat out there, doesn't it?
Yeah, and at certain times of the day, if the sky and the ocean match the same color, you don't even see a horizon line.
Well, hey, Giga, I'm going to tag you in a video that I'm putting in the chat for you to watch.
Sure.
This is a flat Earth explanation of what refraction is, why they're using refraction. It's a good little explanation. It's like 4 minutes.
Okay, yeah. This is kind of what we were trying to talk about. I've never done any of these tests myself, so I'm not really speaking from experience.
No, that's fair. It's odd that, you're not speaking from experience on the test and you're not speaking experience on the globe. But you choose to defend the globe, which tells you the opposite of what your senses are telling you
Like
anyway.
most people, I've never been to outer space and I've never just seen the Earth, so I can't really,
Well, let me ask you this: what's the idea? What makes you?
This is important. Is that the only way you can figure it out? Is to go to outer space? It's the only option available.
I think that's the only way you could actually know.
So you're not. So nobody's ever going to know except for the 27 Apollo dudes. Everybody else just has to believe
in
them.
The space station and people that's been.
Well, they can't see. Well, hold on. They only see 3% of the Earth, so we can't rely on them.
Well, they could see that many of the continents are on the back of the Earth.
They only see 3% of the Earth from the elevation of the space station. 3%. That's if they could see the entire circle of the horizon, which they can't. They can only see a little slice of it, right? So we can't rely on them. They don't see the Earth as a globe. So the 27 Apollo astronauts, that's it. We're putting all our chips on and what they fucking say. That's not the good bet. I wouldn't take that bet, bro.
I would like
That's
to see
not the only way we can do it, though. We don't have to go I don't understand why people get this idea where you have to go far away from the thing you want to know about to figure out what it is. If you wanted to know if
You know,
like your table, you had a table and you want to know if it was square, would you freaking walk a mile away and look at it, or
I would
would
if
you
I was
just measure the? Wouldn't you just measure the table?
I mean, if I was an ant, I'd probably walk away from it and look at it.
If you were an ant, but you can measure it. So you're an ant with a tape measure.
Right.
or a laser.
I
That's
don't
the
have a
thing
tape
about the
measure that
laser
can
test
measure the whole
because they're
world, though.
measurements of the surface of the Earth. Because we can just measure the laser height, and the Earth should be curving away from the laser, right? If the Earth's a ball, it curves away from the laser, and that the laser and the Earth should get further and further apart with distance.
I gotta add this real quick, Indio.
Yeah, go ahead, Sheik.
Giga. The idea that you could become an astronaut and go do the things that they say astronauts go do, right? First of all, you'd have to be selected for a pilot program in like the Air Force or the Navy. And then from there, you'd have to be selected to go into astronaut. And then from there, you'd have to be selected to go on a mission. So there's a lot of selection processes that go on. Most people don't even make it to the astronaut training part.
Yeah, because you'd have to be really
Regardless of how good-
dumb. You have to be really dumb to be an astronaut, right? That's what I've observed. Look at Don Pettit. Most people aren't dumb enough to be astronauts. I totally agree. They wouldn't pass the first initial intelligence test because they would score too high.
Hey, dude, you know what you should do? And this happened recently. This happened on December 1st. There's a guy named Danny Jones, and he has a YouTube channel. And there was a debate between an Apollo astronaut and Bart Sabrell, who made a documentary called Astronauts Gone Wild, where he would ask the astronauts to swear on the Bible that they went to the moon. And instead of doing that, they either ran or took a swing at him. Most of them ran. Only one person took a swing at him. So anyway, the point is that Bart Sabrell and a guy that says, I went to the moon. You should go watch that. And go tell me if that guy, you think that guy actually went to the moon. Based upon his responses. Because he brings up something that they said that like you couldn't go to the moon with one rocket. So they said it at the time. They've said it even now. They're still saying it. They're saying that in order to go to the moon, you need like 15 rockets. Because you need a rocket you need to put your rocket in orbit, and then you need cargo ships basically to bring fuel up for that rocket to go from the Earth to the moon. And this is what they've been saying when they actually do the math. This is what the math says that they have to do. So they bring this up to this astronaut, the guy that says, I went to the moon, and he just goes, well, they never told us that. Hey, what about the Van Allen radiation belts? Well, they never told us about them, so I guess they, You so like things don't kill you if you don't know about them now? That's convenient. But I mean, the point is that, before you rely on these people as like, credible witnesses or anything like that, I don't know why you would do that anyway, because like Sheepdog pointed out, they're all in the military, especially back then. You might want to, if you watch that, I guarantee you're going to be like, what the hell? There's no way that people went to the moon. And if there's nobody went to the moon, you got to think nobody has seen the Earth in its entirety. With their two eyeballs, right? So how do you even judge any image of somebody showing you the Earth, right? Because you've never seen the Earth in its entirety. You can't even judge the image. And that's where we're at, right? So why should we rely on that garbage evidence, right? Of trusting this guy, trusting this image, when we can just measure
the Earth. Are you saying that satellites don't exist?
They exist in what sense?
That we've put satellites into orbit.
You're not one of them, dude. You're not a spaceman. You're not a spaceman. There's no we. There's no we, dude. You're not a spaceman. You didn't do anything.
I don't need to be a spaceman to know that we have satellites.
There's no we, dude. There's no we.
I've literally seen it with my own two eyes.
Yeah, but you didn't do anything. We don't have satellites.
You see satellites.
Okay, how do you know how do you know they were orbiting the Earth? Okay, how do you know they were orbiting the Earth?
I don't understand the logic here.
I'm going to ask you a question. How do you know the little light you saw in the sky is orbiting the Earth?
What else would it be doing?
That's not asking me a question doesn't tell me how you
know
it's
how many objects are orbiting the Earth now. There's like countless thousands.
Yeah, so check this out, bro. So check this out. Astronomers recently released a study. They went over now this is in the Astronomical Pacific. It's an astronomy journal. They looked at old photographic plates from before satellites. And you know what they found? Satellites. How did they find satellites before satellites in 1947, before Sputnik?
There's ancient technology up there. Antediluvian technology up there too. The work of fallen angels. Yeah.
Oh my lantern.
That's also really
People
interesting.
before
That's
the
also
flood
really
put
interesting thing about
satellites
is that there
around
is
here.
Antediluvian
This is the hope you want to come up with?
The trebuchet method of orbiting freaking. Sure, they didn't orbit monolith.
Have you heard of the Dark Knight satellite?
Have you heard of?
That's an instance of one of those.
Have you heard of the Anunnaki? They genetically altered human beings to dig gold so they could bring it back to freaking Beta Reticuli.
Yeah, that's a lie from Satan. But yeah, go ahead with that.
That's a lie from Satan, dude.
It is.
The globe is a lie from Satan, brother.
They're fallen angels, and they've been deceiving mankind for a very long time.
The globe is a lie from Satan.
What's an angel? It's a way to sidetrack you from believing in
okay, so why?
Oh, he's one of those. Okay, yeah. Flat Earth is a sidetrack. Yeah, rethink your whole life, please, sir.
Why did God create a reality from which you can't perceive that? Oh, shut up. Why did God create a reality that is completely deceptive? Right, the Earth looks flat, but it's not really flat. And it seems stationary, but it's not really stationary. And then he wrote it, and then he had the prophets write it down in the book called the Bible, and they also said the Earth was flat, like clay pressed and twisted. Why are you talking over me the entire time I'm talking? You can
There's a new interferer. There's a turbo dick coming in. Yeah, so we're back to Giga, and Indio's asking a question. You probably couldn't hear it because a guy was rudely interrupting and derailing. So maybe you want to just give him. I don't know. Did you hear it, Giga? The question.
I just went and got a Coke Zero. I just got back.
Oh.
Can you repeat it, Indio?
I don't even remember what it was, quite honestly.
Yeah, it's the same question you've asked it many times about, like, why would God be a trickster type thing?
Oh yeah, I was kind of talking to Turbo though. So yeah, why would God create a reality which was tricking us and just not real? That's not what it really is.
Oh, was Turbo the guy who claimed that flat Earth was a trick?
Yeah.
I'm sorry, I got confused. My bad. I don't know who muted Turbo, but you can unmute him if you want. I didn't know that you were asking him that.
He doesn't need to. He just talked over me. He just talked through me anyway. So
okay.
I thought Turbo was saying that the globe model is a trick.
He said
Satan.
He said we made satellites, and then he started talking about the Black Knight, because the thing that he thinks is satellites that he saw in the sky. Like I don't know if you heard this. They really about like a month ago, an astronomical journal said they went over photographic plates before there were satellites, and they saw satellites, which don't make sense, right? If they're man-made artificial satellites put in the orbiting
I've
the
never
Earth.
believed in the round Earth more than when I saw a satellite train being deployed. Like,
what do you mean by man-made / artificial?
So you think that those? So you think that you saw a bunch of Starlink satellites? So you saw a refrigerator from 250 miles away?
Damn.
You got good eyes, bro.
I sure did. They were bright in the sky.
Because they say if you saw 5 lights in the sky, that's a satellite train? Because that's what they said on TV? Like, serious?
Well, there weren't stars.
There's a lot of things with these satellite things is that upon further inspection, what they say is possible actually isn't possible. It can't possibly be what they say it is. It can't be a freaking refrigerator 250 miles away that you can see. It's pretty far. Like, I don't know. Think about something that's 250 miles away from you by land, and how long it takes to drive that far. And now imagine there's a refrigerator in that place, and you think you can see it?
Well,
like, I feel like a refrigerator's in like Philadelphia. That'd be like seeing a refrigerator in Philadelphia from Boston.
It was just a bright light.
Yeah, it was just a bright light. And that's all they are. Like, that's all people see. They see a bright light. It transits the city. You have no idea how high they are, how fast they are, if they're orbiting or not orbiting. That's why when people say we, it tweaks me because they don't have nothing to do with any of that shit. They saw a light and adopt a story and adopted a belief in a story. And now somehow it's their story too. This is like it's like your football team winning the Super Bowl. You're like, we won the Super Bowl. No, you had nothing to do with it. You're just a freaking person looking at the TV that somehow identified with some sports team. And that's what it is. They're just identify. Oh, I'm part of the spaceman. No, they're not spacemen. You're not a spaceman. There's no we in any of this shit. And actually, Crip pointed that out today. Like, if people are like projecting themselves as spacemen, like their they got it's part of their identity. Like, this is the space age. We're all gonna go to Mars. No one's going to fucking Mars. And I just told you, really, dude, I really highly recommend go watch that Danny Jones video. Okay. So they have. Okay, so there's a guy from a YouTube channel called Smarter Every Day. His dad works for NASA. This guy grew up with being around NASA people his entire life. Okay. He did the calculation on going to the moon. 15 rockets, dude. Werner Braun said 3 rockets, all bigger than the Empire State Building. Elon Musk has said something like 15 starships to go to the moon. Oh, he deafened. Fantastic. Just talking to myself.
We heard you.
I had to mute that. Another guy tried to come in and run interference. I have a sneaking suspicion these are collaborators with Giga. That he's actually not alone.
Yeah, I don't know. We've talked to him before. I can't really remember how it went. I just remember his name. Yeah. We'll see. Yeah, I'm sorry. I wasn't looking at the screen. I got confused when he started doing the religious argument. I thought that was the same guy. Usually I'm decent at distinguishing voices, but maybe I'm losing my touch. Could happen.
Yeah. It's like, I think it's the universal whininess of Gen Z.
I think so. I seriously just thought that was the same person the whole time. Yeah, there's actually been studies about that. I don't know if you've seen that people's voices in general are becoming more robotic because they're so used to one, listening to a bunch of robots talk to them, and two, training their voice, like if you're using voice to text, or I guess people talk to their robots in their house. I don't talk to my robot, but I don't have a robot in the house to talk to, but I know people do. But my point is they've learned, you have to talk in a certain way for the robot to understand. So then they just are generally becoming more robotic. There was an article and study about that. I'll see if I can find it. Yeah, it's been a couple years since I read that. I'll have to look for it.
Actually, so I first noticed people using that voice to text like 5 years ago. I'm like, people actually use that crap? Like, a lot of people use it. It's actually shocking. Like, some people only use that exclusively. All they do is talk to their phone. Like,
oh yeah, I use it sometimes. I don't mind using yeah.
There's some people that's the only way they interact with their phone is like talking to it.
Oh yeah, I know what you're saying. Yeah.
I mean, we had Teddy Ruxpin, man. We didn't have that. You could talk to your Teddy Ruxpin. He pretended to talk to you. I guess the phone pretends to talk to you.
Yeah, people's imaginary friends. Yeah, talk back now. Yeah, it's a new world.
And it's always listening, right? So you're going to stub your toe. My toe. And they're like, rub some alcohol on it. Use a Band-Aid made by Band-Aid brand. $3.99 down at the local Walmart. You'd be good at advertisement for your wound. I think I just gave him an idea. Shit.
Add it to your list of ideas.
Yeah, they're going to work it into, like, people ask ChatGPT for this information, and then they're like, They're just going to work in advertisements. Did you see that OpenAI, which makes ChatGPT, is now partnered with Disney?
I did not know that.
You're going to be able to make Disney, like, AI generated content using the actual Disney characters, and it won't be like copyright infringement. Now, Disney owns shitloads of like intellectual property. They own the entire Star Wars franchise. They own all their like Disney cartoon animated characters, but they own a lot of other stuff too, like the intellectual property rights. So get ready for some Disney freaking pornography because people are obviously going to twist it, and it's going to be unstoppable.
Which Ray Bradbury story was it where it opens on him like wandering, the main character is like wandering through the streets, but like he's the only one outside because everyone else is just like glued to their screens inside? I can't remember. When it came out, it was like unusual, right? That was like a futuristic view, right?
Yeah.
Which one is that? Is that Fahrenheit 451? I don't think it is. I think it's a different one.
No,
Yeah.
it's not Fahrenheit 451. That's the book burner guy. Where the firemen start fire.
Yeah.
Cheating into books. I can't remember the one you're talking about.
Yeah, I haven't read it since then. Giga is back. Were you asking Giga a question? Hi, Giga.
Give me a chance to see if he's alive in there.
Yeah. Is that an eagle on
I
his
never understand the
PFP?
position of like
Or is it a phoenix?
I'll actually never know what the Earth is because the only way you can tell is to go to space.
And those guys are so like shady and like, you know what I mean? Like, yeah, they should be forced to like actually watch those guys talk. Like you said, like the guy who's in the interview, he sounded like a clueless person who had no idea what was going on. You know what I mean? Like, yeah, this is your hero that's telling you what your world is like. The one in the interview we were talking about. We should post that link for him. Did you post the link? Yeah.
No, but I'm going to do it now.
Yeah, because everybody who's relying on the so-called astronauts to give them their worldview should totally be forced to like listen to some of these guys actually speak and say, oh, does he sound like a real sharp, trustworthy dude there? Yeah, so you're gonna just put your life in his hands. Yeah, let me know how that works out for you. Old dude says it's called The Pedestrian. I never would have remembered that's what it's called. I think it was like maybe it was in like a short story anthology or something. The Pedestrian, Ray Bradbury.
Yeah, it was a short story, I'm pretty sure.
Oh, yeah, this is it. Yeah, The Pedestrian. Thank you, old dude. It's a 1951 Ray Bradbury short story about Leonard Mead, a man who enjoys solitary evening walks in a dystopian future where everyone else stays indoors, mesmerized by television, making his behavior seem deviant and suspicious to the automated police. Totally. Yeah, this is our life now. Thank you, old dude.
So, Gig, I posted a link to that interview. Yeah, this should be eye-opening to anybody. Just think about your own experience and like you've gone somewhere, like say a movie. You're like, hey, dude, tell us what was it like going to the movie theater? And then you would tell the story like from your first person point of view about what you experienced. These guys never do that. Even if they talk about the experience, they'll say things like they'll describe the experience as like they'll say things like Chris Happy used to do this all the time. Earth from that vantage point, you see, or they don't even say you. They say the expanse is wide and broad, and it leaves quite the it will leave quite the impression. They don't even say like none of it is like in the first person. They talk about it as if they're reading like from like a generalized universal experience, not from a personal experience, which is very strange. Because if you actually did that in real life, you'd be freaking blown away.
Yeah, for sure. And yeah, because that is, their role as they either see it or have come to just embrace it so wholeheartedly they don't even realize it is their role, is to, define the worldview of a generation. And that guy, that's what he seemed like in that interview. He was so clueless. Like he was not ever used to having any kind of, real-time pushback at all. You know what I mean? Like he'd never personally talked to anyone who like didn't believe his story. It was very odd. Like,
well, he talked to Bart. Even Bart was like, "I called you 10 years ago." Like, so he's talked to this guy before. They're not strangers.
That is weird. I didn't know that. That I guess I missed that part. That's really interesting that he's even talked to him before, but he acted like, you're not just accepting this fairy tale as true. Like, what? I can't even believe it. He seemed like that was just out of his realm of experience. You're just supposed to believe the story because I thought everybody was under a spell here, guys. What happened?
Wasn't he in his house whenever he told him to get out?
I don't know if it was that one. Maybe. I don't know if it was that guy. I don't think it was this guy. So that guy, no, I think that dude was. This guy went on one of the last. It's supposed he went on like the last one or the second to last one. 18 or I don't freaking know. But it's very. I mean, all you got to do is watch it. You can know instantly this guy is just like he's acting. He's just like playing a role. It's easy to tell. And like they didn't give him like an extensive script. And this is what I was talking to talking to Dandelion and a couple others about this. It's like, so it was a psyop on the American public and the world. Who maintains the psyop? Like, what happens when all these people die off? Who keeps it going? Did they like pass the torch to some other people? Keep this moon hoax going, guys. I know you weren't even alive when we started it, but it's your duty to keep the moon hoax going.
Well, I think that's why they have the. We'll go back next year. We'll go back 5 years. We'll move it to 10.
Yeah, I think the moon landing was propaganda designed to scare the Soviets. Like, oh, if we can land a rocket on the moon, we can definitely land a nuclear weapon on you.
I think the Soviets and the United States are just both bullshit, quite honestly. And that they just want to control their domestic populations. And they have a lot of, like, every nation has that one thing in common. They do not want the rabble to grab their torches and pitchforks and take over. So you keep them distracted with bullshit. Bread and circus. We're great. We have a space program. We're just, I mean, there's other things to this. I mean, I wish Yoder didn't leave because there's unclassified documents that says NASA, like when it was created, that the purpose was to create the impression that we were so technologically superior that no one would go against us. It was completely made as a psyop. That's where it started, as a psychological operation. In their founding documents. Yoder has them all. He's not in here right now, but I'm sure they're in our DMs. But I mean, that alone, that the documents have said that we're not actually doing anything. We're just making people think something. That's it. I'm joining.
Not
Breaking
you,
in,
I'm
I
sorry.
gave Tactical Joy this stack of documents, Indio. He can post like all the PDFs. Those aren't all the PDFs actually, but most of the PDFs I posted for him, so he can re-host them here. I gotta go though. I can listen.
All right.
Yeah, I've got one that's still wanting to load. 5918 is taking longer to load than the rest.
Welcome, Big Hoss. What was your interest in flat Earth? Like, have you heard anything about it before?
Yeah, I mean, I've heard a few things. I'm not trying to be like a hater or anything. I just kind of want to see what you guys are talking about.
Well, I mean, the topic. We're an intervention program. Most people can't admit that the globe Earth, as far as personally as far as they're concerned, is a belief, and they won't admit that. So it's a problem, right? It's because you first got to admit that you just have a belief. So, for instance, if I ask you or anybody, how do you know the Earth's a globe? And don't tell me how you think somebody else knows it. Like how they know
Sure. So you're
personally
saying,
what their primary information is, and they don't have any.
yeah, no, I think I know what you're saying. You're saying that like if you're going to be like, oh, well, trust the science or whatever, it's kind of just like
Yeah.
taking it at faith.
Yeah, well, even that is saying they know. It's not saying you know. You're saying they know, right? The scientists know it's a globe. You don't personally know.
Sure,
They
yeah.
know.
Yeah.
So for you personally, it's a belief, and they have a hard time just admitting that simple thing.
Yeah, I can agree with that.
Which kind of like pulls the rug out from the whole I can't believe you guys are flat earthers, when all they're really saying is, I can't believe you don't believe what I believe, which sounds crazy, right?
Yeah.
And then they start rationalizing it, and they say, if the Earth is flat, how does this work? If the Earth is flat, how does that work?
They've never said,
Yeah.
if the Earth is a globe, how does this work? They've never said that to themselves.
Yeah, I can see where you're coming from.
I have this funny question I ask people to see how honest they can be. I say, if the surface of the Earth is not curving, then the surface of the Earth must be what? And your answer would be what?
Flat.
99%, I wouldn't say 90, at least 90% of the time.
It's over 70. There's no doubt it's
For
over
sure.
70.
You just want me to say flat, or, but it is curving. And it's like, you can't even be honest about it.
Wow.
Guys, where
It's like
is
painful for them to just say,
Earth?
yeah, dude, the Earth would be flat if it's not curving. But it's a hypothetical. You know what I mean? No one's saying, hey, you're admitting the Earth is flat. We're just saying, hey, hypothetically, if the surface of the Earth is not curving, what is it? And they can't even say it would be flat because they're, for whatever reason.
Yeah.
Don't you find that a little strange?
It is pretty funny, yeah, because people will say things like, "Oh, what if the moon were made of cheese?" You know what I mean? And nobody has a real problem with that, or just silly things. So, what if the cow jumped over the moon? Yeah, and if flat Earth is supposed to be so ridiculous and outrageous, like, why is it so hard to even just say those little words? It is pretty weird.
Yeah, I feel like that's kind of the case with like a lot of different belief systems.
I just want to check and make sure we don't have anybody else in here. If you just enter the chat, don't leave because you can't talk. You have to be manually unmuted if you don't have a role. So, I'll manually unmute you. So, Big Hoss, when you leave and come back, nobody has to manually unmute you because you have the BC verified role. Just tell you.
Nice. Appreciate that. Well, give me 1 second, guys. Sorry. Baby.
Well, I'll, Kadjo? What's his name here? KO. KO.
Ding dong,
Let's see
eat
what KO
it
has
up.
to say.
My mom said I look very good.
What's up, KO? You're unmuted if you want to speak. Hey, he's got our tag. Coolio.
I have nothing to say. I'm just listening.
Okay. Well, hey, I can give you the VC verified role if you just follow a couple simple steps.
I'm driving on my phone right now, so maybe later.
Oh, okay. Well, they're verbal, dude. Like all you got to do is agree that you're going to read the rules and abide by them. That's it.
Yeah, for sure. Then I'll do that. Yeah, sounds good.
All right, word.
Hey, Big Hoss, do you think the surface of the Earth is measurable?
Hypothetically, I guess if you took if you had like an infinitely long ruler or something, I don't know. I don't know what you're trying to get at, to be honest.
Well, Earth as a globe is like a geometry claim. Saying, hey, it's a ball, that's like geometry. And in geometry, to figure out whether something is a particular figure or form, we measure it. Do you think we can measure the Earth to figure out what its figure is or its form is? I think it's
well,
not even in its totality, but a section, even to figure out one or the other.
I haven't really thought about it.
Does it help that most of the surface of the Earth is water?
Yeah, I guess it's hard to measure, like, a fluid, just fluid. I guess is what water is.
Well, I mean, the good thing about the water being most of the surface and it being fluid is that dynamic, you can extend that out, extrapolate that out to the entire surface of the water. So if the water's not curving, then the Earth can't be a ball because water isn't going to be flat in one place and curved in another place. If that water's connected. Right. So in reality, even though we call it the 7 oceans, right? The 7 oceans, there's only one world ocean.
4 oceans. 4 oceans.
Yeah, that's it. There's just one ocean, dude.
Yeah.
Yeah. Is it okay if
They're all
I
connected.
just talk
Well,
as
the
you
7
talk?
oceans are connected as in one ocean. So whatever any part of that ocean, the entire ocean should reflect that part. Now, of course, there's going to be some variation. The tide height, the size of the waves, the currents, there'll be some variation, but like the vertical compared to the horizontal, like the ratio is like that ratio wouldn't mean a fuck of a difference because it's like in the 7th decimal point the difference is. Like if what we call the Pacific is higher than the Atlantic by 50 feet, even it doesn't mean anything as far as whether the surface of the Earth is curving or not. It doesn't confound the result, is what I'm saying.
Sorry, I think hot micing a little.
It's all right for now. You think we went to the moon, dude?
I don't know. I guess I don't have an opinion on that one. I don't know.
What if I told you that even now they're still saying it, that it would take multiple rockets to get to the moon because you'd have to put the fuel into orbit. It would burn all its fuel up just trying to get into orbit. They're saying it now still, even today. That the Artemis needs like 15 rockets need to be launched.
Yeah.
Fuel cargo, basically. So they launch the Artemis, they fuel it up with 15 other rockets of fuel, and then they fly it to the moon. Von Braun said he would need 3 rockets the size of the Empire State Building, and then to fuel those up. Elon Musk has also said it would take 7 rockets or something, 7 starships. So it's turning out to be like if they're actually trying to get to the moon, that there's the story that human beings went to the moon on a single rocket in 1969 is utter horseshit.
Yeah, do you think when Werner von Braun said that, like, was he at that time still thinking like it was possible to get there? You know what I mean? Like, was he taking it seriously, do you think?
I don't know. Now, I know the context when he said that it was actually a production by Walt Disney. Yeah, when he had it was like he was giving like a presentation at Walt Disney did the production. He had little model rockets that he was showing, like in like a model space station. It's pretty weird. I'd probably find it.
Yeah, because that's one thing. I mean, of course, we'll never know the answer. I'm just speculating, but I just wonder, like, at one point they must have actually been like, yeah, let's try to get up there. That'd be cool. Like, at what point did they, people who actually have control of this technology and were trying to do things realize, like, oh, yeah, we really can't do this. Let's just fake it.
What's up,
That'll be
man?
cool. I just wonder at what point that happened historically.
Hey, what's up, man? Hey.
Hey, Big Hoss, do you know who Werner von Braun is?
Actually, don't. I'm kind of here just to learn.
That's why we asked you if you knew. Sometimes we talk about things we assume people know, but then we find out that they don't. So, like Werner von Braun, he was brought over from Nazi Germany. He was the creator of the V2 rockets, if I'm not mistaken, and he was one of the people that helped found NASA, and good friends with Walt Disney. Yeah, right over here on Operation Paperclip.
What's the Operation Paperclip?
It was after World War II. The U.S. government put paperclips on Nazi German members' files, people that would have been good choices to bring into our government to use for basically propaganda, because that was one thing Nazi Germany was supposedly really good at, was propaganda.
Oh, by the way, the Russians got the other half of the Nazi scientists, and they headed up the Russian space program. So you had Nazis on both sides playing propaganda.
Nazis actually dictated, defeated Nazis partially dictated the post-war narrative of what even happened during World War II. I mean, Hitler was Time Man of the Year in 1932. So a lot of people don't know. He was a friend until he was the enemy.
They hosted the Olympics too when he was in power.
They loved Hitler. Shit, dude, there was a Nazi frickin' rally at Madison Square Garden. They took out full-page ads in the New York Times, front pages. All that history has been memory holes, as usual.
Let me ask you, Big Hoss, if you could find out how to determine whether or not the Earth is actually curving or not, would you care?
I don't know. I guess it probably doesn't really affect my life one way or another, but it's still interesting, I think.
Why do you think it wouldn't affect your life?
Because I mean, what is it going to change for me, like in my day-to-day life? I guess.
I mean, you'll know a little bit more about the place of where you live. It's kind of like you buy a house with like 1,000 acres on it, right? And you know nothing about the land that you live on or the home that you live on, and all you do is stay in one room and you believe that everything else is something else, right? But instead you could go out and learn more about it, right? Go look at the wall, see if there's any cracks in it, fix it, grow some plants, domesticate some animals.
Yeah.
Live a happier life.
I mean, I feel like it's kind of the same as like knowing what happens after you die. Like, does it really matter? At least to me.
I mean, I guess you won't know until you know, right?
Yeah.
But if you choose to remain ignorant, then you'll never know.
Yeah. Well, like I said, I'm here to learn, so.
Somebody new come in yet? Truth Revolution 101.
Yeah, I mean, I think it's worth. I think it is valuable to know that you don't live on a globe. I mean, there's no verifiable evidence of a globe. There's no measurements of curvature, because it can help you to trust your own experience. Whereas one thing the globe propaganda does is, from a very young age, make you think that the way you experience the world is not really right. Like, that's basically what you're told. You know, that's what all children are told. Oh, yeah, seems like it's not moving, but it's really moving at a high rate of speed. Seems like it's flat, but it's really not. So you're totally wrong about that too. So you just have to trust these experts, you know, to tell you how it really is. You know, and then when it turns out these experts are wrong, or these experts actually have no verifiable documented evidence to back up their claims, because people were introduced to the globe idea at such a young age, they're looking for another expert to tell them. I mean, I'm not saying this is you, Big Hoss. I'm just saying what I've observed over time is, especially people who are very resistant to the globe, to leaving the globe behind, to just discarding a failed model. People who are resistant to that, they just need somebody else to tell them, now it's time to get rid of the model. Now it's time to go back to actually believing that reality is the way it presents itself. And you don't need an expert to tell you that, because if the experts who originally told you not to trust your own experience, which is the Earth is flat and stationary, just as it appears, and we see things in the distance that would be impossible to see if we were on a globe of radius of 3,959 miles, you don't need somebody else to tell you that. You can just figure that out for yourself.
Yeah. I was gonna say, so I mean, would you consider yourselves to be like experts as well, or as what you're trying to say is like do your own research, basically?
Yeah, I mean, yeah. I consider the people here to be experts on debunking the globe for sure. Yeah, because people here that have been around here for a while, have spent many years studying the issue, figuring out the mathematics of what the globe predicts, debunking that based on thousands of different long-distance observations, horizon observations, and so on. So, yeah, I think that's the case. But that's the thing. But we also don't want people. We don't want people to just take our word for it. We don't want to be the new experts. Like I just said, you can go out and figure that out for yourself. I mean, that's what I did. That's what other people here did. So, even though it's true that in one sense, yes, we become experts on debunking the globe, like you too can become an expert. It doesn't even really take that long. I mean, the math is not really that complicated, and it's better just to become your own expert.
Yeah, that makes sense. Seems reasonable.
Have you seen the long distance observations, Big House?
Long distance observations. Are you talking about like the thing with the laser over the water or whatever? I'm actually like not that familiar. So.
Well, you're familiar enough to say that, so yeah, you must have seen one of them. Yeah, I mean that's the crux of the flat Earth argument, that there's a whole bunch. I mean, laser tests are one part of the long distance observation. You can do it without lasers, but the ones that are most carefully documented, some of the most carefully documented observations are laser tests. For example, one of the FE core laser tests where the laser hit the target at a distance of 25 miles when the predicted curvature there would have been having that target hidden by 297 feet of non-existent curvature. So that's cool. Yeah, so you understand the main argument then, or you've heard it before. That's great.
Cool. Sorry, I'm a little bit out of it, so let me send it. My energy is low right now.
Oh yeah, I understand. Mine is too. So yeah, no judgment here. We're just glad you're here. So that's fine. Did you have any questions about anything else about the flat Earth?
Not in particular, no. I was kind of trying to just listen for a minute.
Sounds cool.
Cool.
Josh Ingersoll is here.
Who is that?
He's a satellite person.
Welcome, Josh. Very interesting.
Is it?
Well, he's supposed to wait to speak to me before he rejoins. So clearly can't follow directions.
The other one. I mean, I didn't
All
do
of
anything with this one. If you did, that's whatever you said.
Yeah, that's why I flagged that I was in here. I'm just listening, but happy to chat.
No worries, dude. Listen, I'll tell you what I'll do. I'll move you to a channel, then I'll talk to you. Then you can come back.
Depending on what his response is.
Oh yeah, I talking to him in the channel. Yeah, it's scary, but he's already gone, so no time for a warning.
Did you move him or did he just bounce?
I was trying to move him, but then it didn't show, so he must have not
too
been paying attention.
bad. Yeah.
I wanted to ask him about the 22 rockets. Because he
Yeah.
said he's a moon believer. I wanted to grill him on that.
Well, tell him to come back and ask him whatever it was you're going to ask him. I'm not supposed to talk to him. That's my personal commitment to myself. I guess since it's only to myself, I could break the commitment to myself, right? Because
Yeah, but then you'd be mad at yourself.
No, it's fine. Just listen. And you'll ask him about
probably
the
for the
rockets.
best.
It'll be
Yeah.
hilarious.
Yeah.
Vintage wants to know what's up with Josh. Josh is a product manager for Amazon. They changed the name. It was Cooper, and now they changed it to like Leo or something. They changed the name. So they're trying to do an imitation of Starlink, basically, and have satellite internet. And Josh is the
Well, I got his
glorified
bio.
fucking salesman, basically.
I screenshotted his bio, so let's
Oh,
see.
yeah.
He's got uncut rocket footage and some ISS pressure sensor, space lasers, and laws.
ISS external pressure sensor. Oh, my Yoder must have hurt him somewhere.
Hey guys, sorry, I invited my friend Chums. I don't know if you guys can like unmute him and like ask him the questions or like agree to the TOS or whatever. Stones.
Oh, okay. What's up, Stones? What a weird name.
Hey man. Hey guys. Yeah, it is a weird name, I think. Sorry guys. It's funny.
Yeah, what's up?
Me.
Here to ask questions?
Wait, we're asking questions. Who's
I mean,
answering?
I don't know. I don't know why he invited
Who's
you here.
answering? Who's
The
answering?
big house bring in here.
I thought it'd be
You-
interesting. So,
You're a Glober, Joan?
No, I'm a flatter, but I'm a flirt. But if you want to fucking answer questions, go ahead.
Oh, he's a flatter and a flirt. Do you have a boy band called the Five Flatters?
I do. I love them. I love when they kick their legs up in the air.
Must be Ocasio Falls.
Right. So, if you want to start having a conversation, what do you want to talk about? The ice wall, or do you want to talk about the firmament?
Ice wall. Who the fuck?
Oh, you're so gonna get wrecked in here.
No, I'm just wondering who believes in the ice wall.
Don't talk about getting wrecked.
What do you think the origin of the ice wall is? The origin of that idea.
The origin?
Yeah.
Well, I don't.
The
I
idea
don't
of an
think
ice
the
wall
origin has
perimetering the
anything
Earth.
more to do with life than it does with God.
No. It came from.
No, it came from God.
It came from
NASA
Captain
documents.
Cook. No, it came from It came from Captain Cook. If you look on old maps, they'll say Great Ice Barrier.
There's
right.
waterfalls.
Captain Cook tried to find a way into Antarctica and sailed for 60,000 miles and couldn't find one. So they called it the Great Ice Barrier. Ice wall comes from globetards. It doesn't come from us. So that's what I'm asking. Like
true.
ice
That's
wall,
actually
who
not
believes in
true.
that?
It's
Yeah.
water. It's waterfalls.
No, the idea originated with globetards. Originated.
Okay, well, fuck you then. I'm not a globe-tard. I don't.
He's not calling.
Then why are you getting
Relax.
upset? Because if you're not a globetard, there's a saying: if you throw a rock in a pack of dogs, the one that yelps is the one you hit. If you're not a globetard, what are you whining for?
Yeah, he's just telling you where the idea of ice wall came
I
from.
said
It came from globe believers. Okay, we're not saying it came from you. We're saying where the idea came from. It didn't come from our community. We never claimed any ice walls.
Okay. All right. So, fair enough. Don't believe that you had a hand in deciding all of this, but
If there was an ice wall, would it mean the Earth is flat? I mean, even if there was one. No, it wouldn't mean anything. So let's get to the brass tacks. What would mean the Earth is flat?
Sorry, it would actually mean that.
So if there's an ice wall, therefore flat Earth. Walk me through that logic.
Okay, so if there are boundaries around the world, the world,
well, maybe it's a boundary on the globe.
No, there's no globe.
No, if it was a globe, there could be a boundary on the globe, right? Like say the Arctic Circle was a giant fucking ice wall around the ring. The whole Arctic Circle is a big fucking ice wall, right? So there could be an ice wall and it would still be a globe.
No, I don't agree with that.
So that's not possible?
Well, I guess
that's what they say exists right now.
Well, I don't think the world is a globe. That's what I'm trying to.
No, what I'm saying is right now they say that there's...
Why am I being...
I'm just explaining things to you, dude. What, are you drunk?
Yeah, I'm a little drunk.
Okay, so
you don't need to take it personally. Just he's trying to explain things to you so you understand them.
So right now they say Antarctica is a giant ice sheet, okay?
Yeah.
And that ice sheet extends out way into the ocean.
It's not a continent.
And that if you sail south, you're going to run into this giant ice wall, this giant glacier that is on top of the landmass that's Antarctica. So they have an ice wall, okay? And the globe has an ice wall. So there can be an ice wall and the Earth can still be a globe. Okay.
Yeah,
so
okay, that's
it doesn't
fine.
decide it either way. What does decide it is whether the Earth is flat or curved. That decides it. It's the only thing that can ever decide.
No, it doesn't decide it at all. I don't think, in my opinion, that.
Well, what do you think would decide it?
None of that is is an explanation or a proof. I don't
care about explanations. I would care about what would decide it one way or another.
Well,
flat or globe.
Not that. Is what I would think.
What?
What do you mean what?
Right, what specific observation can we make that would prove flat or globe?
Well,
observation or measurement.
Okay, you could talk about laser experiments. You could talk about a few other things. But I'm not saying the ice wall is proving anything. I'm saying that that's just like one way to talk about something that is obviously like a that's not something that is a disproving or gotcha. You know what I mean? We can have other conversations about things that exist. The ice walls is not one, but I do think that is the truth. But, okay, so fine. Let's talk about
He's just trying to explain to you that the ice wall is just a description of the coastline of Antarctica.
Okay, that's perfectly fine on either side. I don't necessarily think that
so it
one
can't decide anything. That's the point I was trying to make. We're only concerned.
That's fair.
Hold on. We're only concerned in the evidence, which will prove one way or another which one it is. We don't care about the things which could work either way. Why fixate on them if they can work either way? They're not going to tell us anything. We're just wasting our time arguing about.
I don't know why that.
Well, I'm just saying, dude. Why? You got to be cocked, dude, because you're taking everything personally for no reason, dude.
I'm cocked.
Dude, it's not personal. I'm just giving you information, dude. You're obviously new to this topic, so.
No, I don't think I'm new to this topic. I've read a lot. I've thought about it a lot.
That's okay. There's a lot of people who talk about this topic. The point here that India is trying to tell you is the arbiter of if your floor is flat is the measurements of your floor. If your floor is curved, you would discover that by measuring it.
Yeah, I agree.
Yeah, you wouldn't look at your ceiling lights or talk about whether your wall is made of ice or talk about it's warm or cold some time of the day and not some other time. Right.
No,
none of those things can determine whether your floor is flat or curved. Now you can make up stories about why one matches one shape versus the other, which are just bullshit stories. So
I guess I have to agree with that. But I don't necessarily think that okay, so some of this is conversations about I do get misdirected questions or oh, here's my first argument of whatever, right? I don't think that's I think that I have to argue against some of the bullshit quickly until I can make an argument against something that's more nuanced. So anyway,
look, this topic isn't an argument at this point. We're way past that. I mean, we've been talking about this in here.
Well, I've never been in here, man. I'm sorry.
Listen,
I don't want to be
Josh,
a dick. I'm just
listen. We got a dude named Josh. He was just in here. He's a satellite person for Amazon. So all this is verified. He's worked for the UN with their little space nonsense, and we've interrogated him many times. He doesn't actually know anything.
Triangulation?
Well, hold on. And we've talked to him many times, and the best he can do is show government cartoons. Right? He doesn't know anything. If we ask him how any of this shit works, he doesn't know anything. Okay, so the point is that at this point in time, in this so-called flat Earth, globe Earth debate, it's a done deal. It's already over. People just haven't woke up to the fact that the conversation's already done.
Well, I don't think I have a disagreement then with any of y'all.
Well, you don't. I mean, what I'm saying is, you don't have to debate anybody. Because I can ask Josh right here. How do you know the Earth is a globe, Josh?
I thought I was coming in here talking to prove my point and type of thing. You know what I mean?
No, what we're trying to tell you is that you actually have the high ground. They have the burden of proof all the evidence is on your side, so you never need to shy away from anything they say. Just look into it, and you'll figure out, whoa,
Okay,
they have a problem here.
So here's a question, and that's actually like a really nice like of a point to make, because I really appreciate that. So I have a really actually I have a concern. So when we talk about triangulation, when it comes to the idea that
What?
like we have satellites, right? We have
They
satellites
don't
that
use
do
they don't use triangulation. They use what's called trilateration. It's a different thing.
trilateration. Okay,
Yeah.
you're right on that. That's actually true. That's true. So
And also
my
doesn't use a globe.
concern is okay. So I've had several conversations with people about like triangulation and trilateration, which you're correct to use the term. How do I guess like have this argument about like, okay, there's a method to like put define a point on the globe. The globetards
They're not
are
using a globe. They're not finding a
right.
point on the globe.
I know, but
no,
you have
no,
to
no, no,
understand.
no. Listen, brother. What you don't understand is even though you look on your phone and it shows the globe and says latitude and longitude, that's not how the GPS itself functions. That is shown to you in a coordinate transformation within the receiver. It changes the coordinate system from Earth-centered, Earth-fixed to a geodetic reference system. Okay, so it changes it. That's not how the receiver actually works and functions within it.
I don't understand that. Okay, so
I know you don't.
Make that clear to me.
Okay, so find your position on a plane.
How do you make point A to point B make sense if you're not like using that method? And that's what's frustrating to me, because I keep trying to like figure it out. I just don't get it.
Okay, I know things are hard. They're using a coordinate system called Earth-centered, Earth-fixed, right? Which is a plane. So the actual coordinate.
What is it? What is it? Earth what?
Earth-centered, Earth-fixed.
Okay.
Okay. But the coordinate that they're putting you on is on top of that, on top of a plane. They're not actually measuring any of that. They're not measuring any globe. They're not measuring any of that crap. So GPS is a passive one-way beacon with a timestamp inside of it. Your receiver picks up that timestamp and says, hey, it took this long for the signal. Hold on. Took this long for the signal to get here. I must be this far away because of the speed of light. And then it does this with multiple, transmitters, beacons. Okay. They can be in the sky. They can be on the ground. They can be anywhere. Okay. Now you have a bunch of overlapping circles, and that's where it puts your position, but it doesn't put your position on top of a globe. It puts it on top of something called Earth-centered,
like a flat
Earth-fixed.
map.
Earth-centered, Earth-fixed. No, these are listen. You're trying to reify a mathematical model and say, hey, dude, this mathematical model, there must be reality. No, dude, we do this all the time. This is well known in all sorts of engineering of everything, is that we'll use a mathematical model, but that mathematical model doesn't have any ultimate reality to it, right? Other than the output. What happens in the guts between the input and the output?
Reification.
It's called a reification fallacy. When you make an abstract idea,
it's beautiful. I love that.
Say it's real.
I'm gonna say it to my friends.
There's a bunch of stuff you can learn about logic, and if you just listen, you can actually learn a lot about how these things work.
Yeah, we have a whole channel, like if you go down, there's information channels with all of these topics at infinitum. From not just like, these aren't like flat earthers. We're using official sources of how they say it works. In the guts of it. Now, there's always two different narratives to this stuff. There's the way people think it works, and like second order people will talk about how they work.
And then when you look into the guts of the devices and how they actually work, it's often quite different.
Okay.
Yeah, so like they are all functioning on the same plane of existence that we are functioning on. So they're drawing angles from a flat surface to a horizon, and they're calling it locally flat, and they're using horizontal planes. Right? That's just the base of what they're using, and then after the fact, they turn it into a globe because that's what you expect to see.
Can you see in the chat?
Do
you see the live?
Are you
Do
talking
you
to
see
me?
the text channel that's right above this voice channel? It's called the Livestream voice text.
Are you talking to me?
Yeah.
I could see chat, but I don't see.
I don't know if you even have the BC verified role. Hold on, let me give it to you.
I'm not. I don't think I've. I don't think I've.
Yeah, you got it.
No,
So
Chum, they're
there's a
not talking about the side chat. They're talking about the one above it.
Yeah, someone pinged you in it.
Wait. Oh. Somebody
Right
else.
above here.
Something else.
It's not the embedded chat. It's the chat above it, above this one.
Hold on. Let me look. Does it say
Yeah,
lobby?
if you lower,
Someone just pinged you in it.
no, yeah, if you lower this window and then look up right above it.
This is the one with the Nazi stuff.
Nazi stuff.
What?
All right, can I help y'all out real quick?
Written.
Let me help you. Hey, guys, let me help you out. If you open the embedded chat, there's literally a disclaimer with the link straight to the live stream voice text chat.
German Nazis. Which is it? Right there.
Yeah, scroll down. We were talking about Project
Hold on.
Paperclip.
I just found it. Okay, now I got tagged. Okay, so and again, this isn't stuff that I'm like unaware of. Like I've looked this stuff up like a lot. I don't get this part of it. This equator slash like the X axiom and the Z north.
Do you see the? Do you see the? Look. Do you
What
see
does
the?
it say? Griff Z.
Okay, look. I'm gonna post it again. Look at the image, the diagram I posted. You see that?
Okay,
with a
I'm
little
looking
square.
at it.
You see the ball with the square on it?
I see the ball with
the square.
That's
There's a little square on it that says. You don't see the little ball with the square on it in the chat
I do.
right now.
I see it already, and that square is
Look,
confusing.
where the coordinate system actually is on that square. It's not on the ball.
Well, yeah, obviously.
Okay.
I see that.
Okay, so they take this coordinate system and do what's called a coordinate transformation or a geometric transformation and convert it all into latitude and longitude and then show it on your phone with a little image of a globe. That's how GPS works.
The actual observer is in the middle of this imaginary globe. The globe doesn't actually exist.
Oh, okay. So, like, but again, though, like, I've looked at this stuff. Like, I think I get it. Like, I think I understand, the idea behind this. But it's just.
Well, think. How do they get the? So you have the origin of coordinates, right? The center of that sphere and the square.
Yeah.
How do they get the height, the distance of the square to the center? You think they measure that? Of course not. Okay. They presuppose the distance of they just add.
They add?
They just add 3959 to the height of the satellite.
That.
Satellite, whatever it is, right? Or they can use a pseudo range, and if it's a fixed ground station, they can just add a height to that. Because there's all this stuff is black box. You can't open one of these GPS receivers and see what it's actually doing.
Because I don't actually get like what the plate is. Like at the end of the day, like I think that okay, are we talking about the O?
The point was GPS don't prove a globe. It doesn't even use a globe, and it's been around before satellites existed.
What?
Yeah, so did you know that? Like LORAN was a system used. It's the same as GPS, except for they admit it's
radio towers. Okay, it's existed before satellites existed.
No. I disagree with you here.
And the best part about it.
Here's an interesting point.
Sorry. There's no disagreeing. LORAN worked
There's
before
no
GPS and satellites, and LORAN was known to transmit beyond the geometric curve. So.
Wait, what?
Yeah, 1,800 miles, dude.
What do you mean?
I mean, it's supposed to be the Earth's supposed to be a big ball, right? So you should only have a line of sight.
I understand that you can use lasers to like disprove what you could disprove the globe Earth theory.
Yeah,
I get
but
that.
this is using radio waves. That the radio waves you're getting the position of about 1,800 miles out to sea from a ground-based radio station. Right? The curve of the Earth should be in the way. There should be something like, I don't know, 1,800 miles, probably like 100, 200 feet of curve, 200 miles of curve in the way. Meaning there should be a 200-mile mountain between you and the boat.
And?
Yeah, but there ain't one.
Huh? Of course there is.
There isn't one because they did this for navigation.
I agree with you. I get that. So what are we arguing about?
That GPS, tell your buddies or whoever you're debating, that GPS existed before satellites.
Okay.
Before satellites. Before the first rocket was ever launched. Before Sputnik.
Again, my question is, how do they do it? How do they make it fake? Like, how do they make?
They put a little frickin'. I told you they do a coordinate transformation and show a little ball on your phone.
Yeah, they also have so-called geostationary satellites.
Look at it this way. Okay, so hold on, Andres. So on your phone, they can make an app called GPS, right? And instead of showing you a globe, it could be frickin' Super Mario. And they could plot your position based upon the coordinates, because Mario is actually just like a wireframe coordinate system. And whatever your phone says your position is, they could map that to Mario. And you could think you live on a fucking 3D Mario.
Yep.
I guess.
Not I guess. That's the way it is, dude. Just because they show you a fucking cartoon don't mean nothing.
Well, I think it looks pretty professional, but I'm not saying
so it's
that
so good. Here's how good it is. Okay, listen. Black out all your car windows and drive using just the GPS. Just stick the GPS in the dashboard and take the turns when the GPS says the turn.
If you're saying that these are fake images, I want you to tell me why they are. And that's also part of the things that I have arguments with my friends about, is like, why are these fake? Well, I don't actually have a good argument.
Because they depict something that's impossible.
Well, then I will tell them that. But
you've seen images of Santa, right? Santa Claus, right?
Dude,
you've seen
you know what I'm talking about. You know what I'm talking
am.
about.
Listen closely. Have you seen images of Santa?
Have you seen images of the globe?
No.
Okay, well, first of all, give me permission.
The point is, you're trying to think of your excuse before you actually listen. Okay?
No.
So really
let me show pictures, and you could tell me how they're wrong.
I am. I'm working. I'm trying to build up logically to that, but you won't let me.
Okay.
It's really simple. Are all images of Santa fake? Is there really a Santa?
I think there's probably pictures of Santa.
Okay, here comes the cope. Listen, brother. Someone doesn't need to prove how every image of Santa Claus was faked. We know Santa's a fictional character.
I mean, you could easily do it for like 1 or 2. And then the ones that I actually care about.
Every single image of Santa is fake, bro.
You would help me make the argument to my friend.
Bro, every single image of Santa's fake. Every one.
I know,
there is no
Santa
Claus.
The globe?
There is no globe, and every single one is fake.
Then tell me, do
you want to know how we know every single one is fake?
Yeah,
because okay. Here we go.
Why
Because
don't
all
you give me
those
the
globes.
option? I'm
Are you going to let me
I'm gonna
answer?
post
Or are you
one
going
or
to keep
two
talking?
pictures
You ask me a question and
of the
talk? Is
Earth.
that your idea? Why are you asking me a question and talking?
I'm sorry.
Okay, so this is how we know every single one of those is fake. All those images depict an ocean that on it has curving water. The water curves into the shape of a ball. We can go to the ocean and try to measure this curve, right? Because it has to be curving. If
with
the
a
picture,
laser, though, right?
if the picture shows curving water, then when I go to the ocean, what's supposed to be in that picture is the ocean of the Earth. I should be able to go to the ocean and measure that curve to see if it actually exists. The thing is, that curve doesn't actually exist in reality. It only exists in a stupid image somewhere.
Listen, I agree with you 100%. I've seen
Just
that
like
video.
if they
I've
showed an
seen that
image and there
video,
was
and
spikes of freaking quartz crystal sticking out of their freaking image of the Earth, I could just go to where those spikes are, and if there's no spike there, I know that image is bullshit because what it depicts doesn't exist in reality. That's how we know they're all fake, okay? Because what it depicts doesn't exist in reality.
Well, okay. I don't disagree because I saw that laser video and I thought it was.
There's way more than
I
one
thought it was
laser test,
damaging.
dude.
I thought it was damaging, and I'm not fucking mad about
There's
that.
way more than one.
Well, I saw one.
And there's way more than those distances. There's 800, dude. There's a 10,000-mile radio transmissions.
I have
Did
trouble.
you hear that correctly? 10,000 miles, the United Kingdom to Australia. Radio transmissions before satellites existed. Now, how do you do that on a ball?
Well, okay. So here's a good point.
You certainly can't do that over curving water.
Brother, I agree with you in that term. Like here's what I'm gonna say.
I don't know. It kind of makes sense to me. What are you saying?
I have friends who I can make the same arguments at, and then they're gonna tell me, well, here's a picture of the globe.
Yeah, and you ask them one question. Okay, how can we test that image to see if that's actually what the Earth looks like from space? What if the Earth is a cube from space? What if the Earth is a freaking pyramid from space? How do we know that what's in the image is what the Earth looks like from space? Okay?
I mean, I guess
how can listen, you ask them, how can we test it? The only way you can test the authenticity of the image is to see if what's in the image actually exists on Earth.
Yeah, I mean, I guess okay, so here's the thing. I can't make an argument against like
what
that.
If they showed a Great Wall of China on the East Coast? You need to prove how they faked the image? Can't you just go to the East Coast and see there's no wall there?
But it's okay, so what's my
I know,
argument?
it makes too much sense. I know it's painful.
I have a problem fucking making the right argument. Like, you understand what I'm saying?
It isn't our argument. They're auto-believing in something. And why should anybody else believe it? See, they're doing something called reversal of the burden of proof. They're saying, hey, dude, these are images of the Earth to space. Well, that's begging the question. How do you know any of that?
Well,
how do you know that that's an image of Earth from space? Just because someone said, here's an image of Earth from space. So what?
Yeah, I agreed. I don't.
So are all images true unless disproven?
I mean, okay,
why do they deserve to be believed? Let me ask you this: why do the people that claim that those are images of the Earth from space? Why should you believe them?
Well, because they're the ones. They're okay. So
should. I want the should thing. No, stay on the should. Don't try to run away from it. I want the should. I want the should. Why should you believe them? Give me one good reason.
You need to support the evidence. If you make the claim, you need to support the evidence. Wait.
No, but why should you believe them?
Well, I don't. But then.
Well, why should anybody?
Okay. Well, let me. I'll show you a couple of pictures.
Why do your friends believe them? Hold on. Let me ask you this: your buddies.
They look right. They look correct. They look like.
How do you know that? How do you know they look correct when you've never seen the Earth from that point?
Man, I'm just trying to tell you.
No, I'm asking you. I'm asking you. Shh. Stop talking for a second. How would they know if they're correct when they've never seen the Earth from that point of view?
Well, that's part of my first argument then. How would you know if you've never seen the Earth from that point of view?
No, well, people say, we've heard people say, well, they look realistic. Well, how do they know they look realistic? How do they know what real is when they've never been there to see what it really looks like, right? They have nothing to compare it to. This is the problem. And this is why they bring it up, is because those images can only be believed and trusted. Look at the title of this chat, Globe Believer Intervention Program. We are here to point out that the globe Earth is just a belief. And if your evidence is government cartoons because people said, I went to space and took a picture, and you simply believed what they said as holy writ and can't even say why anybody should believe that shit in the first place. Why should anybody else believe it?
And but again, like, I struggle to make these arguments because I just like don't know how to
Dude, the
argue
space
against
images,
some of
that's
these
very simple
pictures.
argument. Why should you believe it? Like, yeah, they claim these are images from space. Yeah, so what? Why should I believe them?
Yeah.
Give one good reason why you should believe them. I can't think of a good reason.
But okay, well, I could say that all day and say I don't believe that that's a real.
No, I didn't say claim you don't believe it. I said ask them what. Listen, brother, you're getting confused. Ask them the question. Listen. Yep. Ask them the question why you should believe it. I didn't say you don't believe it. Say, hey, I'm open-minded. I want to believe them, but why should I? Really simple.
Yeah.
But why should you?
I have asked them. I got mad.
And what was the and should believe them?
They told me I was a dipshit.
Well, so they didn't have an answer. They didn't give you any reason you should believe them.
Yeah, they told me I was retarded. And I didn't have an answer. And I felt...
You felt like an idiot about what?
I told them that I didn't believe it was a real picture. Then they
Why
told me
should you?
Retarded.
I'm going to ask you, like, for the 10th time. Listen very closely. Why should you?
Because it's a really good picture. It's like a...
How do you know that?
I don't know. You tell me, dude. I don't...
No, I want you to tell me. I want the people that claim they're real to tell me why I should believe it.
Well, I don't know how to do it.
To ask a question of why you should believe it?
Yeah.
Look, if someone comes up to you and says, I rode a unicorn and I was riding Bigfoot double on the back. Isn't it fair to ask? Hold on. Isn't it fair to ask them why should you believe them?
Yeah, I guess. I mean, I guess.
So if someone says, "Hey, this is an image from Earth from space,"
that's what I'm trying to explain to you.
It is completely fair to go, "Well, why should I believe that?" What? That's completely rational, fair question. This is why you don't like it, and this is why it's not a liked question. People don't like this question because when these things that are based completely on faith, when you ask, "Hey, why should I follow your faith?" Because that's all it is. You're following their belief because they have no knowledge if that image is real. They didn't take the picture. They don't know if that's what the Earth looks like. They don't know any of those things.
I don't think it's real at all. But
all they're trying to do is to get you to. Well, all they're trying to do, you don't know if it's real or not. Neither do they. That's the point.
I know it's not
real. He's teaching you the vulnerability of their argument. He's not critiquing you. He's showing you how their arguments are vulnerable. So just try to follow what he's saying.
I'm trying to tell him.
Look, what they try to.
I'm struggling with the argument, and I don't know.
They don't have an argument. That's what I'm trying to point out. They're trying to get you to assume that what they're saying is true. This is an image of Earth from space. They're trying to get you to agree to that.
Yeah, they're saying
they haven't demonstrated that that's actually the case. That that's even true in the first place.
They're saying this is an image of space. Prove it's not. That's what they're trying to get you to do.
Basically, yeah.
What is that?
Yeah, they're shifting the burden of proof onto you, and we're trying to help you realize that that's not your burden to bear, and you can just simply be like, oh, well, your image is showing the water curving here. Where is it curving in reality?
Wait, I can't see the picture.
Picture what?
I thought you were saying this is a picture of Earth.
Oh, you want a bunch of pictures of the Earth from space? Oh, I got a whole.
No, Well, that's my problem. That's hard. That's like
It's
half
not a
my
problem.
issue.
That's what we're teaching
They don't even
you.
look the same, dude. It's not a problem. It's a problem for y'all, for freaking globetards.
I'm not. First of all, I'm not a globetrotter, but also I just don't know how to like say the right stuff to like tell this person like, hey, you're actually not like looking at this realistically.
Yeah, don't let those people get you down. Sounds like, I mean, you're the one who has the higher ground here. They're just
I don't think I do.
resorting
I
to
feel
insults.
bad about myself. Like I feel like I can't do it. I feel like I can't make a good argument when they show me the what?
Which one? Which image did they show you? Look in the chat. Look at all these Earths. Which is the actual?
I can't
What is
see
the?
anything in chat. I can't see anything. I don't even know what.
I don't believe you, dude.
Okay.
You already seen it. You already said you could see it.
No, I
You
never
were
said I
reading
could
it
see it.
earlier.
Yeah, I said you see the square, and you talked about it. Remember?
Yeah, I know what picture you're talking about. I don't know. I
Okay.
can't see
So there's
any.
an animated GIF that has a bunch of globes flashing. Which is the? Which one does the Earth actually look like? Because none of these look the same. The animated GIF that says "busted."
Hold on, let me find it.
It's only up like 5 posts, man.
Are they? Oh, they're in the above chat, not inside chat.
I don't think I'm allowed in the chat or something. Like I don't see
You
it.
are.
What's it called? What's a chat called or something?
It's directly above where all the people are in the live stream. There's another
Live stream
little...
voice text?
Yes.
Okay. Hold on. Okay. Oh, yeah. Definitely seen that one. Okay, so when the
Can you
Clidio
tell
one,
us which one of these is the one that looks like Earth? Because none of them look the same.
well, I believe actually that none of them do actually have any sort of like.
Well, what about your friends?
Well, again, I'm trying
to pull up the images, so they haven't gotten there.
I could copy and paste these to my friends who would just like laugh at them and go like, "Hey, that's not like."
So they're all real? Why
That's
do they
not
look
real
different?
NASA images. And I'll be mad. I get pissed off about it, you know?
Well, how did they? If they believe in these images, how can they explain the inconsistency?
Well, I don't think
they all
believe
can't be
in all the
real,
images.
dude.
I don't think they
Some
actually
have to
believe
be
in all the
fake.
images.
Okay, yeah, I can see how there's like the two totally different perspectives there. That's kind of like a.
Yeah, I think the problem is you need to realize that you don't need to play defensive. You need to play offensive.
I need to be offensive.
Yeah, you need to realize that the ball you don't have the burden of proof. You experience the world as flat and stationary. That is their experience as well. That is the starting axiom. So they have a claim that's contrary to all observable reality as we experience it. And so they have a very high, extraordinary burden they carry. Extraordinary claims require extraordinary evidence. So where is their evidence?
Wait,
now
who said
they
that?
have
Who
to start
said that?
presenting evidence, and they don't
Carl
have
Sagan.
any valid evidence.
Wait, Carl Sagan said that?
Yes.
Wait, Carl Sagan? Guy who like a astrophysicist?
He also said,
he thought the world was round, yeah.
Yeah, he's a dingbat.
Yeah, but this is why you need to learn logic, bro.
It's like an all or nothing fallacy, though, dude. Just you don't. There isn't 100% right in anybody.
Of course not.
Yeah, if you learn logic, you'll understand when they're trying to pull these sneaky tricks. They're trying to use all or nothing fallacies, or trying to pigeonhole you into something, trying to flip the burden, use a straw man, and you can be like, "No, I'm not claiming that. No, I am being super logical and reasonable." And that just makes them be the unreasonable ones, and they start being like, "Wait, maybe I should pull back on this unreasonableness, and we can have a proper discussion."
Let's take it one step further. Like
Yeah,
you said,
you get
appeals
one
of
step
authority.
further that way.
Yeah, so appeals of authority. Here's something else Carl Sagan also said. One of the great commandments of science is mistrust arguments from authority.
Too many such arguments have proved too painfully wrong. Authorities must prove their contentions like everybody else.
Yeah, use the hostile witnesses of their own religion that they look up to. They think they're standing on the shoulders of giants, but Newton actually called them
Wait,
not,
that's what
not
you said
able
too.
to.
That's what he said too.
Yeah, Newton basically thought
Standing
that
on the
anybody
shoulders
who
of
would
giants.
fall for the theory of gravity and believe it would not have the capacity for philosophical thinking.
Okay. Well,
This,
so
Jones, just so you know, brother, just so you know, this is what's called a hostile witness. We're holding their own words against them.
oh, that's smart. That's a good idea. I never thought about that.
Yeah, you
Hostile
don't need
witness.
to defend anything. You're just looking at reality. Reality is presenting itself to you like this, and they have this claim that's contrary to all that, so they need to prove it.
All right. So, end of the day, they need to prove why their picture. Because again, this is the thing that like gets me fucked up. They need to prove why their pictures of the Earth are like real pictures. And
You can do
not
it
the
really
other way
simply,
around.
bro. Just take when they post a picture, you just look at the picture and say like, look at that edge where it's curving the water over there, and they're like, yeah, it's curving, and then you're like, where's that in reality? The checkmate right there. They don't have that.
Checkmate him. I'm gonna checkmate him by saying, "Hey, do you see that? How this isn't really real life or real water?"
What if it was an image of the Earth, right? And they showed the Great Lakes in Mexico City. Right? We can go to Mexico City and see if the Great Lakes are there, right?
Yeah.
We don't need to prove how that image was faked at all. We go, hey, dude, we went to Mexico City. There ain't no Great Lakes there. That image is bunk.
Yeah, but I was thinking like we can't go to like your average person or like maybe nobody can like go to space and like take a picture of the Earth, so you can't like objectively see that with your own eyes.
Whether you could or not, even those images still need validation with the Earth.
Yeah, we can't replicate their fakery, but we can test their claims within the images. So if the image is showing curved water, that curved water would be in reality, and we can go back to the ground and check if the ground is actually curving. The ground isn't curving, so they die.
This is exactly the
That makes sense to me.
find out. I was trying to figure out this. I was trying to figure out a way to explain this. And now I think I understand it. So like basically like when I like look at a picture of the Earth from like NASA or whatever, it's on the onus is on them to explain how that's true, and also
how do they verify that? How do you get to verify that photo and take the same photo just to verify it?
Yeah, I agree. I guess I don't know how they could ever like agree or say that it's true.
Yeah, they'll believe it's true. That's very common. What you can just tell them like
very common, yeah.
like we can't go there and we can check that. That's fine. But can we somehow like see if this image is true? Like, is the water curving? Oh yeah, it's curving. Well, then let's go check in reality if the water is curving. Oh damn, it's not curving. I guess the Earth is flat after all. Damn it.
Oh shit! Yeah, I guess I fundamentally missed that point.
Well, actually, I think it makes sense for them to say it is curving. But I can say
based on the photo, but then like
prove that it's your job to prove that, not mine. Yeah.
Yeah. No, you don't want to be like it's your job to prove it's curving because they'll just be like, well, I believe in the astronauts and that's the proof of the curving. But you should question the evidence they're presenting because they also just believe in this evidence. It's not actually empirical, something you can test for yourself. You can't go up there and see the Earth like that. You can't verify it's actually curving like that. But through going there, but what you can do is actually look at the surface and see if it conforms to the curve they're showing. A lot of the times when you look at ISS footage and they're showing you like high altitude balloon footage or whatever it is, just pay attention. Don't ignore what they're showing you. At the beginning of the on a balloon launches, you'll always see the horizon is curved because they're using fisheye lenses. So you just stop at the beginning of the video and just be like, "Bro, are you kidding me? Your Earth
I
is
mean,
so,
look,
so
that's
small.
what I'm
If this is
thinking.
the Earth curve, you cannot have all the continents of the Earth. So this is nonsense. So if you go higher up, you're still going to be just as curved. It's not actually Earth curve; it's the curve of the lens.
Okay,
And
but
so you
all
can
right.
dismantle all of their arguments if you want, but at the core of it, you can always just drag it back to the Earth being curved or not, which is the measurements of the surface. And that's where you win, because that's the deciding factor. Is it curved or not? Did you measure your table to be flat or to be curved? You measured it to be flat, well, then it's not curved. That's basic logic.
And I do think that that's a really good way to like respond, but also like I'm gonna have
That
to come
actually
back
made a
to
ton
you.
of sense to me.
I'm gonna have to come back to you guys with some arguments because I have friends who are like very like
We
they
get you,
have a lot
bro.
of
We get you. We've dealt with globe salads like for over 10 years. So this is nothing new to us. You can bring every single arguments they think works. We'll show you where the logical fallacy is. We'll teach you how the fallacy works, and then you can just dismantle their stupid arguments, which are actually non-arguments. And then you can present an argument they can't refute, and then they'll just be like stuttering idiots. Like normal.
Well, all right. Thanks, Drake. Drake, is your name Drake or Drace?
It's Trace AI.
Drace AI. Are you Are you AI?
He could be.
No, but a lot of Globers think I am.
Goodness. Well, that's funny. Also, I like Huawei Day.
Do you guys have any like resources?
I have
I guess
Nicholas
never mind. You said there was resources in the text channel. I'm sorry.
At the very bottom of the server.
all of that Flower of Life circle that I had. I used to have that whole thing made out of silver on my as a necklace on my chest. Then it got broken. Oh, he left. Oh man, what the hell? Is Dr. Jordan Peterson in this too? Okay, well, anyway, we'll talk later. Thanks for helping me out. I don't really know what else I would.
Yeah, you can always invite your Globe Zealot buddies in here, or
Well, that's
like
what I
Drace.
don't want
Yeah.
to do. That's what I
Oh, you don't want him in here. Okay. Well, that
No,
Drace's plan was good. Yeah, Drace's plan was good to practice. You could bring in if they have a decent, if what they think is a decent argument, then you could bring it in
No,
here,
I
and we
don't
could
think they have a
teach you
decent.
how to dismantle it. Yeah.
I don't think that. I think that I have to have a good one to them. You know what I mean? So I'm gonna do. Oh shit! I dropped my guitar.
No, don't do that.
Oh no, it's fine.
Okay, good.
But anyway,
Don't
all right.
break it.
Have a good night, Joan.
Thanks for talking to me. I really appreciate that.
Yeah, good to talk to you. Come back again.
Yeah. After listening to y'all, I've adopted your tag. I don't know.
Good. Yeah. Yeah, I heard you say you saw the inconsistencies. I think that was what old dude posted in the two different globe images there. That's what we were trying to show your buddy there, but I don't know if you ever actually looked at them, but you did, so that's cool.
Well, yeah. He's a little inebriated, so give him a second chance. Yeah.
Oh yeah, all about second chances here.
Mm-hmm.
Isn't that right, Josh? Oh, he's not. But yeah, no, the devil's in the details, really, at the end of the day, right? Like, the more you dig into it, the more you start seeing how they went about, and sometimes they take the short way around, sometimes they take the long way around, and they always try to put a bunch of smoke screens up. So you just got to pay attention to the devil's in the details.
Yeah.
One of my favorite things to do is I'll give them everything. I'll give them all their explanations, and I'll say, "How big is the Earth?" Like, what do you mean? Then we have to go down that whole rabbit hole about how big it is, and then the next question is, how far away is the horizon from a 6-foot observer? And then that's really what screws people over after that, because most people who believe it's a globe, they understand that when they've gone out to like large bodies of water, they've seen things like 15, 20 miles away.
Yeah. Isn't
And that becomes an issue.
Isn't like the measuring of the coastline, like bodies of water, kind of all about what, like fractal geometry is about?
How so?
Well, I mean, I don't know. Like that's just always what I've heard. Like fractal geometry is like how you measure like something that is immeasurable, like just kind of made up, you know.
That's why they say the coastlines are immeasurable, is because the water keeps rising and falling and the coastlines keep changing, and so the closer you draw in the boundary along the how when the land recedes inwards. I don't have good English for this.
Oh, you're good.
Yeah, the closer you go
high
to the
tide, low
actual
tide.
landmass, the longer the distance around the landmass is. So it becomes retarded way. You can't really define it by its distance without having an arbitrary standard.
Yeah, that makes sense. All right, well, it's getting kind of late for me. I might have to bow out, but it's been nice talking to you guys. I'll definitely be back in this VC if you'll have me.
For sure. Come back anytime.
Yeah.
Yeah, we also have the English Hub and Politics server where we have outposts and we go out and talk to as many globe believers as we can, because that's kind of what we are, the globe outreach community where we try to help the globers accomplish some form of rational thinking.
Yo.
Good morning, good afternoon, and good night.
Fuck, why everybody's silent?
What the fuck? Why no one is talking?
the refraction coefficient is here. Okay, the refraction coefficient is 0.96, right? That's extreme refraction. So now we would need to see evidence that you can have extreme refraction, right? A refraction coefficient of 0.96 without, without a clear shot, right? I mean, with a clear view of what we're looking at.
Yeah.
We don't see any superior miraging effect. We don't see fata morganas or anything like that, right? And this is like ducting conditions, right? And ducting of visible light creates, a chaotic scene with visible light. So,
yeah.
Yeah,
so I will admit, like, I didn't like. How do we say this? I forgot how to say this, but like, shit. Like everything you said, I didn't really like. I can't really remember, but I do like. You know what I mean, right? Because I'll
Yeah.
admit what you said is a lot. Yes.
Yeah,
So
it's a lot
excuse
of
me for if I.
information.
Yeah. So excuse me for if I missed certain things you said. You can actually like. How should I say? Correct me on that if you want. Yeah.
Yeah. And just quickly before you say it, I just posted 2 images in the side chat. So this is the
Yes.
same 2 oil platforms that we were looking at earlier. Okay, this
Yeah.
is what I would consider what extreme refraction would look like. And this
Yes.
is not a condition that you would want to go out and make observations in. Okay, we can see that clearly we have superior miraging effects taking place here. Okay, this is what a superior mirage looks like.
Yeah.
If you type in superior mirage and hit images on Google, right, you're going to see
Yeah.
crazy images, right? Nobody should go out and do an observation on a day where there's a superior mirage taking place, which is extreme downward bending of light. Okay, we don't see any of these superior miraging effects in the observation I just presented.
Yes.
Can I make an addition, DJ?
Yeah.
I just wanted to say, just to kind of like recap it in a very simple form, when DJ showed you the windmills, you could see the black at the bottom. Those all should be completely covered by the curve of the earth. Like they should be down below the curve, just like you would expect when they say that there's a sunset or a boat going behind the curve, right? And that's not to confuse of what's going on, but we're making a clear distinction. In this observation, we know the distances of these objects, and they are clearly not behind the curve of the earth, because the curve of the earth should be 3 miles away, 3 kilometers away, something like that. 2.3 miles away. And they're
Right.
not.
Just I got to go on mute, right? I got to go too because it's getting late here. My wife's getting annoyed at me.
Yeah.
And
Oh, wait.
right, so
I want
just
to say
before,
something quickly, but we can talk another time if you want. We can talk another time.
Just before you say it, right? Just adding to my last point really quickly. So notice that in these last 2 images that I posted, okay, we have very, very heavy refraction on this day. Okay, but notice that the horizon is actually much closer. Right? The horizon's not beyond the oil platforms. The horizon actually looks like it's in front of both of the oil platforms. So if extreme refraction, right, superior miraging, causes the horizon to be so much further away, how come when we have much more refraction, the horizon actually looks closer in this one? That's just an interesting thing that I wanted to point out. Anyway, your turn.
Okay, so if we look at the wind turbine, the turbine close camera shows a large amount of the yellow base above the water. As the turbines get further away, there is less and less yellow base visible by the time you get to the turbine.
I wouldn't say that.
The yellow.
Go ahead, DJ. You're still here. Sorry.
My bad.
Yeah, so it's because it's miles further away, and miles further away. So if you think about how far, okay, so the closest one's 8.4 miles, and the furthest one's 11.2 miles. So as things get further away, their angular size becomes smaller due to perspective. And if we actually draw a straight line across them, we can actually
Yes.
see it is just a perspective effect, right? So
It's
the same thing happens
yeah.
just quickly in the side chat, right? So
Yeah.
the same thing happens here with the close-up image, okay? And we see the same thing happen here with the right, with this image from the zoom footage. So sure, right? The one that's at
Yeah.
8.4 miles away, it's going to look like it's bigger, right? The yellow bit's going to look like it's longer, and the black
Yeah.
bit's going to look like it's longer, and each of that's going to compress into the, well, not compress, it's just going to shrink in the distance because it's 4 miles, 6 or 7 kilometers distance between them.
Yeah. Yes.
Yeah,
Because
think of how
like
big
oh
a
yeah.
soccer ball is. Think of how big a soccer ball is if somebody's standing in
Yeah.
front of you, and then if they walk further away, that soccer ball is going to get smaller and smaller, right?
If the soccer ball is with them, or football, we call it football.
Right. The football, yeah. If the football is with them, they take the football. As they move further away, it's going to appear to get smaller, even though it's the same size.
Mm.
Do you agree with that?
Wait, say it again. I gotta think about this.
Yeah, so if I'm holding a football and I'm standing in front of you and I hold the football and I walk away from you, the football is the same size no matter what, right? Because it's the same football. But because I'm moving away, it appears smaller and smaller as I get further away.
Mhm.
Right?
Yes.
So the
Yes.
same thing with the windmills. The windmills are the same size. They just appear smaller because other ones are further away. The closer ones appear larger and the smaller ones or the further ones appear smaller. But they're the same size.
Yes.
Does that
And
make
what was
sense?
your question? What was your question again?
That my question was if I hold a football in front of you, like if I'm 5 feet in front of you, the football is going to appear normal size. But if I walk away with the football in my hand, does it get smaller or does it stay the same size?
It stays the same size.
Even though I move further away, it's not going to look smaller to you.
What do you mean? Wait, say again.
Here, I'll see if I can post a GIF in the side chat. I wish I had a better.
Yeah.
It's like here we go. Here's a good one right here. Do you see this bowling ball in the
Yeah.
in the GIF? I know the camera is a little wobbly, but do you see how it looks like it gets smaller as it goes further away?
Yeah.
But it's not smaller, right? It's the same size bowling ball. It just looks smaller.
Yeah.
You understand?
Yeah. Do I need to say something on this or like?
Well, I mean, I just want to make
What
sure
is
you
the question?
understand. Is there something
Yeah,
you
I
want
understand.
to do?
I mean, wait. Let me also look at the thing that anti-globalist sent. He also sent. Oh, we can't. Give me a minute.
Sure.
And also about the. Oh, there was okay. So about the other thing in the windmill, right? Yes. I mean, how would I say this? I mean, you are like describing the law of perspective, which is 100%
Yes.
real. Don't get me wrong. When an objective gets further away, it's like gets a size smaller in our eyes. However, perspective shrinks the entire object equally and if I say it right, I don't know if this makes sense, but proportionally, right?
Yes. Generally speaking, without any
Yeah.
kind of
Okay. Wait.
other refraction
Yeah.
and other
Yeah.
effects going on. Yes.
It makes the top, middle, and bottom shrink at the exact same rate. Perspective does not chop off the bottom of an object while leaving the top perfectly visible. Look closely at your bowling ball video. As the ball rolls down the lane, it gets smaller, yes, but do you lose sight of the bottom of the ball? No. You can see the very bottom of the bowling ball touching the wood all the way down to the pins.
You're
floor
not
doesn't
losing
rise
sight
up
of the
and
windmills either.
swallow the bottom half of the ball. If the water were perfectly flat like that bowling lane, we would see the exact bottom of the wind turbines touching the water. No matter how far away they are, they will just look like tiny, perfectly proportioned miniature turbines. Do you have anything to say on that? No, look back at the wind turbines.
Yes, if you introduce variable, if you introduced variables which are not present there, which may be present out at sea, then you might get that same effect.
Come again?
And you can.
Oh, no,
if you introduce, so if you bring into your bowling alley variables, conditions which might not be present, but which are present out at sea with a ship, then you might generate the same effect.
So you say if you introduce variables, conditions which might not be present in the bowling alley, of course, right?
Right, but they're
Yes.
present out at sea. Like
Yes.
looking at ships and royal rigs, then you might get the same effect. Just as, right?
Yes.
DJ already demonstrated to you with the lid, the cap of the bottle,
Yes.
and the yellow part, which seemed to go down below the floor, even though the floor is flat. Yeah.
Oh, let me get that picture again. Actually, I'm gonna scroll back. Okay. Wait,
So
let me see.
something to look at while you're looking at this picture. You can see the bottom of the windmills.
Yes.
It doesn't matter if they're compressing and looking smaller. They are the same size, but because the ones that are smaller are further away, they're going to appear smaller.
Yeah.
Well, he's also disregarding that the further the bowling ball gets from you, the more you have to look up.
Sorry?
Well, we don't. No, that's
Yeah,
man. That's
you drop the
completely
bowling.
sidetracked. That's
Well,
completely sidetracked.
not when it comes to perspective. It's not, because when you drop the bowling ball, you can see it at your feet. As
We're
it
just
goes down
focusing on the windmills.
I know. As it goes down the alley, you have to tilt your head up. And your feet, where it lands, upward.
What does that have to do with the windmills?
It's
Yeah,
all
dude.
perspective.
Yeah,
It's all
dude.
perspective.
Dude, like we're
What-
trying to stay on topic, okay? Like
I am.
Yeah.
It's perspective.
Okay, wait, James, wait. Are you on my side or there? Like, I'm kind of confused now.
Yeah, that's what I'm
Come
saying.
on.
We're trying to avoid confusion, not add confusion.
Hold on a
Okay?
second. When you look at the image of the
James,
bowling ball,
James,
that-
please, I beg
Okay.
you. I beg.
Okay, wait,
seriously,
can I
do me a favor here, okay? Can we shelf that topic or just put it on the back burner till we get to this conclusion and then bring that one up?
Yeah.
Okay,
thank
I'm gonna give my last like phrase before I go, because it's like really late. But I want to know who said who asked me about like introducing variables or conditions which might be not in a bowling alley. Who gave that argument? Can I?
T-Dub.
T-Dub. Oh, T-Dub. Okay. So, like, can I be honest? T-Dub.
I should hope so.
Okay,
not
this is
keep
like the
alive
last
me.
thing I'll say, and then I'm going. I cannot like talk further. You can add me if you want. We can talk further about this, but you kind of prove my point. I mean, you admitted that on a truly flat surface, the bowling alley, perspective does not hide the bottom of the object. You can see the bottom of the ball the entire time. So if the ocean is also flat, why does it behave differently? The reasons
It depends.
boats and rigs lose their bottom half at the sea isn't because magical ocean variables. It's because the
depends.
ocean is
It
not
depends.
a flat bowling.
Let's make the bowling alley.
It
Let's
is
make the
curved.
bowling alley. Let's make the bowling alley 5 miles long.
Can I finish
let's
this?
Make
Wait,
the,
can I?
let's make
can
the
I finish
bowling
this real
alley
quick?
5 miles long.
Well, I cannot extend this conversation, bro. I gotta say this quickly, bro. And then you can say it, and then add me, and then we can continue this. Yes.
Yeah, we already went over sinking refraction and physical obstruction behind waves.
Okay, wait. Let me finish this. Let me then finish this. Let me say this. You can't just claim there are conditions at sea without explaining the physics of what those conditions are. What exact variable is physically amputating the bottom 23 feet, right, of an oil
Welcome to
rig on
Flat
a
Earth.
perfectly clear day? Is it
gotta
waves?
apply
No.
those standards.
No
There's
waves
nothing
don't
missing.
permanently hide
There's
23
nothing
feet
missing
of
of the oil.
steel. Is it
There's
is it
nothing missing of
refraction?
the oil
We
rig.
already established that standard refraction lifts the image, making you see further, not less. The only variable that perfectly cuts
Not
off the
enough.
bottom of objects in
Not
exact
enough.
accordance
Not enough.
with
Sir,
your
not
own
enough. We
calculator
went through this.
is the physical curvature of the globe. And you cannot say anything on it. The
Yes,
physics of
we
perspective
can.
don't magically
You're
change
just
the gist.
ignoring
Because you're over
everything,
water.
bro. We already addressed all of it.
Yeah, and I'm addressing it again, and you address it again.
You're hand waving our reputation.
I think we both agree to disagree at this point, to be honest.
You're just hand waving our refutation.
What do you mean?
Dude, you conceded that you do not have a geometric curve of the Earth.
Exactly.
Yeah, that's fine. We're okay. We agree. You do not have a geometric curve of the Earth. You and I, there's no disagree here. I agree with that statement, and you agree with that statement. Your excuse is you don't see the geometric curve of the Earth, but you do see it, but you only see it optically when it's not also obstructed by the geometric curve of the Earth, which you don't see either.
Okay, wait. Can you say it again? Optically, like.
Yeah, you have an optical geometric curve, a non-physical optical curve that you can't see. You see it because there's another geometric curve that you don't see either. What you've done here is just say your globe is unfalsifiable because you would never even give a reason for why or the distance. How far can you see on the globe? What would make your globe falsifiable? You have an unfalsifiable belief system where you agree and disagree with your own model at the same time. This is called cognitive dissonance.
The oil rigs and the wind turbines are 10 to 18 kilometers away. At that
doesn't matter.
Distance, the condition you're running into
those are
the
markers.
curvature of the Earth.
No, those are markers. The curvature of the Earth is unseen. There's no curve there. You said it's the geometric curve of the Earth can't be seen because there's an atmosphere in the way that blocks your curve. But you still see the curve anyway because it's loomed over and around a curve that you also don't see.
Okay, can you summarize this for me?
Yeah, that your model is an unfalsifiable belief system where you agree and disagree at exactly the same time.
I'll summarize it. There's no measurable curvature.
Okay, mathematics, bro. Go back to kindergarten, bro. Alright. Yeah, wait.
You
back to kindergarten.
Why?
Yeah,
what do you mean?
What are you talking about, bro?
What do you mean? What am I talking about?
Mathematically cool. You've been pretty cool up until now.
No, because he walked himself into another
No.
contradiction.
Wait. No. I'm not talking bad about you guys. Only him because he keeps yelling and screaming at me, bro. Like.
No one's yelling
what's your
at
name?
you.
Like Crit. I'm not antagonizing. Whoa, he kept like shouting at me, bro. Didn't you hear, bro?
No, I'm not shouting at you. What?
No, I'm not saying you. I'm not saying you.
Oh, okay.
I'm not saying you, bro. No. I'm not angry or antagonizing you guys. I'm just listening. Don't think I'm rude to you, bro. The other guy he kept like shouting in my ears, bro. Met the tricks. Met the tricks.
The third grade.
I feel like he doesn't understand what you're saying, Crit. Have him steel man your argument.
But no, I think he wants to. It's okay. Like new guy here.
Bro, it's so damn late, bro. I'm lost.
Okay, yeah. I get it. So just how about this? You get the last word. Say what you want to say, and we can call it that. Call it whatever.
Okay.
Well, so what do you want to say?
Okay, so you want me to give a strong argument?
No, whatever you
my
want
last.
to say. It could be like, "Hey, a good talk, guys. I had a blast. I'll come back again." Whatever you want to say.
Oh,
Anything
like
you want.
that. Oh,
Yeah,
like that. Okay, so yeah, I mean, it was like good talking with you. Like even if I disagree with you or you disagree with me, like I admit at least we like talked and tried to understand each other, right? Like, I mean, like to be honest, like guys, I listened to you more. Like apart from the discussion, right? Like before we began the discussion, I tried to listen as much as possible to you guys. You do understand me, right?
Yep.
Like you guys can be like completely honest if you think I was like keep breaking your words or like sentences or like if I didn't try to listen. You can be fully honest. Like I did my best to like I mean keep the discussion polite as possible. Yeah.
We agree.
Like,
you did your best.
So that's fine.
Yeah,
It's
like not
okay.
that. Yeah,
it's fine.
Like define okay. Like did I like at some point like was I annoying
mean,
or
we'll do it. We'll do it at the time. We won't.
Yeah.
There's no reason to like discuss it now. Like just
Yeah,
like address it when it happens. If it happens, if something happens that we like not happy with or disagreeable with, we'll let you know in the moment at the time.
Yeah. But it's more like that, like during the discussion that I wasn't like disrespectful or stuff. Like till like maybe 2 minutes
Yes,
ago.
you were disrespectful. You said
What
you
did
were
I say?
You need to go back to third grade. Like, don't make.
I didn't say you are. I didn't say you are. I didn't say you are. I was only saying Matrix.
Matrix. Yeah, he's directed towards Matrix.
Yo, Globe Student, I didn't say it to you. Oh, my bad, bro. I mean, if you feel offended, I mean, I'm not trying to jump to conclusion, but like,
I'm not offended. I'm just telling
It was
you
you
what
that
you
was
said.
offended. That's why you said it in the first place.
I mean, if you didn't shout, if you didn't shout like that and you call me stupid.
Am
like,
I shouting now?
I mean, not now because like now you're controlling your voice.
Because I haven't changed anything.
You only talk when you like. I think you.
Have a nice night. See you later.
Whoop, whoop. There's the tone police.
Yeah.
Yeah, some people just don't click. It's fine, but there's no. If I think once he comes around more, he'll realize how people talk and that there was nothing special about what Matrix was doing. It's the same tone and tenor he always has. Like I think this dude just isn't used to certain people.
Half of the problem, Crit, is he kept talking through me and thought he was going to power through. That was 99%, not even half, it was 99% of the problem. He wouldn't shut up for 10 seconds, instead made it a minute and a half ordeal, when if he'd have just shut up, got the message, and got on his way, it would have been game over.
Oh, that's a good point, too, yeah. Just would have like, all right, shut up. Shut up, go lay down, listen.
But I liked your Steelman, Crit.
Bro.
You were talking about the non-horizon horizon. That was pretty good, man.
I mean, bro, you're saying like I didn't let you finish talking. You didn't let me finish talking. You went through me.
Oh, you're still here?
Matrix. I was talking to Matrix. Matrix.
It's sometimes part of the deal when you're in someone else's room that's being moderated.
I mean, yeah, okay. It is his room, but I mean, can you deny the fact that he kept talking to me then?
Have a good night's sleep. I hope you have a good morning when you wake up.
Thank you.
Yeah, we don't.
I don't know if it's sarcasm.
We don't really need to focus on how the conversation went and like people's character or anything like that. It's kind of meta, Like,
yeah, to be honest, I admit. True.
When we got into the like nitty gritty of the subject matter, then you're okay. I mean, you may have been interrupted a bit, and you may have interrupted other people a bit. Like it's just part and parcel of how conversations go sometimes.
Yeah.
I mean, like just relax, man. It's cool. You can come back. It's okay.
Yeah,
You're not banned.
I'm
You
I'm
didn't get
relaxed.
muted.
I'm relaxed.
It's all good, man.
No. Thank you. That's more like I was in the way of like I want like feedback like that. But I'll go.
Just before you head off, right? I
Oh,
just
yeah.
posted just one extra little video in the side chat.
Yes.
Okay, so
Wait,
the other one,
yeah, go ahead.
the other one that we looked at was from 8 feet height, right? But in this
Yeah.
one, he lowered the camera down as close to the water as he could get it. Okay, it's about, let's say, it's like
Yeah.
1 foot height now. Okay, and he zooms in on the oil platforms, and if you have a look at the GIF, it actually pauses and shows a picture of the oil platforms.
No.
Right, so even from this low height, just above the surface of the water,
Yeah,
we
this
can
is-
still see the horizon is beyond the oil platforms. It's after them. So if you think that the bottom is hidden, right? How can the horizon? This is the only thing I want you to think about, because this is the only thing I had a problem with you saying, right?
Yeah.
If the horizon is blocking the bottom of something, how can the horizon be beyond the thing that is blocking?
Yes.
Okay, that would be impossible
Yeah.
on a globe.
Okay, so is it okay if we talk about this another time, because I have a feeling
Yeah,
that
man.
we will go on and on and on, and that it will then. Oh yeah. Besides that,
Yeah, that
if
was
I'm sure
the
you
last
want,
thing I wanted to say anyway.
Also, you want to send like a YouTube video, I think. I'm not sure.
I already sent it earlier, but
Yeah?
look,
Did you
I'll
send it in DM? Like, let me see. Send it to
No.
me like privately, and then I'll watch them, and then I'll
Yeah.
see it myself.
All right, cool.
All right, man. All right. Have a
Catch you
everyone
next
have
time.
a nice
I
evening.
appreciate. Yeah, you too.
Yes.
You too. Catch you next time.
All right.
See ya.
Have a nice evening, everyone.
Yep,
Ciao.
hasta luego.
What?
Yeah, DJ.
Yeah.
Or DJ. Can you
GG's. GG no
open
worry.
can you open the mute in such chat?
Yeah.
See, I've got a question why someone was side chat. That's normally an indication that something stupid's gone down and you were blocked in side chat to prevent yourself from getting TOS banned.
I was muted like 3 days.
Probably.
Yep. Maybe they forget.
Well, I was muted for 4 days. Gotcha.
Yeah, Harmoody wouldn't have posted anything bad. His cognitive dissonance gets annoying sometimes. That's probably all it was.
20 says your other mate does a reset, comes back and you have exactly the
Oh,
same
yeah.
conversation that you've just had for the last hour and 43 minutes.
Dude, he reset
He's been in before.
even before he left. He'd already reset multiple times.
Oh yeah.
Hey, I know it's a little bit late to say this, but a shout out to Mrs. DJ for letting him stay in here with us.
Oh yeah, she got annoyed at me for saying that. She got annoyed at me for saying that she'd got it for saying to you guys that my wife's getting annoyed at me. She's like, I wasn't annoyed at you.
Now you're in the doghouse.
Just remember, ladies, sleeping on the couch is just like camping.
Yeah, you can. People pick up wife aggro all the time.
We appreciate her patience and her grace.
I still don't think he understood what Crit was saying about the so-called refraction.
He had no idea, mate. He had no idea what DJ was saying. No idea what T-Dub said. Absolutely no idea what Crit said. And he definitely didn't want to listen to me.
Yeah, I agree.
Since you're here, did you want to go over what you were talking about with perspective?
Yeah, I realized what Crit was saying, how it was a moot point, but I do think it's overlooked at the same time.
No, it was a good point. I think it was just too much for him at the time.
Oh,
You know,
I get
I could be wrong too. I mean, like sometimes
yeah.
I think it when you started having him visualize something else, another line of thinking, I thought he was going to pop, and he got close to it, but he pulled back a little bit.
Well, when the guy was telling him to notice how the bowling ball appears, gets smaller, but we all know the bowling ball is the same size the whole way. As you're watching that bowling ball go down the lane, you're looking up to follow it. Your eyes start from where it lands, and it looks up as it goes down the alley. You know what I mean? That's perspective. You have to look up. And the reason is because it's getting further and further from you, just like the guy said, makes it appear like word he was looking for is symmetrical, so it symmetrically gets smaller and smaller. Whole object gets smaller and smaller. But the ground at the bottom is the only thing that deteriorates or shortens that angle. You know what I mean? There's nothing above the ball. So the ground is the thing that's going to be the first thing that causes it to disappear on a flat plane. Perspective will do that.
But I don't think he would understand convergence into the horizon.
There is a loss of information where two things meet, right? Two objects meet with greater distance and optical limitation. There will be loss of information visually, so optically.
Yeah, that's the
with
angle.
enough distance. Yep.
That's the angle of the sight, and the angle is derived from the ground. The only thing that can block it.
Right, where they're meeting.
Yeah.
It's the point where those two objects are meeting, right? So like
they're meeting the whole time.
two headlights, right? So that's going to be horizontally in that instance, right? But two headlights on a car, right?
Yeah.
With enough distance, vertically will seem to meet and become one, right?
The angle will become so small.
Right.
There's a limit in which.
So they'll appear to meet horizontally.
Yes.
Right?
Yes.
But in the case of ships on the horizon or whatever like that, that's going to be vertically because they're oriented. They're oriented that way.
Derived from the horizontal.
One on top of the other, right? One on top of the other, not side by side.
Yeah. When they say the ship disappears bottom up because of the curve, they have no idea. They don't even realize that would happen and does happen on a flat plane. Bottom of it will disappear first. The ground is the only thing delivering the angle of sight. That's where you get your angle of sight from, is the ground. The very thing that will obscure the object before anything else.
Right, like looking down the hallway, so you've got convergence on all sides. You've got floor, ceiling, walls, right, converging to meet. And there'll be loss of information. You won't be able to see right to the end and to be able to tell like that there's doors and windows or lights and fittings, like nothing, none of that.
Well, even in that they'll call it curve, right? They'll be like, well, yeah, but you're making a hallway so long that the curve of the earth still comes into effect. But when you draw out the lines, all the lines of that hallway are straight. Every single one of them. Not one of them's curved. They don't realize that. And as you start from your feet, in order to get to the end of the hallway, you got to look up. So to me, looking up is important. That is perspective.
Well, yeah, there's the light path, and then there's the conceptual straight line from eye to object.
Right. You know how artists draw a hallway. Well, Globers will tell you that hallway is converging to the curve of the earth. Every single line in that drawing is straight. On one line is curved. So the straight lines are giving you a perspective curve, I guess
Right.
you
So
could say, even though
even
it's
in
not curved.
even professionals like surveyors, so basically going to treat their line of sight as a straight line, right? The way that the light's being received by the eye, right? They're going to, from object to eye, they're just, for all intents and purposes, practical purposes, straight line, just distances, that sort of thing. Rarely are they going to want to involve refraction and all that sort of thing, right? Because they're not going to be operating over those sort of distances where it's going to affect it significantly enough to even matter, right?
Yeah, and my argument is, maybe I'm beating a dead horse here, but my argument is they're treating those lines as if they're curved, even though there's not one single line in that drawing that's curved. And those drawings are also how we see things, because those artists are trying to draw exactly what we see. Does that make sense, or am I just babbling?
That's
No,
all
you
right.
got it.
I
Yeah,
mean,
you got it, man.
there's a lot more that we could have gone into with that guy too. I mean, there is so much to take into consideration, right? There's surface conditions, there's air conditions, visibility is a factor. Then you've got
They're
things
calling
like
those straight lines
diffraction,
curved.
and you got light destruction, right? You got like DJ was talking about, I was saying to him, like the conditions necessary to make such observations, right, with such clarity, right, don't exist in the air, meteorologically, right? They'd have to show that it does, right, that it can refract to that extreme without information destruction, right? But like DJ was saying, like those instances where we're seeing, out of the ordinary light distortion, right? You'll see these dramatic effects flipping, these really extreme miraging effects, like
I just noticed
inverted images and mirrored images.
Hey, just quickly,
I
check out.
just noticed somebody posted something on the chat. It's explaining exactly what I'm trying to say. Notice how those squares, they converge to the observer, you looking at them, and once they get so far away, they come to a vanishing point. That's the angle of sight. That's your minimum. There's no angle that your eye can see beyond that. But all those lines are straight,
Yeah,
and they're calling.
but I don't think that explains these zoomed in images where it looks like there's half a boat with a horizon cutting it in half. You know what I mean? I don't think that explains that.
Yes, it would. It would. Picture those people that one image has standing clear out there. Now picture them up close on the standing.
I don't think it
standing.
does.
Hold on. Picture them standing on the first square of the picture.
It could be a factor involved, but you couldn't solely just rest upon that being the reason.
Let me finish arguing.
I'll nuke this motherfucking place.
If you picture those people standing clear out in the distance on the very first square.
A nigga was talking about how he need to get nut in a bitch's pussy for Jesus.
I'm just saying, the symmetric
What was that?
symmetrically get smaller the further they get from you. Eventually, it's going to get to an angle of sight where you can no longer see them. And because the ground, they pop up, top of them is above the ground. The ground is what is limiting the angle of sight. So, of course, they're going to disappear bottom up on a flat plane.
How do you explain the GIF that I posted?
That's exactly what's happening, right? The Earth is flat and they disappear bottom up, right? So what I'm saying is actually happening. Because the angle is from the ground. That's where you're getting your angle from.
Yeah, but the top of the boat's not getting smaller in size.
Yeah. You can see the top at the very last, right? Because there's no ground at the top of the boat. Ground's at the bottom of the boat. Like where the squares are sitting, that's what the boat's sitting on. So as the squares disappear, that's where the boat disappears, bottom.
I think you should look into thinking refraction.
What are you talking about? Did you not just hear what I said?
Yeah,